start the meeting. And you can have conversation during the coffee time. Thank you very much. My name is Jan, and me and Kochmaniuk will take care of this session. The first one is virtual. Sankalp Basavarai will talk about the log4j debacle. And before the Sankalp goes on, I would like to ask Tom Strix. He's also a presenter. If he's in the room, Tom, if you're in the room, please upload your slides. Otherwise, you will be talking with blank screen behind you. Thank you. Sankalp, stage is yours.
Let me just. You guys hear me all right?
Yes.
Awesome. Thank you. Thank you. Good morning, everyone, all the way from India. Hope you had your morning coffee. So we had some interesting discussions yesterday on, layer 3 stuff. So what we'll do in this session is move a little up on layer 7. So we'll examine layer 7 security. But before we do that, a little bit about me. I'm Sankal, based out of India, senior architect in Akamai. Over my tenure, I've worked with almost 300 plus companies across worldwide on technologies like internet security and web performance. So a brief overview on the agenda. So in a nutshell, what I want to do in this session is to demonstrate how internet security is evolving and also how we must adapt to it, right? And as a beautiful use case for that, I'm using the log4j vulnerability as an example. You might have heard about this in news or Twitter handles. It's probably the worst that we have seen in the recent years. So we'll look at what exactly is this, how did it work, and a few insights, my personal insights on it, and I'll also finish it with a few recommendations of mine. So before I dive into the specifics, let's look at the brief timeline of events to set up some context. So what happened is, on the last week of November, a security researcher discovered a vulnerability in the Java utility, and he logged it, right? So we do that. It's perfectly normal. But the storm was kick-started on 9 December when somebody exposed this on Twitter, and it was only there for, I think it was only there for 5 to 10 minutes, and it was later deleted, but that was all it was required, and then started the whole mayhem, right? So this vulnerability went haywire. Attackers started exploiting it. And it was so bad that even the CISA director, Jen Easterly, went on record saying that this is the worst that she has seen, right? She went on record to say that. She gave out an official statement. And of course, it was given a code name 44228, and there were three parties involved, primarily three parties. There were, on one side, attackers who were constantly trying to evolve to evade and exploit this at the maximum, and then there were cybersecurity companies, or even the companies who were trying to thwart it, and then there was Apache, who was trying to release patches and to address this, right? So started the cat and mouse game, right? And it went on for a while, and it went from worse, bad to worse, right? To a point where within a few days, we at Akamai were seeing about 2 million attacks per hour. That was the intensity of this attack, and it's just one company. I mean, similar reports you can read in Google or Mandiant or FireEye and other companies as well. But even to this day, and this has been like what, 4 or 5 months, even to this day I see logs on a routinely basis on, attackers trying to exploit this vulnerability. And to quote my personal example, my sister's website, which hardly gets any visitors, probably 100 visitors per month, she even saw, log4j attacks against her website. So that shows the massive, or the pervasivity, or pervasiveness of this attack. Moving on. So what the heck is log4j, right? So let's see what the heck is log4j all about. Full disclaimer, I'm trying to condense the information, the technical information, into layman, so that, for the benefit of larger audience. But if you have any questions, chat, or you can connect with me offline. So what is log4j? Log4j is a Java based logging utility, right? So whatever the codes that we run on Java, everything has to be logged, right? So this is one open source utility which is very famous, and it's also, helpful in debugging purpose, or event logs and all that stuff. So it is open. Since it's open source and very versatile, it's used very widely. One of the important features about log4j is known as lookups, right? What is a lookup? Lookup is nothing but an expression. I've given an example there. I had this whole interactivity built in the PPT, but I think in this paradigm, it's showing at one go. But anyway, lookup is nothing but an expression. So when you include an expression, what this log4j will do is it will read that and replace it with whatever the expression says. For example, in the first line at the right side, I've written date something, all systems good. So when log4j reads it, it will replace that with a date, and it will say all systems good, right? Very simple, right? And one of the uh, powerful features of log4j is you can pipe it or tag multiple such expressions together. For example, in the third line, I've highlighted there, the lowercase current user is something something username. So I'll take the username and I'll make it to lowercase, and log4j will log it as the lowercase current user is administrator. All of these will go into the logs, right? Now, if it was only this, we wouldn't be having this conversation. It was, powerful, simple, all good. But the problem started with a thing called JNDI. Now, what is this JNDI? JNDI is nothing but Java naming and directory interface. What it does is it gives the capability to this utility to go out and talk to certain external directories, be it like, DNS, be it an LDAP server, or even the Java environment for that matter, right? So it gives the power to go to the external world and interact with directories, right? And the way to summon this genie, let's call this a genie. The way to summon this genie is using the expression JNDI. So I've given an example there. The current mail host is JNDI Java something. So the moment the log4j utility reads it, the parameter JNDI, the genie is summoned, and JNDI will go to the Java environment and probably replace that with the configuration server file or the environment host name, right? So that's how it works. Now, fair enough. Where is the vulnerability? Because it's clear cut, it's powerful, everything is good. Where's the vulnerability, right? So let me show you that. Let me demonstrate that with two examples of how this can be exploited. And that gives you a sense on how easy it was to exploit this vulnerability. The first is a data exfiltration vector. So assume that Sankalp is a bad guy. I'm a bad guy. And what I do is I go and register a website called malware.example, right? So now what I do is I write an expression like I've written in the left side, which says JNDI, go log the AWS secret key, append it to malware.example, and then whatever the host name that you get, do a DNS lookup for that, right? And I smuggle this expression brute force. I mean, I smuggle it to AWS, I smuggle it wherever I can. And if you think that's smuggling this expression to any environment is difficult. It's actually pretty easy. You can include it in HTTP headers or a URL or some post body or something like that. It's very easy, right? So you just have to smuggle this in some header or something. The moment the log4j reads this, right, immediately the JNDI would get summoned. It would take the AWS secret key. It will append to malware.example.com. Since I own that domain, when it actually does the DNS lookup, now I have the AWS key or the secret key, whatever, right? And I know where it came from. So I know where it came from. I have the key. I have the key, so I can easily you know, compromise that data center. Example number 2, remote code execution. So for this example, same thing. Sankalp is a bad guy. He owns a domain called malware.example. Now I write an expression JNDI, do an LDAP query on this URL, right? So that's how I say, and I smuggle this again. So JNDI being completely naive, it will send out a LDAP query to a domain which I own. And then I reply back, hey, you might want to check out this URL. There's something probably interesting for you. And JNDI again follows that URL, downloads a virus, gets compromised, right? It was that easy, right? This is just 2 examples, but you can just, think wildly is what I would say. Now I know what you're thinking. If JNDI was the problem here, why did we just not look for the expression and just block it, right? Just block the JNDI. Wherever you see JNDI, you just block it until everything is fixed, right? Makes sense, right? But here's where it gets really tricky, right? Here's where I want to share some insights which I experienced that day. If it were to be that easy, probably we could have easily blocked it using a regex pattern or something and call it a day. But what happened was, once we did that, attackers became even more smarter, and they were getting smarter and smarter by the minute. I mean, it was chaos. It was like 5-day 24 by 7s. We had architects, we had supports, we had engineers all working. Someone is looking at Twitter handle, right? Twitter handle, someone is posting, hey, here's a way to bypass their logic, right? So it was mayhem, right? So why was it mayhem? So let me share that. If you block JNDI, look for the expression and block JNDI, that's not gonna do the job, simply because the attackers found new ways to masquerade it. And I've given an example there. The first expression, if you look at it closely, I have not written JNDI in the expression. I'm calling J in a separate parameter in an uppercase. And when the computer or the Java utility, when it actually reads it, it eventually lands on the same expression. But it's just that I cannot look for it in the initial when I'm scrubbing for that parameter, right? So that's why it became difficult. And what was happening is we were building regexes uh, to thwart such attacks, but then they came new, right? It was announced real time, and then we even saw logs where, even though it was not announced on Twitter, lots of experimental minds in the attackers, so they started coming up with new ways. So that's why it became very difficult to avoid or to thwart such attacks. Now comes the big question, how bad was this vulnerability? If I'm taking one use case, I mean, we come across lots of malware every day, but why am I talking about this? How bad was this vulnerability? And I've collected a few excerpts. You can take a look at it, and that will give you a sense on how bad it was. I mean, the Belgian Defense Ministry was shut down, right? FTC, the Federal Trade Commission, came out and warned companies that you should not be compromised. And mind you, this is the same commission who penalized a certain company for 700 million because they got compromised, right? And there are strict diktats, strict rules by regulating agencies, that warning sent out to companies that you should not fall victim to this, because that would mean uh, loss of information, and that's a bad place to be in, right? I mean, imagine, I was talking to one of the CEOs the other day, and he casually mentioned to me that he started his company in 2012. but somehow it didn't kick off and he's restarting it again. That's a 10-year gap. And I asked him what happened, right? When you had the idea, why did you wait for 10 days? And he said, a ransomware attacked my company back in 2012 and I had lost all information. So I had to build everything from scratch. Right? That is the impact that such attacks have. The financial impact, the impact that a brand takes, the beating that a brand takes, it's colossal, right? Again, this must be a one-off event, right? And that's not wrong. I mean, that's wrong. It's not a one-off event. It what we have seen in the pandemic is it's not only changed the way we behave in normal life, but also the digital life as well. I mean, I'm taking the data of 2020, and you can almost say see there that there's almost 80% increase in digital usage, and we are living in 2022, so you can only extrapolate it, right? So what does this stats tell us? The stats tell us that the attack surface or the points where the hackers can exploit have increased exponentially. And not only that, the Log4j is a classic example of how the attacks are evolving. No longer are that one virus where you had an antivirus and you pick it up using signatures. No, that's outdated and it's probably dead, right? So now attacks are evolving thanks to social media and the digital adoption. So the penalties are massive. What is the solution, right? One word: zero trust. And if you haven't heard about zero trust, it's not a new concept. It's been there for a while, probably a decade, but it hadn't picked up pace. And for those of you who don't know what zero trust is, it's certainly not what I'm showing in my slide. Zero trust means um, authenticate, authorize, and examine everything. Don't take anything for granted. Don't trust any entity and say I'll accept this incoming connection, or this is an employee, it's okay. No, you have to, by default, have a mindset that you have been compromised by default, and you have to authenticate and authorize everything or examine everything. So that's the way to approach. That's what zero trust is. In line with that, I have jotted down 4 security recommendations. But before we even go on to that, I want to explain a fundamental principle when we are talking with security, right? So the attacks are constantly evolving, just like the coronavirus. There is always a new variant every day and all that. How do we stay ahead of the curve, right? So that's important. And I'm taking the same example of COVID. How are we staying ahead of the curve in terms of COVID? We are testing insanely, right? Why are we doing that, right? So to catch the new variant as early as possible, right? And the same applies to security domain as well. We need to catch the attacks as early as possible. So back in the day, we had just one firewall sitting at our data center, which used to, scrub the traffic or TLS connections or whatever, right? All the traffic that was incoming, but gone are the days. You cannot afford to have that simply because it's way too closer to the chest, and these firewalls are, practically dead, right? So the way to approach is catch him as early as possible. Now, if you ask me or any IT security architect for that matter on how early are you referring to, my answer would be catch it at your browser. If it's possible, catch it at your browser, catch it at your laptop, right? Ideally, that would be the best case scenario. Don't even let that flow into your data center where all your information is stored, right? So, but of course, that's not possible, right? So we need to have checkposts in place, right? So we need to have some sort of cloud security in place which will weed out the attacks even before they reach to the data centers. But does it mean that it's a foolproof solution? No, that's not foolproof solution. And that's why we need to build our security immunity at at the origin or at the data center itself, right? So I have devised in line with this theme. I have given 4 security recommendations, very what do you say, on a very high level. I've given that. So let's discuss it. The first one, following the same theme, catch him early, right? So the other day I was giving a talk on zero trust, and I talked about how zero trust is applicable to IT and everything, and an interesting question came, and somebody told that, don't you think that we should maintain the same thing for the code as well? What about the code that we wrote? Right, websites and all that, right? So don't you think it should be zero trust policy should be applicable that too? I was like, yeah, that's actually true, right? Because security starts at the machine where you're, trying to access the site, right? And classic example, uh, look at the snapshots that I've given. It's a popular government site which I was analyzing 2 days ago. Um, it's an important site, and the login screen is sitting there like a duck, you know, waiting for a clickjack attack, right? So I tried to simulate a clickjack attack and I was successful, right? It's an important site. So my firm belief is there's a lot that can be done at the machine, at the client level itself. So one of the examples is DNS, right? Maybe go for high secure, more secure DNSSEC or DOT protocols. Not DOH. I'm not a big fan of DOH, but DNSSEC or DOT if you're owning the domain, that is. And even I see companies which are still using SSL, and it's hard to believe. I work with so many companies. I see that at least 25-30% of the companies demand that we don't block SSL, right? So that's a concern. Look, it always starts with DNS and then comes SSL, right? So get these 2 things right. And after that, there's this one recommendation I would like to highlight is CORS. If you have not heard it, CORS is a way to tell the browsers to behave, right? It's complicated to implement, but if you implement it properly, it's just a bunch of headers that you're saying. For example, the snapshots that I've given there, if you had just sent one CORS header to the browser, then probably this would have been avoided. This clickjack attack would have been avoided. But it's a little bit tricky to implement. That's why people don't go for it. But do it, spend some time on it, spend some resources on it and implement it. And the attack vector or the attack surface reduces significantly, right? Your page will no longer be prone to data leakages and all that stuff, right? And the second is build a checkpost. Now the checkpost may be a proxy, it may be a CDN, it may be a cloud security firewall, whatever it is, not the traditional firewall, but the cloud. Again, the checkposts are not fully effective, but they can sit and scrub and weed out at least some of the traffic. They can do a much deeper inspection than what your firewall at the origin could have done, right? And one recommendation I would like to highlight is um, it's not only enough to have a cloud firewall, but it's also essential to have a sandbox or a honeypot model. So one of the things that I see in the real domain is not a lot of companies have honeypot implementation. What is a honeypot? It's just a replica of your site. So when an attacker tries to attack your website or your API or whatever, he or she will automatically get redirected to this replica, and that attacker will think he is operating on the main side, but you on the back end would be getting all the attack vectors or the attack information from the back end, right? Complex stuff to build. Not a lot of companies go for it, but it's if I'm talking in terms of getting ahead of the curve, this is the best way to do so, right? Have something called as a sandbox or a honeypot, so that what happens when bot attacks is at the peak right now, right? DDoS attacks and all that, right? When you block something, you look at the IP, or when you look at some vector and you block it, they will know that this has been blocked. They will come up with another way, they'll find another loophole and again attack you. And this is a common pattern in the security domain, right? So if you block one thing, they will find another way. So honeypot is a holy grail for such scenarios, because the attacker will think his attack is success, but you are getting all the information or the traits of the attack itself by sitting at the back end, right? And having a good page and intermediary proxy, would that do the job? No, right? That used to work like 10-15 years ago, but not anymore. One of the important aspects that we should be mindful of is the way the attacks are evolving, right? Earlier we used to have a virus, but nowadays these threats are moving inside an organization, inside an enterprise, inside a company. A classic example: Twitter hack, the crypto hack. Elon Musk's Twitter account got hacked, and he posted a bunch of stuff, and a lot of celebrities um, Twitter got accounts got hacked. When they did an RCA, what they found out that the the cause for that was probably an employee that got compromised. And I have added another snippet which I think I picked just last night from a news item. An IT admin got pissed off by the employer, wiped off the data, right? So the no longer are the attacks external, but they're moving inside the organization, which becomes even more difficult to weed out, right? Suppose your employee is browsing something, some site which is not supposed to, and that has some sort of virus, and that's enough to infiltrate your organization, right? I mean, for the attacker, he has to be right only once, but from the other side, from the defender perspective, we have to be right always. Every asset should be secured, right? And most of the trend that I'm seeing these days is companies going for MFAs and thinking that they are secure, but that's not the case. It's not enough, right? MFAs regulating a bit of access in the Active Directory is certainly not enough. We need to take it up a notch. By the way, MFA is proven to be as easily hackable as a normal username and password, right? So we have to stay ahead of the curve again. uh, Having an MFA algorithm which sends out an OTP is definitely not enough. We have to look at the algorithms which or the standards or the methods which are used to generate these OTPs, right? So I think FIDO 2 is one of the best standards that is available right now. But again, we might discover a loophole on it someday, but we have to always have, stay ahead of the curve. And the last recommendation, right? If I follow all three tips, will I be secure? Not really, right? So there will always be these 0-day vulnerabilities, attacks, which will impact you. So we, again, zero trust philosophy is that assume that you have been attacked, right? So how should we build our infrastructure? So that's where this micro segmentation concept has taken birth. It's basically nothing but a spin on the VLAN which we used to have, right? It's just VLAN on steroids. So what we say here is, instead of the traditional one company, one data center, and there are units, build individual units which act as separate entities and shield them, such that if one entity, one Active Directory gets compromised, it will not spread. It's a containment measure, right? And it's, of course, we have done it with VLAN, but this is nothing but VLAN and steroids. So we are regulating the chatter between two VLANs or two networks, and who has access to what in the other VLAN. So we are regulating or you know authenticating every um, packet that flows. That's it I had for today. It was a short presentation, but my thought process was that to put it in most layman terms on how security domain is evolving. But if you have any questions, you can put it in chat. I think we have some time, or you can also connect with me on LinkedIn as well. I've given the handle. Any questions?
Yes, me.
Wait. Wait. Okay, go.
Hi, Jelte Jansen, SIDN. These are all very good tips, but I want to talk a little bit more about Log4j itself. Isn't the the microphone is being adjusted? Yes, thank you. So isn't the fundamental problem of the Log4j issue something we learned 30 years ago with SQL, that don't parse untrusted user input?
Right. And it's a funny thing, right? I mean, we have all these contingencies in place. I mean, we know this stuff, but there's always, they call it 0-day vulnerability. I mean, I think a couple of weeks ago, Chrome announced a 0-day vulnerability. I mean, it's good when we don't know it, but once it's announced, and they're like, people are like, okay, we goofed up. So the point is that we'll always goof up. There will always be that one bug which is, you know, um, what do we say, unexplored, and somewhere down the line someone might catch it, so we have to be ready.
Right, thank you.
And I have a
If there are
question in
no.
I read the text question in the text chat.
Okay.
It's, well, Daniel Karenberg from Rapid CC is asking, does it mean that better build all our IT backup again from scratch?
if we are talking in terms of microsegmentation or even zero trust, yeah, and that's why most companies don't go for it. You know, I've seen some hesitancy to, you know, reject the entire IT, because I mean, if I'm pitching this to Amazon and say, hey, you have to change the whole, uh, you know, the way you work, I mean, of course, it will be met with backlash. But then again, the cost of, you know, being compromised is way too high. So we might as well see what we can do, right? At least if not full, at least some parts we can fix.
You want to ask question? Please.
Hi, Q Meisel from Glauca Digital. You said that it's proven that multi-factor authentication is as easily hackable as a username and password. What do you mean by that? Because that makes no sense to me.
Right. So the traditional notion is that, you know, the OTPs or, you know, the push tokens are safe. Once you have that on your you know, website, it cannot be hacked. But that's not a foolproof solution. I mean, there are
Yeah, I
many
understand
ways.
it's not foolproof, but surely it adds. Surely there is some value added.
Yeah, it does add value. Yes, it does add value. Probably it will avoid some attacks, but it's not foolproof. That's what I meant.
Okay, thanks.
Okay. Thank you, Sankalp, for this very good presentation.
Thank you.
Well, I read it from here. Okay, we are glad to hear our next speaker. That's, excuse my reading, Christian Harent from Interlink. You have your short presentation. You're welcome.
Yeah, thank you and good morning. Thank you for joining my talk. My name is Christian. I'm from Interlink and I love to automate all kind of network related stuff. So I'm going to show you to you today what you can do with the RIPE database with some automation to fill it in with data from Netbox. So let's get started. Yeah, what is the problem? Yeah, depending on your size of your organization, you are dealing with hundreds or even thousands of prefixes. And on the other hand, you have these RIPE policies. So you have to document all these prefixes you have in the RIPE database with all these policies, which we all love to do. So this is how your RIPE database entries look like, right? Or is it more like that? And this is your facial expression when the next RIPE RSC, the assisted registry track, is coming in and you are praying to pass. Yeah, let's face it. Keeping these objects up to date isn't much fun. It's prone to errors. You can forget about something. It's manual work. It's boring. So there must be a better solution to this. So we have looked around and yeah, we have discovered, we have Netbox, which is our single source of truth, where we document all of our prefixes. And what's good about Netbox, it supports webhooks. In case you don't know, a webhook is a HTTP request sent to a predefined URL whenever you create, update, or delete an object. And then we've looked at the RIPE database, and it's offering an REST API as well. So nice. Just put the URL of the RIPE database API into a Netbox webhook, problem solved. Okay, it's not that easy. It's great to have all this data, all of your prefixes documented in Netbox, but the RIPE database needs additional information like admin contacts, abuse contacts, maintainer objects, organizational objects, you know it. So how do we bring these two together? We have looked around and is there any cool open source tool we can use for this? But we couldn't find any. So we have developed our own solution and we call it RIPE Updater. What do we want to achieve with the RIPE Updater? The most important part is to automate the INET-num and INET6-num objects, which are the most frequently updated objects in the RIPE database. So what also would be nice if you add some validation to it. We do not want, for example, to document the RFC 1918 addresses. This is our private stuff. We will not put it in public RIPE database in the internet. We also want to check for overlapping prefixes. That could happen when you resize or split a prefix. So we want to take care of this. The next step is very important for us. It must be very easy for the administrator to document these prefixes. So all the additional data should be based on templates, which you just can select with a drop-down list in Netbox. What also would be nice to get some backups before you delete or overwrite an object in the RIPE database. And lastly, yeah, you get some email reporting so you can keep track of what's going on. So what do you need to run the RIPE Updater? Yeah, of course, you need Netbox, at least version 2.4 or later. You add a webhook and some custom fields. And two of the custom fields I want to highlight here. The first one, it's stored in the prefix and it's called RIPE report. It's a Boolean and it's basically just determining if you want to have this prefix documented in the RIPE database or not. And the second one is the previously mentioned drop-down list of all your templates. So what else do you need to run it? Of course, you need RIPE database access with a maintainer password, and you need a platform to run this on. We have chosen Docker for that, and I think it's the most easy solution, but you can use whatever you like. It must be able to run Python code, and you put a reverse proxy like Nginx in front of it, and you are good to go. So let me give you an example. Here I'm creating a new prefix, and I have set the RIPE report to true because I want this prefix to be documented in the RIPE database. The next step is to select an appropriate template from the drop-down list. And when I now will create this prefix, following things will happen. Yeah. Netbox will send a webhook to the RIPE Updater containing all the data you have just put into the prefix. The RIPE Updater will see the template and read it from the file system and sees there all the additional information we need. Yeah. In parallel, we do the overlap check, which is basically go into the RIPE database and check if there is an overlapping prefix. And if we have found an overlapping prefix, we will then check back with Netbox, which is our single source of truth, and see if this prefix is also present in Netbox. And if it's not, it is considered to be deleted, but not before creating a backup of it. Now we jump back to our main part, which is to document this newly created prefix in the RIPE database. And the RIPE Updater will mix the information from the prefix, from Netbox, and the selected template together and put it into an API call to the RIPE database, which you can see in the top right, bottom right. Finally, you will receive an email so you can keep track of what's going on. So let's recap. With the RIPE updater, your database is always up to date and it's consistent. Sorry, it's consistent, and you can be as relaxed as this guy when the next RRC is coming in. One thing I want to mention here is you can now batch process all of your inetnum objects. For example, you want to add a new contact. You just put the contact into the template and then just select all prefixes in Netbox, click on mass edit and hit save directly without any change. And Netbox will trigger a webhook for every prefix, and the RIPE updater will make sure every prefix is up to date in the RIPE database for you. So, but one question remains. That is great, but why am I telling you all about this? It's because I'm very proud to announce we are going to release, or we have released, the RIPE updater on GitHub. You can check it right now on the URL, it's in the bottom. And so you all can have your RIPE database entries automated with the data from Netbox. But first, I want to thank you for your attention. And yeah, do you have any questions?
Thank you very much. That's cool.
Thanks.
I'm using Netbox. Excellent stuff. Yeah. Who's first? Go.
Hey, Ondřej Zaletka, RIPE NCC. I just wonder if you do this mass update, does it actually update objects in RIPE database or does it delete and recreate them?
It will check if there is if there's already an object present, and will only update if there is any change to the objects.
Okay, so but it will do update, not delete and recreate.
It will only delete and recreate in case you have resized the prefix. Or,
okay,
yeah.
Thank you.
Please.
Hi, my name is Rinse Kloek. I'm just a personal person. One question, does this also work for Nautobot?
It may be, I've not tested it yet, but the data model should be very similar. So yeah, we could try it out. It might just work.
Okay, thank you.
Thank you. Anyone else have a question? The online queue is empty.
There's one, the text one. Actually, there are two now. Wow. Okay, the first one is Brett Kerr from Neminet. He says, does the updater potentially support other products that support webhooks?
Other what again, please?
Does the updater potentially supports other products that also support webhooks? So I guess what?
Also, other products than Netbox? Yeah, yeah, maybe Nautobot is supported. Yeah, basically it will support everything which has the same data structure and model as Netbox has, but which may be Nautobot, but other than that, I don't know.
Thanks. Yeah, actually, yeah, it's a good question. Do you want to replace Netbox or do you want to replace the RIPE database with other registry database? Thank you. And the other one is Matthias Ordner, Exaring AG. Does the tool respect the RIPE REST API rate limit and anything specific necessary?
The rate limit? What's the rate?
The API has a rate limit,
yeah.
I guess. Maybe somebody creating hundreds of new networks.
Yeah, we have not taken care yet about it, but this might be a nice addition in the future, yes. Yeah.
Thank you.
Yes,
I guess we're going to use the product as well. I like Netbox and it's a good step in the right direction.
Yeah, thank you. It's great to hear.
Well, thank you very much.
Right, okay, let me introduce. Okay, everybody, our next speaker is Tom Strick. I'm not sure if I spelled the last name correctly. It's about RFC 3849 and RFC 5737. You're welcome. Tell us please more.
Good morning, everyone. It's amazing to be back here. It's been too long, although I guess it's still March 2020 for some of us at least. So yeah, as introduced, I'm going to talk about two specific RFCs, Normally, that's not the most exciting or interesting conversation to have, I'm sure, but I'll try to make it interesting. The reason why I want to talk about documentation and why I want to talk about RFCs is because documentation matters. And it's one of those annoying things that we easily as engineers can forget, right? Like coding, that's the fun bit. Configuring the network, that's the fun bit. Documenting the network is not the fun bit, right? And that's why we have solutions like Netbox, like talked about earlier, because they do it for us. It means I don't have to write the documentation myself. But in this case, it's even worse. Take you back to, yeah, this is now, what, 2 or 3 years ago, easily. And we got a ticket where we were seeing consistent CRC errors on our egress ports on a topo rack. In this case, switch to EWR03, which is in one of our Newark data centers. You now also know what the internal Cloudflare references are for the network operators group. So if you ever see that in an email from us, I guess now you know. So we're spitting errors, and it looked like this, which was really interesting. So each individual color is an egress interface for a compute node that we have. So normally the procedure that we take whenever we're seeing egress errors or ingress errors for any of their compute nodes, we just take that compute node out of production because that's the easiest way of doing things. Cattle, not pets. So we remove the node from production with the expectation, oh, it's a faulty NIC, or it's like there's a bad patch cable, a bunch of different reasons why things can break. But instead of the errors going away, they stuck just on a different compute node, which is weird because that usually indicates that something else is broken. So saw this happening again, removed it from production. The errors came back again on a different node. Something clearly is happening here that is not within the expected behavior for any of our operators, where we kind of know what's happening. So eventually what we did is we asked our SRE team, the people responsible for managing our compute side of things, to enable a specific option on the NIC that allowed us to packet capture broken frames, because otherwise the kernel gets to them too early and they get dropped before we can TCP them. So we actually started looking at this, and what we were seeing was that the Nexus switch, because these are Nexus switches, it's actually a example of a cut-through forwarding system, right? So it's not doing store and forward, just cut-through. And it was detecting a bad CRC coming in. It was clobbering that and sending it forward. So that usually indicates that the Nexus switch, in one way or another, was receiving an already broken frame, but instead of dropping it on ingress, it was dropping it on egress. But the way that our architecture is laid out, the TORs are the last node in the network. There's a bunch of different network kit in front of those topo racks that, if there's a broken frame in there, should have seen that broken frame. So this kind of explains what's going on, right? Like we're doing some fancy things within the switch, so that makes sense why we're seeing it on egress, not on ingress. But we should be seeing that on our core switch. We should have seen that on our edge router where the traffic was coming in from. So something's weird. So like I said, we enabled RxFCS, enables us to do the packet captures. And we had to look at that. And this is the packet capture that we saw. You see just a bunch of ACKs. The weird thing that you might start paying attention to is this thing. The annoying thing with this is if you look at the packet capture, you might be able to see that there's actually some encapsulation things happening, right? It's ER span traffic that we're seeing. For those who are not in the know, ER span is a Cisco protocol that allows you to GRE encapsulate packet captures or frame dumps from a switch and then forward it to an arbitrary location, allowing you to do port mirroring without needing to have a machine directly hooked up to the switch itself. So the thing is, we were still wondering, like the frames themselves, like the GRE packets themselves, the ER span packets themselves were perfectly fine, right? Like normally, if things are broken in Wireshark, you'll see that they're red, right? Like they get nice color coding, and then it's very indicative that like something's broken, fix it. And that's not the case here. It's like it's the nice yellowish green. Don't take my word for it. I'm colorblind. But apparently, what was happening is the Nexus switches have a pretty damn notorious system where they're looking deeper into packets than they actually should. What the Nexus switch was doing in our case was not erroring on the ER span packet. It was erroring on the packet within the ER span packet itself. The packet within the ER span packet was the broken packet, and that's what the switch was complaining about. That's not helpful for anyone, especially because it's not documented. We couldn't find any documentation anywhere on the Cisco website that told us, oh yeah, it's like this is the thing it does. We just kind of had to go with, as I think all of us do a lot of the time, unfortunately, is relying on our connections, relying on the people that we know. But again, it's like, what does that have to do with documentation besides the fact, if there's anyone from Cisco here, could you please document that behavior? It would already be a help. But that's not just it. Like, if you recall that packet capture, there was something in there that probably shouldn't have been in there, and it's this. And some of you might recognize that IP address as running a specific service that doesn't have anything to do with ERSpan. I think it's something with DNS. But yeah, so what was happening is an operator in a network that won't be named was also, I think, running Nexus switches, because I found some documentation on the Nexus website, and as far as I know, it's still online. And they're telling you, it's like, oh yeah, this is how you configure ERSpan. That's cool, right? Be nice if they couldn't, maybe. It gets even worse, is that it also says the source IP to 1.1.1.1, which is in and of itself already a pretty interesting thing. So if you look at the packet capture, you'll see, let's go back a bit. Yeah, I blurred it out, but the source is also 1.1.1.1. So we're getting some weird traffic, unfortunately. And yeah, that kind of needs to stop, because and also, like, the thing is, like, we're no longer 2020. I'd want it to still be 2020, but this is now 4 years ago, right? Like, this is more than 4 years ago. It's about time that you start updating your documentation. The thing is, obviously, it's not just Cisco doing this, right? Unfortunately, it's even Cloudflare doing this, and we're the ones operating the damn thing. As you might see, that's not a documentation prefix. Like, we don't even own that prefix. I don't know who owns that prefix. Sorry if you do. There's other things where, you know, it's like, sometimes we make our labs, and 1.1.1.1 is an easy IP address to use in labs because it's short. And like, I now remember the documentation prefixes because I've been giving this talk a couple of times and they stick. But, you know, like, it's understandable for people to use those IP addresses. That's fine. The thing then is, when you get called on it, is to accept the fact that, okay, I messed up, that's never going to happen again, not you're blocked. That's just a bit awkward for everyone involved, really. So the easiest way to fix that is with two specific RFCs that have been around for a really damn long time. Like, they're probably older than some of the newer RIPE attendees, which is in and of itself amazing. But yeah, like, 3849 has been around since July 2004, and 5737 has been around since January 2010. So you can't really blame ignorance, especially now that you've seen this talk. I will find you. Just as a reminder for, like, those in the back, like, generally, like, just write them down, remember them. It's not hard. It's 2001 DB8/32, so it's /32, all the space, like, all the room for activities. It's free real estate. Use it. And for IPv4, we even have 3 of them. You know, you can vary, you can be nice, and you can just kind of, you know, like, variation is the spice of life. Use it. There's 3 of them. 192.0.2.0 is probably going to be the easiest one to kind of remember and stick with. I do think I included the testnet with this, but for all intents and purposes, it's good enough. So please, please, please use these instead of 1.1.1.0/24. It makes my life a whole lot easier because it means I don't have to run through a bunch of weird documentation that might have been hidden somewhere about a weird packet hitting my network that shouldn't have hit my network. And just, you know, like as a closing statement, it shouldn't be that difficult, really. I mean, I know it's easy and we all make mistakes, but if you make that mistake, just do it once and then watch my talk again and then don't make it again. And that was it for me. I want to thank all of you for your attention. I want to thank all of you for definitely using those RFCs because you all will now, I hope. And yeah, that's it.
Thank you very much. Now I know who's first.
Oh boy.
Jan.
Thank you for reminding everyone about those RFCs. Have one comment on, I don't know, question. Using those RFCs actually solves half of the problem because what I did twice. I looked at an amount of packets with sources from 2001 debate. People actually do read the documentation and they do use those addresses as a source addresses for those packets, right? So, and yeah, I don't know what we can do about this, yeah, but at least we can filter them.
Exactly. So that's the thing is, unlike the 1.1.1 stuff, inherently we always allow pretty much all traffic to 1.1.1 because it's interesting and it's job security because I can make talks like this. But with the documentation prefixes, if you follow manners, you drop them at your firewall. A good network drops them at egress.
I'm actually surprised how many people actually might start announcing 2001
Oh, yeah, like
debate to get your
seen it all the time,
someone
but,
else's
like,
traffic.
At that point, it's also part of the community's responsibility to drop these on the BGP border or your firewall border or whatever. But that's workable, right? Because they shouldn't be routed, there shouldn't be traffic on them. So
Yeah, and so I guess it will be too late to ask you guys to sacrifice 111 as a documentation prefix. So I don't know who owns 123. Maybe those people can do the good thing for community and make that prefix documentation.
that probably would have been a better idea.
Thank you. Wolfgang.
Wolfgang Dremmel, DKIX Academy. Can you please add one slide to your presentation because there are also AS numbers reserved for documentation?
Yes, indeed there are. I will.
Peter.
Peter Hessler, OpenBSD. Do you have any comments about people using IP addresses that will never be seen on the internet? For example, the US Department of Defense address ranges.
I mean, it's the same thing as like using the documentation prefixes in your own network for routing. It sucks to be you, I guess. I mean, it's like, yeah, we're gonna drop it on our firewall. We're gonna drop them. So like, if your stuff doesn't work, then it's the same thing with RPKROV. Like, if you're gonna be announcing an invalid and you're gonna use traffic on that invalid, then
Yeah, and as we've seen with, for example, the UK Department of Water, I believe, that was all not announced, and then they sold it to the public, and now it's being announced, and now it's being having interesting conflicts in the wild.
You can't press the button, huh? Will, please.
Yeah, well, I should have pressed the button, sorry. I'm Will, I'm from JNDI. I was wondering maybe we should do something with AS 112 on that and starting announcing those prefix with the on IXP. Maybe, I'm wondering because some people will not filter those, and yeah, I'm not filtering those actually right now. So.
I mean, you should.
Yeah, sorry.
But yeah, I mean, I think we can, AS1112, that's the one also taking care of the ARPA stuff, right?
Yeah.
I guess we could, but then to what end? Because then the primary point at that point is you're being a wastebasket for a bunch of weird packets, right?
Yeah.
Yeah, I'm not 100% sure on what the value or like added.
It was more a thought process, and like if anyone was thinking that was clever, or if I was totally stupid and not awake.
No comment.
Okay, there is no people in the queue. Are there any questions in text?
Nope. We missed one question from last presentation by Elvis, but that Elvis already knows about that.
Sorry,
So
Elvis.
Not of this one.
Okay, Tom, thank you very much.
Thanks, folks.
Oh, this is Maria. Okay. Yeah, Maria. Oh, you're already here. Okay. Maria would present about a recent version of BERT, made in Czech Republic, BERT 3, if I'm not mistaken. And maybe say what is Koalas. I'm not sure my Latin is up to speed.
Of course. Hello, I'm Maria. I'm from CZNIC. I'm a developer of the routing software BERT for several years, I think since 2015. And the Kovolas is something like Kovadis, but the bird is more flying than walking. So it's where are you flying? How does it move? No, maybe this way. Okay. First of all, thank you for the respecting community. It's been rough 2 years with the COVID pandemic, especially for people like me. We were locked in with lots of unrespecting people, but it's good now. The parallel execution has been a long requested upgrade, so I now can say that it's going to be here. But let's start with some parts of history. I hope I got these dates correctly. I may be off by a year or something like that. It's just a common mistake of by one, so it's off by 1 year maybe somewhere. But in 1998, there is the first commit in BERT history. That commit is adding a presentation in Czech, so there's no need to read it or use Google Translate. Nobody has ever translated it, but it's a nice piece of history. The code has been heavily optimized for x86. And when BERT was released and the first development was closed, there was no notion of even dual core architecture. So when in 2005, the first dual core CPU was announced for PCs, it was, I think, Intel Core 2. It was just, BERT was just quite done and working. And then there were lots of years when almost nothing happened. Anyway, all this time, BERT thought, or BERT creators thought, that IPv4 is going to die. And in 2017, we finally dropped this assumption and we integrated IPv4 into the IPv6 version. And now we fully support running BERT with IPv4 and IPv6 together. We were trying to push IPv4 outside as hard as we could. We failed. And in 2017, also, I think the first 16-core CPU was made available. So I think it's something like 5 years since since there was a good reason to make BERT multi-threaded. So it's 2022 and we are coming. Fine. What is done? The new filter engine is done. It was completely impossible to make it multi-threaded. So the first thing had to be to rewrite the filter engine. The big thing, what happens inside BERT now, in BERT 2, is that the routes are propagated as they come in. There is no delay, almost. It just waits until there is some space on the wire. It's not possible to do it in the multi-threaded environment because we could get in lots of deadlock problems when accessing routing tables. So we had to make some breaking points, some queues, which also brings quite a lot of possibilities to implement minimum route advertising interval. After lots of years when this was completely impossible in BERT. So there were some people asking for flap dampening or something like that. Yes, it will be there. Not in the first BERT 3, but it will be there. The three things that are separated into their threads are BGP, RPKI, and pipe threads, where pipes are these things moving routes between two different tables. The RPKI non-blocking loading is quite crucial because when you have lots of CPUs doing the BGP, and now it's not the one CPU doing the BGP and sometimes checking RPKI. Now it's all your CPUs doing BGP, and we don't take any liability for you locking yourself outside of your router by running BERT, just because you forgot to set a C group to lock your BERT inside inside some part of the CPUs and let at least one core for maintenance. We can't take any liability for you breaking your hardware. It's your fault. Anyway, it also bricked RPKI. So I had to make RPKI also multi-threaded to have its own thread to not suffer from the BGP, from lots of BGPs. What is broken? I want to say thank you, DKIX, for testing. I spent almost 3 years on doing that thing. Then I finally managed to convince Ondřej Filip to release it. And after an afternoon, I have 3 months or more of work to be done. Thank you, DKIX. Anyway, for now, please don't call ROA checks from CLI in BERT 3. It will just fail. There are some problems with the memory management, as if you have lots of CPUs and all of them need some memory and some buffering, it will eat more memory than before. But we are working quite hard to reduce it. There are some problems with Quark implementations from recent years. So, for example, when there are some auxiliary tables, they are implemented in such a bad way that they have to be completely rewritten, which is something I'm doing almost right now. There are also some problems which I completely forgotten about. For example, MRT dumps. There are simply some parts of internal API that I completely missed when doing the rework. So if I can recommend anything to you, please do documentation. Please do it even if you are doing little changes, and please do it from the beginning to the end and beyond. Do the documentation, document everything. Or you can get into my place and, well, I know I am a code cleaning lady, but I would like not to clean such a mess. also due to the long time, I couldn't merge BGP, BMP and flow spec validation just because it used parts of internal API that wasn't there before. And the new API my colleague Andrzej Zajíček implemented was completely unmergeable with the multi-threaded version. So, well, we'll have to rewrite parts of these as well. And I also want to say sorry to all your BSD folks. It's been a long history of portability issues. We are trying our best, but you can see even read it from the end, from the bottom up. There are 3 commits in one day. Hey, it's April 1. Trying to fix some portability issues in FreeBSD. There were obviously better days of Martin Maresch, but he did a good job. I must say he did a good job. Anyway, by solving lots of our technological debt, I can also promise you, and it's something like salvation is coming or so. We will have the JSON route export, not in the first version of BERT 3, but we will have it. It's possible now. It hasn't been. We are going to unify route attribute names, so you don't have to check whether the BGP next hop is written in filters this way or that way, and in the attribute dump in another way, just because some programmer, some developer in 1999 decided to name these 2 things differently. This one thing differently in 2 places, to say better. We'll have non-blocking reconfiguration, which is something lots of people ask for. Well, I know some of you are parsing the configuration file for 20 seconds. We know it. We can't make this much faster because it simply takes the time to parse all of your IP addresses. We are not generating your gigabyte big config files, but we can finally offset this reconfiguration and this parsing to another CPU to not block the BGP. And as far as I can remember, the FreeBSD has finally implemented some years ago a better synchronization API for routes with kernel. So in FreeBSD, we'll be probably implementing that. In the others, we will just offset that route synchronization into another thread. So that's it. And knowing what is broken, try BERT 3 today, tomorrow, or anyway, or any day. But please don't do these things I had told you do not do. And put your BERT into a C group. Thank you. Any questions?
Thank you very much.
I have seen one text question. May I read it first?
Yep, please read it.
And guys, if you send me text questions, better do this before the speaker ends talking, so then you get a leg up. Alexander Zubkov from Curator Labs is asking, do you plan JSON export for other stuff like show protocols? Should be only 2, right?
Well, I think it will come as well. The ultimate goal is to render Birdwatcher obsolete.
Okay.
Tom.
Tom Strix, Cloudflare. First of all, thanks for that. It's very much appreciated. Would it be possible to expand a bit on what your strategy is, I guess, to make BGP converge when you're multi-threading it? Because I guess you're treating tables differently.
Sorry, I may maybe missed the point. What's our strategy in BGP convergence?
Yeah, it's like so how do you deal with the fact that you're running in separate threads for separate neighbors, and how do you get to a point where you have a single unified forwarding table?
Well, the table is for now the table is has one lock, so it's synchronized on the table. In future, there will be probably a lockless structure or something like that, even to make it even faster. Anyway, the single source of truth is the table, and anyway, if something is in the table, it doesn't mean that it's exported. There is in bird 3 some queue. There is a journal which needs to be processed by every exporting connection, exporting protocol, to process the routes. In bird 1 and 2, these are actively pushed into the protocols. In bird 3, they have to pick up them, which can lead to quite big buffers when one single protocol is taking their time to do everything what they need, and the others are completely finished. So the journal can be, in the worst case, something like all the updates that have come from before.
Right, cool. Thank you.
Please.
Hi, very nice talk. Stavros from AMSIX, by the way. Okay, partially I got my answer from the previous reply. That's good. Then I have a second question. Where these features that are really promising are coming to, let's say, their final release?
Well, the first goal is to make it stable and to fix these problems I was speaking about. So until ROA is capable to be called from CLI, you are getting no JSON.
Okay. Fair enough.
And on a quite personal note, I don't know whether you are going to get any JSON.
Right.
You remember me.
Yeah, I know. Okay, then a second question. So I know that a lot of us still having bird 168, maybe having plans to go to bird 2. Shall we wait for bird 3, or we should go for bird 2 and give you some time to work on the bugs?
That's a good question. I think it's okay to go to bird 2 because as far as, well,
Well, going from one bird version to another is a painful process.
At least 3 months ago, we thought it would be okay to move to bird 2 because the transfer between bird 2 and bird 3 should be just locking bird into C group. Anyway, it looks like we'll have some little changes, like displaying the extended attributes of routes in a slightly different way. So if you are most concerned about the configuration,
yes,
you may simply go to the version 2. Anyway, there are quite a lot of changes between version 1 and 2 CLI output.
Yes.
And there will be quite a substantial amount of changes in the in another way between 2 and 3.
Okay.
So if you are concerned about the CLI output, you should probably wait for bird 3.
And the configuration, actually, the configuration file.
The configuration file should remain almost the same.
All right. Okay.
Anyway, if you managed to wait for, well, it was 5 years from release of bird 2, you can wait another year.
Thank you very much.
So you're actually looking for alpha testers, more alpha testers, right?
Well, in fact,
more work.
There are some people who already run bird 3 in production. Anyway, they don't call ROA from a CLI.
Please.
Maximilian Wilhelm, biorouting. Thanks for this. I know it's complicated. Are there any plans to implement ISIS in Bird 3?
Well, implementing ISIS was quite a political issue several years ago. Anyway, and now I think if we get enough time and people to do it, there is no problem with it. Also, contributions are appreciated.
Thank you. Are there online questions?
Nope. I'm double checking, but looks like we are done.
Any other question? No. 3, 2, 1, go. Thank you. And this is it for today. We are 5 minutes early for the break, but have a good coffee. Thank you.
Jan said he might show up or whatever. Oh, thank you. Are you handling QA part? That might be good things, but show them other way. Hello, everybody. Welcome to the 11 o'clock session. My name is Peter Hessler, and I will be chairing this morning's sessions with Jan George. It's nice to see so many faces in the room, but I would like to see a little bit less of your faces, if you know what I mean. There are masks available out in the waiting room, and there are self-tests if you'd like to make sure that you don't bring home some little friends with you. First off, we have Chris Adams, excuse me, from the Green Web Foundation, talking about a fossil-free internet. Go ahead.
Okay, hi folks. I'm assuming you can hear me okay, right? Right, 200, okay, good. All right. Okay, hi folks. My name is Chris Adams. I am the Executive Director of the Green Web Foundation, an NGO set up to work towards a fossil-free internet by 2030. I'm also an organizer of an online community called climateaction.tech, an editor of a magazine called Branch, which is all about the intersection between climate and technology, and I'm the chair of the Green Software Foundation Policy Working Group. I'm going to barrel through this talk relatively quickly, so if you miss anything I'm saying, there is actually a link that you can follow here through to our website with a link to the entire deck with all the kind of words that I'll be reading off as I run through this, okay? In the limited time I'll have with you, I'm going to cover these three things. Well, first, I'll give you some background on climate to help set the scene and kind of our place in this. Then I'm going to introduce you to something which I'm referring to as a fossil-free internet, then point to some recognizable emerging qualities that I think may be of interest to you. And then finally, I'm going to make a case to, I'll cover how to make a case for this when you're actually at work. So it looks like most people are sitting comfortably, so I guess I'll begin. All right, what's a tech conference without an XKCD cartoon these days, huh? There's one for everything. This was released earlier, and I think this year, and I find it really interesting and useful to help me think about like the climate crisis, basically, or what's happening here. I mean, I turned 40 this year, and that's kind of if we look at this map, we'll see how over the last, say, like, well, my entire lifetime, we've basically seen this kind of raise, this rise in emissions, and we've seen how there are certain people who do well out of it and certain people who don't do so well out of it. And there may be reasons why we haven't been moving as fast as we could be moving, for example. And if we were to kind of refer this to something which is a bit close to home, what's happening the last like 12 months, you can see these same kind of charts here. There are certain groups and there are certain people who do really, really well out of us not really doing much or thinking too hard about this. And it works very well for some people, but for some of us, if you pay for energy bills at all, you might kind of feel that maybe I'm not doing so well like this, and maybe this is something we should be doing about now, which is really affecting us now. And I think I'm going to share this on massive letters, and it might seem really, really obvious, but basically, while we will talk about cool things like efficiency and everything like that, one of the reasons we kind of have this kind of background level of kind of angst around climate is basically because it's not that we don't have alternatives to get off of fossil fuels. It's because most of the time, it's because we haven't been able to find a clear path off them, basically. But there are paths off them. For example, around May last year, there is a group called the International Energy Agency. They published this groundbreaking report detailing for the first time ever a roadmap to get the entire energy sector, which is basically what we rely on a lot of the time as engineers and internet technologists for basically powering everything we do. They published a roadmap to get the entire sector off onto the same 1.5 degree pathway that we see scientists talking about in the news again and again, and increasingly we see children talking about in the news. Now, this is interesting because the IEA was not a radical campaigning organization. It was initially set up by Henry Kissinger in the 1970s to ensure a steady supply of cheap crude oil as a response to a number of oil producing countries in the Middle East restricting how much oil they produced during the oil crisis of that decade. It's since become incredibly influential over the last 50 years, and countries and large economies now base their industrial strategy on what these projections say will happen. And in this report, it's interesting because they share a roadmap that basically says, yeah, you know, the science guys, they're right. We really do need to get off fossil fuels. And remember, this was an organization that was set up to supply a steady supply of oil for rich countries. And they basically said, no more exploration from now on. You might not be able to see it so far, but like that's literally spelled out on their report on the bottom left-hand side. In this report, they kind of lay out a clear pathway to get to kind of basically net zero and 1.5 degrees of warming and actually basically avoiding the worst of climate change. And along the way, we end up with an economy that's larger, more efficient than the one we have now, and it's healthier and richer. And while fossil fuels aren't phased out entirely, they play a much, much, much smaller role. It's a positive standing future. And as you can see, there is, well, basically you might ask yourself, well, what part does the internet play with this, right? Where are we in this? Now, generally speaking, the internet or the kind of tech industry, you can think of it as being roughly the same size as, say, the shipping industry or the aviation industry in terms of like carbon emissions, basically. And I think we need a fossil-free internet. And if you wanted to tell your boss why you think we should have a fossil-free internet, these are the main reasons I think we would want to have this. So we're in a climate emergency. So a fossil-free internet is obviously going to save carbon. It saves lives because there is an undeniable toll from the bad air quality that comes from burning fossil fuels. It saves money because, well, if you pay bills, you've seen how the cost has actually gone up. And then if you have people who actually care about this stuff, generally greener firms tend to keep people longer. And finally, well, you can see this whole war going on in Ukraine, which is related to this, and how we end up funding essentially a war machine by default because we're reliant on fossil fuels so much. So I've explained why you might want to kind of have a fossil-free internet. Now let's talk about what a fossil-free internet looks like, or what qualities you might look for it. So I kind of think that I've tried to come up with a memorable way to think about this, or a way that you might kind of look for things that help you identify what a fossil-free internet might actually be. Partly based on ideas that you see in the web accessibility movement, where they talk about POUR being perceivable, operable, understandable, and robust. And I've come up with GOLD, which stands for green, open, lean, and distributed. And I'm going to run through these in the time that I have here. So first of all, green, kind of obviously, means green energy and green inputs. As we see, we need energy to run computers, but also to make computers and networks. And every time we use the internet, for example, even if we don't mean to, we're basically burning fossil fuels, because the internet is currently the biggest machine in the world, and it still currently runs on fossil fuels, predominantly coal right now. Now, we really do need to stop this, and this is something that we can do, but I kind of feel that if we're developers or engineers, in the same way that we don't really need to build the web with fossil fuels any more than we need to build houses with toxic materials like asbestos or things these days. But generally speaking, when you're using power, a chunk of it will be coming from things like gas and coal right now, where even if you're buying a kind of green energy tariff. And this actually will change depending on where you are in the world. And when the internet, yeah, we are, when the screen updates, you can see this. Has anyone heard of this website here at all? Electricity map? Okay, 1 or 2 pages. Okay, so I find this map really, really useful. It basically shows you how green the grid is in different parts of the world. It's an open source project, and they basically pull this data from various open data sources. And this can be used to for you to figure out where you might choose to run infrastructure or run particular workloads for a kind of lighter carbon footprint. Google does some of this, and I'll point to it a little bit later. You can also see how different decisions people have made can change how the grid works. So for example, you can see France full of nukes, really, really low carbon most of the time when they work, all right? You can see Poland really, really big into coal, much, much, much higher carbon intensity, and vice versa. And so you can see a bunch of this stuff. Like Germany, where we are the land of coal and solar. So we've got this weird mix, but generally speaking, it's I find this really fascinating myself. So that's one thing. Now, if you did want to run on kind of green energy, the way we tend to use it is if you're looking at a website, you're choosing to buy, say, infrastructure that's running on green energy. If you're not running solar panels yourself or something like that, what you're normally doing is you're basically investing some money into the grid to make sure that you are essentially shifting us away from fossil fuels to something greener. So in the long term, this ends up making the grid greener for everyone. And you'll typically look at this on a kind of yearly basis. So even if you're using, say, like a green tariff, there will be certain times where you're not entirely running on green energy. And like this kind of makes sense. Like solar panels obviously aren't going to be that effective at night by comparison, right? And it looks a little bit, and this is basically one of the things that we do. My organization, we track the transition of the web away from being entirely running on fossil fuels to something which is not running on fossil fuels. We've been doing this for the last 15 years, and we track how people account for this. And generally speaking, what we count a site as green as if they've accounted for all the emissions coming from running the infrastructure that they are basically delivering web services with. Now, it's worth referring to this that I said that you're not always running something on green power, for example. So if you say, well, I'm half my energy this year is coming from green power, it's not necessarily 30% continuously. It's usually going to be like you have these kind of fluctuations like you see here. Now I'm sharing this with you because this is something that you might come back to later on, and there are increasingly kind of time-stamped clever ways to account for this stuff. And especially if you have, as we've seen, like the cost of things like, say, batteries and solar and stuff come down, it's actually increasingly likely to be increasingly possible to actually run your infrastructure without needing to kind of be reliant on the grid, so that you can basically time shift green energy to be running it to run it locally. Now, I've spoken about like running something on green energy, but that's not the only source of emissions when we think about like the internet, basically. There's obviously a carbon footprint from running things, but there's also a carbon footprint from making things. And depending on how much you use a device, that'll actually be somewhat different. So for example, these, what you're looking at here, this is a chart showing how you have, say, embodied emissions, which are coming from basically turning sand into kind of silicon chips. That needs a lot of energy to do this. And this usually comes from burning fossil fuels again. And you might see things like, say, networks and data centers, where because they're on 24/7, actually what you choose to run it on has a much greater impact. So this is one thing we need to be aware of. You need to be thinking about the entire life cycle. And this also actually gives you an argument for saying, well, if for example, you've got some user devices, one thing you might want to do is actually just extend the life of that, using it for longer, because proportionally a significant chunk of that is actually going to come from the actual making process rather than kind of using the using phase of this. So that's kind of green energy, which is kind of obvious. The other thing I think that will be interesting is the idea of open. So open as an approach, not necessarily just open source, because if we're going to make data-informed decisions about how we might kind of end up with a greener, more advanced internet, then you kind of need to have data for a data-informed decision. Now, with the example I spoke to you about things like hardware, there's some really interesting projects. This is one from a group called Boa Vista, who are in France. They've basically been collecting all the numbers from every single product they can find. And they will basically let you figure out the emissions associated with maybe your device that you have or your servers or something. And then based on the lifetime, get an idea of at what point you might need to, what impact your choice of energy might be compared to the choice of the energy coming from making it, for example. This is really, really useful for you to understand when you're trying to figure out how I'm going to decarbonize a set of tools. Do I choose for greener energy, or do I choose to kind of not buy so many servers in the first place, for example? The other thing that's interesting about open is if you have open data, then you can put it in lots of interesting places. So this is an organization called Ember. Ember, they collect emissions data from pretty much every country in the world, and they create it and they make it available in useful data sets. So you can find out the kind of carbon intensity of electricity anywhere in the world, how much of it is coming from, say, say, coal versus gas or something like that. And they use this to inform policy. But because it's open, you can do some other things. So one thing that we've been doing with RIPE is we've been building some carbon intensity APIs so that we can basically annotate any public IP address with carbon intensity data. So rather than just using a map, you can basically like query your entire fleet and get an idea of what the emissions might be from running stuff in one place versus another place, for example. Now, there are obviously caveats related to this. So this is only going to be as good as the data that you rely the kind of any geolocation stuff on. And we're currently using, say, MaxMind for this. But I think this is the kind of direction we'll be starting moving towards. And I'll point to some examples of this, because this is something that we're doing as an experiment for anyone to use. But some other organizations are already further along with this. So Google is an example of this. Google have basically been ahead of the game on this in quite a few ways. They've invested in running green energy for a lot of time. And they've also been building tools that make it possible for you to basically look at your infrastructure and work out where you might run a workload based on things like the carbon intensity, the latency requirements you might have, or the cost requirements you might have. And I'm afraid you can't see it quite so well in here, but these kind of criteria are new criteria you might take into account when you're looking to basically decide how and when you might run any kind of service or any kind of application. Open is also interesting because I think it allows us for new ways to think about how we use existing digital infrastructure. So what you're looking at here is the heat exchanging part of a new data center in the Netherlands using a bunch of open compute servers. So Open Compute is a project by a number of large organizations like Facebook and Microsoft to basically build open source server components, partly for helping them run their own kind of hyperscale data centers. But it turns out that these are actually useful in lots of other places. And this is a really good an example. This is the part of a data center that you see from a company called Block Heating. Block Heating, rather than having a massive out-of-town data center the size of a football pitch somewhere, what they do instead, when you have this massive out-of-town data center, all the excess heat, you basically spend huge amounts of time and money to keep things cool and kind of vent it into the sky. What they do is they basically have lots of smaller data centers. Like they basically take lots and lots of end-of-life servers from companies like Facebook and Microsoft, put them into shipping containers, then they connect these shipping containers to greenhouses that grow crops like tomatoes and cucumbers. Now, greenhouses, they will usually need to kind of get the temperature hot enough to grow tomatoes, and they'll usually be burning gas to heat up these things. So what they do instead is they take the waste heat from these servers, and rather than venting them into the sky where it can't be used, they put it to use to actually come up with delicious, delicious produce. Now, I think this is kind of cool. This is using waste heat productively, turning what was a problem into something that is valuable for other people. And I think that having like an open chain, open kind of tool chain makes it possible to come up with ideas that you otherwise wouldn't have seen really. And I think this is also useful because it extends the useful life of hardware, for example. So that's open. Now let's talk about lean. So lean is about making resources you do use count and not wasting things needlessly. So in Germany, has anyone heard of the Blauer Engel certification before? Okay, the 1 or 2 hands. So earlier on this year, the Blauer Engel, there was the first ever Blauer Engel kind of Blue Angel certification for essentially like a eco-certified product. It was a open source PDF reader called Ocular. And this is now, this is interesting because they in order to actually get some software certified, it's run on really, really old software, not some shiny new thing. So in order for you to kind of get some software certified, it needs to be running on 5-year-old hardware. And increasingly, these kinds of certifications and ideas are being worked into how public sector organizations actually buy and buy large services these days. So while this is a kind of like an interesting idea now, it's increasingly it's seen as one of the tools that groups will be looking to reduce their own operational emissions to basically in line with the science really. It's also interesting because there are certain kind of, say, closed source tools where they have weird spikes of inefficiency. So if you were to compare LibreOffice with another very, very well-known commercial operating system, one thing that's come out from projects like this to analyze this stuff, and this is some of the work with Software, which is a German kind of tool, a German project to measure these, they found out that one of the big sources of inefficiency was basically some code which blinked cursors that ended up causing massive spikes in energy usage inside the computer that wouldn't have come up. And this is like one thing that you discover from this when you start applying this kind of analysis to tools like this. If you don't work with desktop machines, you might work with the web. There are tools that allow you to kind of apply this kind of lean idea to what you're building now. So GreenFrame is an example where they'll basically take a series of Docker containers to represent parts of the infrastructure that you might be running, and they'll basically measure each of these. And they'll put this into tools like continuous integration. So when you're working, you can see roughly the energy associated with maybe a particular user journey going from a page to making a form submission, for example. And then every time there's a new pull request or a new commit, they'll show the difference. So what you see here is an example of a pull request that's basically put a bunch of new energy on the screen and the network, for example. And with each of these, you can dive into, say, the database level or the server level and so on. So there are tools that allow you to actually kind of embed these ideas into how you build digital services now. But can you apply this to networks? I think you can apply the ideas of like lean to networks, even if there isn't a kind of one-to-one matching between, say, watching a Netflix, downloading something and there being a kind of one-to-one ratio between what kind of emissions have been caused by you doing that. This is a project from called Seismic that Facebook and a number of groups have been funding in off-grid locations, particularly in Peru, where you basically have off-grid connectivity that's primarily running on diesel a lot of the time because that's basically the main way that you generate power. There's been some interesting work I take a sec for this to be visible. Come along. Yeah, here we are. To basically see if you can modulate the power used by various tools, by the infrastructure you do have, so you can kind of match it to demand rather than just having a steady amount the entire time. So this has made it possible to basically run off-grid connectivity on things like solar and storage. And you can see, for example, at the very top, there's like the weather that might be taking place here. Now, the second bar down, the telecom site power usage, you can see how when it was particularly sunny, there's a spike in using more because of course there's more energy around. But when it's dark, you might bring it back down again and use some of this kind of 2G only mode, for example, just so there's something available because you know you don't have that much usage there. But when you have like, say, kind of places where in times where there's less solar, for example, you might scale down to a slightly lower power use. And you can see at the very bottom that people are using battery to kind of act as a kind of counter to the energies coming from, say, solar in this case. So it might be that you top up batteries to make sure you've got enough to last you through the night and so on. And then when you actually have periods where you're not going to be expecting so much power, you'll have some kind of controlled dimming thing here to run through this. So these are ideas that work kind of in off-grid places to provide continuous connectivity to match the usage. I think we can apply these ideas ourselves to how we run infrastructure ourselves, and like the rest of the internet, for example. And I'll touch on some examples of this a little bit later on. So we've run through G, O, L. Let's look at D for distributed. So I think this is one thing that is of interest because there's a new kind of trend in how people are actually choosing to run infrastructure or when they might choose to run infrastructure. Because depending on basically the conditions of the grid that you're using, the same piece of software can have either a high carbon intensity or a low carbon. It can be greener or not so green based on basically when you choose to run it. Has anyone ever heard of the baking forecast here at all? All right, this is that is kind of niche. All right, so in the UK, there is a project where basically people who want to bake particularly green cakes or green loaves of bread have basically hooked into an API so that they can see when there's going to be a lot of solar and wind on the grid and when there's going to be loads of gas on the grid. And they will basically say, today's a good day to bake or today's not a good day to bake. And this is actually an example. It's a kind of like silly but quite fun example of how the carbon intensity can impact the things that you actually do. And if you go to Twitter, you'll see baking forecast to use this yourself. I mean, it's only for the UK. I don't know if there is a baking forecast.da, but if you're in the UK and you want to bake a green cake, then this is an API for you. But you can do this at other places in other domains as well. So we run a magazine called Branch, and we do something like this for the magazine itself. So we know that the grid powering our service is green, and we've taken steps for that. But we don't really know about other people, what the grid might be like for other people in the UK. So when we know there's lots of energy on the grid, we know that sending data over the wire is going to be kind of green, we'll send a full fat, really kind of rich experience down the pipe to our users because we know that the energy along the middle and the energy used by their computer will be kind of green. So we'll have like videos, nice images and everything like that. However, if there's lots of fossil fuels on the grid, we'll scale back some of the design and basically try to make the most of the carbon budget that we do have. So while people use things like page weight budgets to make sure websites load quickly and are accessible and kind of offer a nice experience, you can do the same thing for carbon. So we basically adapt the design to have a lighter weight and images-free version. So you can still access SM content, you can still download a particular image, for example, but we don't default to showing it, all right? I mean, this is actually good from an accessibility point of view anyway, because if you want to have, say, websites that are accessible in Google or anything like that, or people who are maybe partially sighted, then you probably want to show this stuff anyway. So this is a nice way to kind of make it really kind of front and center. The other thing you can do, and one thing we'll want to do in later on, is experiment with things like, say, web workers or tools that can see when the energy will be green and in the background pull stuff down. So even when you have loads of fossil fuel on the grid, if you fetched everything beforehand, then you're kind of okay. And this is actually something that Microsoft's Windows Update is actually now incorporating themselves, of like moving kind of processing through time to go for the greenest possible decision. This also works with data centers as well. So Google data centers have some of the highest energy intensity per square foot in the world, like more than aluminium smelters, for example. They can also respond quite quickly to changes on the grid, depending on what the grid conditions are like. And Google do this. They have a massive fleet of servers, and they will basically adapt the machines they have running and the jobs they're doing to match the conditions on the grid. Because in many cases, it makes economic sense as well as being green. And this is what I mean by examples of the grid changing and it making sense to move data, move work around. So this is probably an extreme example, but in Texas, you had a case earlier on this week where on one side of Texas, you basically you would be paid $2,500 to basically use a megawatt of power. But on the other side of Texas, you'd be paying $3,500 to be using that power, partly because on the left-hand side, there's loads and loads of wind because it's a particularly windy day and they need to get rid of it because it's if you have too much, it's basically damaging to the grid. So it makes sense to just pay people to use it and turn things down. On the other side, maybe it's really, really hot and you've got loads of fossil fuel generation. You've got loads of people turning on AC and therefore you've got a real demand crunch and people struggling to meet that demand. So people just have their prices go really, really high. Now, most of us are not exposed to this, but these are the kind of trends we'll see more of. And there are organizations that will take advantage of this now, basically. So that's this idea of like distributed, for example. And if you work, I mean, if you're a network engineer, you realize that there are limits on the speed of light. You can only move things around so fast. Just the same thing with energy. There are literally issues with transmission, just the same way we have issues with connectivity. And when you actually think about this at a network level, there's some really interesting work from path-based networking tools that have basically started to become more prominent. The example I referred to, like, here's an example, for example. So let's say I am in the UK and I want to access a website in, say, in Poland, for example. If I'm going to do this, I'll need to hop through every single country to get to this, or most countries, and every single time the carbon intensity will be different as I run through this. So France is going to be kind of low carbon, but Poland is going to be quite high carbon. And if it's Germany and it's not a particularly windy day, for example, we might be using a lot of gas, which means there's going to be a footprint there. Now I can do things like I can use a CDN to serve most of my content from somewhere closer, like Netflix do, for example, and that's going to have some impact, but I'm still need to be getting some stuff and going through particularly kind of like middling areas. Now, if I had some idea of kind of path awareness, then I could do something like a kind of low carbon trick shot, sending it around the greenest parts of the internet to actually get to, say, Poland, for example. And this is one thing that you often see with, say, North of Europe, really. You can do this kind of stuff. And these ideas are basically being implemented by an organization called Scion, or a protocol called Scion, which is probably the best example I can see from this. Like, do these optimizations deliver any real changes? This is a chart from a recent paper showing this, that they were able to kind of get maybe half the energy usage compared to like BGP. Now, this is obviously relying on the entire internet using them instead of BGP, but it gives you an idea that, yeah, there are possible savings there. So that's gold. Green, open, lean, and distributed. I'm just going to make the case for a fossil-free internet. So assuming these ones here aren't like all that attractive to you, or it may be that you do care about this, but not every one of these is going to be really one you might lead with in an organization, because they might not have the same priorities that you might have. The thing that you can actually do is just make the argument that it's so much cheaper now. Like in the last 2 years, you've seen lots of organizations doing this stuff because the cost has come down so much of green energy. And that's especially the case in the last, say, well, 6 months, for example. You can see how the cost of green energy, this is basically showing a percentage. So in the last, say, 10 years, the energy is about 10% what it would be. And then if you look where we are right now, the cost of gas and coal is multiples higher. So there's a good argument to basically have something cheaper in that sense. And I think that's all that I have time for. If you're interested in any of this, my organization that I work for, we provide training, consultancy, and if you have any kind of green services that you provide, you can basically please contact us so we can get them listed when people ask for this. If you care about this, there is a Slack community called climateaction.tech, which is very, very well known, which is really, really nice and supportive. And these are the ways to reach me. I'm Mr. Chris Adams on Twitter and Chris at the Green Web Foundation. And that's me, folks. Thanks.
Okay, thank you. Thank you. We are running a little bit tight on time, so I'm going to cut the Q&A key right now. But first, Robert, if you would like to go to the mic. Okay, there is not a Robert, so then Gordon, please come up.
Hi there. Hi there. Chris, thank you for the talk. Very interesting.
Please remember to give your name and affiliation. Thank you.
Gordon Bill, probably 2005. I am. So thank you for the talk, first of all. And I'm quite interested in. You mentioned that some companies couple power generation, renewable power generation capacities with data centers.
Yes.
And sometimes these power generation capacities might exceed the consumption of the data centers. I'm just wondering if this is becoming sort of a new norm, if we should expect to see more renewable power generation capacity to be installed next to data centers that might even exceed the data centers' needs, turning them effectively into power plants with compute capacities.
Yes, absolutely. In fact, not just this. Yeah, this is totally a thing that's happening more and more. And it makes economic sense a lot of the time, because you can basically get paid to turn off data centers, as well as when there's a lot of demand on the grid. If you have a particularly heavy load, for example, then there is an argument for that. And if you're able to then basically provide that to power those kind of energy services to other people, that's a whole separate revenue stream. There's a term called a controllable load resource specifically for this kind of stuff as well. So yeah, that's absolutely a thing that people do now. And if the data centers are probably particularly good kind of off-takers for things like this, and make it easier for them to get built. And in many cases, it saves you money as well, rather than buying gas and helping kind of fund a war machine, for example.
Thank you very much.
Blake, go ahead.
Blake with Zayo. So thanks again for this. This is great. People like myself who are part of a sustainability working group within their company really appreciate having slides like this to use as kind of ammunition for this sort of thing. On that note, we recently kind of rebooted the company, and part of that was that our investors actually insisted that we create a sustainability working group within the company. So this is a thing that can be done, like change can happen, even within large orgs like ours. So thanks.
Cool.
Okay, thank you, Chris.
That's me, is it? Yep. Okay, well, folks, I'll be around for the rest of the day, but and I'm on these places too. If you want to email me or anything like that, have a lovely day. I'll hand over to the next person, I suppose. Ta-ra.
Clicker.
And next we have Carson Stroman, who will be talking to us about fragmentation in DNS and protections against DNS cache poisoning.
Hello, RIPE. Hello, Internet. It's time to talk about DNS again. So I'm talking about a study that my colleagues and me, which are Roland from Rijswijk, Patrick Kötter, Markus de Bruyn, Anders Colligan, and me, did in the last 2 years. And we investigated, or we did some research into the question whether IP fragmentation is dangerous for DNS, and whether that is really a problem on the internet as we know today. So we wanted to know, is IP fragmentation a real threat in the internet? Is it possible to have mitigations? And how much do these mitigation cost? First, what we are talking about. So it's possible, and that is known for quite some time, that attackers can bring an authoritative server to send out DNS answers fragmented. And that is done by lowering the path MTU by sending spoofed ICMP error messages to an authoritative server. And then later on, when a DNS resolver sends a query to that authoritative server, that server needs to fragment the response going back. The attacker knows about that and then can send a spoofed second fragmented IP package towards the DNS resolver, which then happily combines the second and the first fragment. Now in DNS, everything that it identifies a DNS response, and that is DNS without DNSSEC, everything that it identifies a DNS response is in the upper part of the DNS message, which is then in the first fragment and not in the second. However, some juicy information that attackers might want to spoof are in the second part, which might be, for example, the IP addresses and names of name servers in a DNS referral. So, and that false response is then being sent back to the client, and it's also stored in a cache so that other clients will also get the wrong answer back. So first, we looked into how common is IP fragmentation for DNS responses. For that, we looked 24 hours at the DNS responses at a large European internet service provider that has about 4 million home and business internet access users. And we've seen quite low numbers of fragmented responses, low numbers in percentage, but still high numbers in total numbers. So it was for IPv4 0.10%, and for IPv6 0.11% of all the DNS responses that we've seen were fragmented. That's still for IPv6 69 million responses. So it's low in percentage because the internet is big. It's still a high number of responses. And a lot of these responses were caused by DNSSEC. Now we can say, okay, if it is caused by DNSSEC, then we are all good because DNSSEC prevents this kind of spoofing, and the resolver will figure out that the data is being spoofed and it will not forward that to the client. That is true if the DNS resolver is a DNSSEC validating resolver, but unfortunately, not all the resolvers in the world are DNSSEC validating. So still, there is a danger for roughly 50% of all the resolvers in the internet that are not validating resolvers. Here, this shows the amount of fragmentation we've seen over 24 hours. And there we see that it starts somewhere in the early morning, and it goes then down in the evenings, which is a little bit strange because the most traffic that is being seen at this ISP is in the evening times. And this is the percentage of fragmentation we see. And the most fragmentation really happens in the early morning days, or hours, sorry. So this might be because of caching, that certain DNS responses that are prone to be fragmented are falling out of the caches during the nighttime and then being refreshed or refetched in the early morning. Then we looked into which DNS servers are responsible for sending IP fragmented DNS responses, and we found that for IPv4, it's just 37 DNS servers that are responsible for 90% of all the fragmentation we've seen. And for IPv6, it was 133 name servers. So that is a low number if we compare that with the total number of responses we have seen. And then if that is a low number, the question is, maybe these are domains that we don't care about. These may be not popular domains. And we looked into the domains which are being served by these name servers that we've seen sending fragmented responses. But then we found really some interesting domains in there, which we can say they are slightly popular, like office.com or army.mil or Fraunhofer.de or something like that. So that was the first research we did, and then we looked at the authoritative side. We used the Open Intel platform, which is a large research platform that covers around 60% of the public internet, and we used that to send DNS queries to all of the domain names that are being queried from Open Intel, and we looked into fragmentation on the responses. Especially, we looked for fragmentation on the A record, the quad A record, and the NS records responses. And again, in percentage numbers, we saw very low fragmentation, but then in total numbers, it's still high. So that was 0.047% for IPv4 of all the answers were fragmented, and 0.096 responses on IPv6 were fragmented. So low numbers, but it's still in the millions if you count the packages. We looked into the distribution of the size of the DNS datagrams that are being sent for responses. This is the picture for IPv6. And as we see here, the large majority of all responses are below the Ethernet MTU, and most responses are even below 1,232, which is the size that we can say is guaranteed to never fragment in in the normal internet if we have the normal MTUs of IPv6 or IPv4. And this is the picture for IPv4, which is very similar. And we looked into the size of the EDNS information that the authoritative servers advertise to the outside world, meaning that how large of responses are the authoritative servers willing to send back. And the good news here is that about 50% of all authoritative servers have already tweaked their configuration. Now I have to say that this measurement has been done in early 2020. That was before the DNS Flag Day, and that was before the open source and some of the commercial DNS vendors changed their settings on the eDNS buffer size. So still before that, around 50% of all operators have changed their configuration to a more sane and more safe configuration. Next, if the eDNS buffer size is setting low, it will create more TCP traffic, because then responses that don't fit into 1232 byte or 1500 byte, whatever the configuration is, have to be queried over TCP again. And then the question is, how much of the authoritative servers in the internet support TCP today? And we used again the Open Intel system for that, and we tested out how many of the authoritative servers really are supporting TCP. And we found out that 90% of all the domains that are in the Open Intel dataset, they support TCP on all their DNS servers. However, roughly 2.4% of the domains, they have no DNS server supporting TCP. And that rules out TCP as a mitigation technology for the spoofing problem and the IP fragmentation problem, because that would cut out these 2.4% of domains in the internet. Are these important domains? We looked into this, and we found that at least during the measurement, live.com, office.com, and yahoo.com had some of their authoritative servers not responding to TCP. And 1.5% of all the domains in the Tranco 1 million list of popular domains, of the 1 million most popular internet domains, have no server with TCP support. And this is a plot that shows where these servers are. So we can say that in the first 10,000 or so domains, the picture looks good. They have TCP support, but then in the remaining part of the 1 million, it's a mixed bag. There are evenly distributed domains in there that don't support TCP. The conclusion is that there are a few but still popular domains that don't support DNS over TCP. So the usage of DNS over TCP as a mitigation for these fragmentation attacks cannot be recommended. Next, we looked into which operating systems are vulnerable for ICMP spoofing. Remember, the attacker needed to lower the path MTU towards the authoritative server in order to make fragmentation more likely, more easily happening. And we looked into popular operating systems to see whether they are being able to attacked by spoofed ICMP error messages. For that, we created a test setup, and we sent spoofed ICMP error messages, and then we sent a DNS request to that authoritative server for a resource record that we have planted there that was just below 1,500 byte, which is the Ethernet MTU, and we looked whether that came back fragmented. And we found out that the Windows operating systems and the BSD operating systems are not vulnerable for ICMP, spoofed ICMP error message. messages. It was not possible to lower the path MTU for IPv4 there. But for older Linux kernels, they were vulnerable in such that we are able to lower the path MTU to roughly 500, what is it, 552 bytes. And that creates the possibility of IP fragmentation attacks there. And these older Linux systems are, for example, Ubuntu 14.4 and 16.4, the LTS versions, and Red Hat Enterprise Linux 6 and older, which we still see some in the internet. And the question was, how much of these older Linux systems are still being used in the internet as DNS servers? And this is the point where our research goes a little bit away from the real scientific approach, because we used a query for the version.bind name in the chaos class to figure out which operating systems are used. So now with this query, we only see the bind name servers, and we only see the bind name servers where administrators don't change the version number. But still, this is like the lower bound of operating systems that we see, because the popular Linux distributions, they encode the version number of the operating system in the version string. So you get something back like bind 9.11 EL6 or EL7, and that tells you that this is a bind 9.11 running on Red Hat Enterprise Linux 7. And we could, with that, figure out how much of old Linux distributions are still used for authoritative DNS servers in the internet. And we found out that at least from the bind name servers that we have seen, Red Hat seems to be more popular than other Linux distributions. So we've seen 28.2% of all the servers that we have created were running some kind of Red Hat Linux, and 11.5% were still on Red Hat Enterprise 6, which is one of the vulnerable kernels in there. There was 14% EL7 and small 0.2% of the new Enterprise Linux 8. And there was less Ubuntu. There was 2.9% of Ubuntu servers and roughly 1.5%, which is combined Ubuntu 14 and 16, which are vulnerable, could be found in the internet. So that is, yeah, still some 15% of machines in the internet, authoritative servers in the internet, that are potentially vulnerable for these kind of attacks. And that opens the question whether it is wise security from the security point of view to run long-term supported Linux systems in the internet, because this security problem is not something that has been like published as a CVE and has been patched. Is something that has been changed in your Linux kernels, unrelated to the security problems, but still the combination of running DNS software on all the kernels creates a security problem. Then we looked into mitigations. So what kind of mitigations are available? What is the impact of performance? And what is the current support in popular DNS server software? And mitigations which are already implemented and widely distributed in server software, we rank them higher than mitigations that have to be implemented first and then have to be rolled out in the internet, because we know that can take years for a new feature in DNS software to be rolled out in the internet. In order to test this, we built a small scale model of the DNS part of the internet, which we do, or we have done in the past, to do proper scaling of resolver infrastructures for large ISPs. So we know that the performance numbers we get from the testbed are comparable to the performance numbers we get in the real world, because we have done this kind of performance testing for large ISPs in the last 10 years, and we then were able to compare the numbers we had in the testbed with the numbers in the real situation later. For that, we built an array of authoritative servers that were hosting a root zone top-level domains, roughly the same number of top-level domains that we have in the internet, and then second-level domains. And we created a mix of DNS sec zoned and non-DNS sec zoned, comparable to these in the internet. We had a large DNS resolver in the middle where we tested the mitigations, and then we had another array of clients which need to be much larger than the authoritative servers and the resolver to really saturate the resolver there to find out when do the stuff breaks. And these are the mitigations that we tested. We already ruled out TCP only DNS servers because there are too many DNS servers out there that don't support TCP, but we still wanted to know what is the performance impact if we run DNS just over TCP. Then we are also interested in how about TLS, DNS over TLS, DOT, TLS 1.3 being highly optimized. What is the gap between pure TCP and having TCP plus TLS in there? Then we implemented something that we call opportunistic TCP. That was implemented together with the good guys at NLNet Labs in Unbound. And opportunistic TCP is that we first try to resolve a query over TCP. And if we reach an authoritative server that doesn't support TCP, we do a fallback on UDP. With that, the idea was that all the servers, the 97% of servers that support TCP, are protected against these kind of attacks, and only the remainder, the 2.47%, they are still open for attacks, which is a better situation than today, where all the machines are possibly attackable. Then we looked for using UDP only for the small responses, that is responses smaller than the regular MTU that we see in Ethernet networks. We also tested what happens if we just throw away all fragmented packages, all fragmented answers coming back to a resolver on the firewall level. And if we just throw away smaller fragments that cannot or normally does not happen in Ethernet networks. So everything that is below like 1,500 bytes, if we throw away that one. And the last one is something that was suggested by Mark Andrews of ISC, that is signing all the DNS responses with a well-known TCP key, because that creates some random stuff, a signature, which is at the end of the DNS message, which is always in the last segment. And that is much harder to spoof and to guess from the attacker's point of view, and that can also mitigate these kind of attacks. And here's the performance numbers that we found. For running DNS over TCP, we found that we have a performance loss of 44%, if I see that correctly. And with DNS over TCP and then TLS on top, there we see that TLS is quite optimized. It's just another 4% more loss, so minus 48%, but still minus 48% for DNS is not acceptable. We want to have our DNS quick and fast and lean. And then the opportunistic TCP was even worse. That was because if a DNS authoritative server didn't support TCP, we had to wait for a timeout. And then we would requery over UDP, which resulted in a performance loss of 76% compared to classic DNS over UDP. Then on the positive side, if we use UDP just for the small responses, meaning for responses which normally don't fragment in Ethernet networks, we had a slight performance increase, not much, roughly 5%. And that might be because DNS servers, the authoritative server and also the resolvers have less data to process. Because authoritative servers, if they have a restriction on how much data they can send over UDP, they put less data in, for example, the additional section. And that is maybe less work for the servers, resulting in this little speed up. If we throw away fragmented responses on the firewall level, we also see a performance increase just a little bit, 47%, but still good. And what we found out is that if we throw away the data, and then the popular DNS resolvers that we used to test in our testbed, which were Unbound, Bind, Power DNS, and Microsoft DNS, and not resolver, what they do is that they remember that a certain server is not reachable with the normal eDNS setting, and they fall back to the classic DNS over UDP with an eDNS buffer size of 512, so a maximum answer size of 512. That results in even less data to process, hence the speed up. And then the few TCP connections that resulted from that didn't have a large impact on the performance here. With the dropping small fragments only, we had even a higher speed up of, 5.8%. And using TSIG, there was only 0.3% speed up. I think that is just a measurement flex. So seems to be that if we use TSIG to secure DNS between the resolvers and the authoritative server, it's the same as the classic DNS over UDP, so no speed up and no losses. So our recommendations for these tests is to use DNS over UDP for the small responses only, meaning for responses that don't fragment, that are guaranteed to don't fragment. If you do that, you can safely drop all the fragmented answers on your firewall level, because there's no legitimate reason why there should be fragmented answers anyway if you have this setting. And we communicated that to the people who planned the DNS Flag Day, and also that was a confirmation for what people in the DNS already knew quite some time, that it's a good idea to limit the DNS responses to 1,232 or similar values, which was then the recommendation on the DNS Flag Day 2020. So conclusions here. It's possible to attack DNS content with fragmentation, with IP fragmentation. The amount of natural fragmentation is minimal, but still significant. Even popular domains are vulnerable. It's not just the little home pages, it's large corporations that are vulnerable. And fragmentation should be avoided and can be avoided. There is a mitigation already built in every DNS server out there. It's just a matter of creating the correct configuration or updating to the latest version, which has the new configuration, the new defaults already built in. And of course, these mitigations that we looked into are just working against the effects and not eliminating the cause, meaning you should really deploy DNSSEC, because if you have DNSSEC deployed on your authoritative zones and also on your DNS resolvers, this cannot happen anyways, and you don't have to really fear any of the spoofing attacks. And that concludes my little presentation here, and I'm happy to take feedback and questions.
Thank you very much. Okay. So just as a reminder, we do have a text Q&A if you would like to submit your questions via text, also very useful for those of our remote participants. You can use your phones to add yourself to the virtual queue, as currently nobody has done, or you can come up to the microphone as you are. So first question.
I was about to add myself to the queue, but thank you. Jelte Jansen, SIDN. I have, first let me thank you for this comprehensive and extensive work. It's really great stuff. I have a question about one of the first slides, the vulnerable resolvers. You mentioned that it's much worse for DNSSEC signed zones, but would resolvers that do not verify DNSSEC also not ask for DNSSEC records in their responses, or are there so many that do ask for them but don't validate?
My knowledge, and please correct me everyone here if I'm wrong, is that the popular DNS resolvers, even though DNSSEC validation is not enabled, they still ask for the DNSSEC data by setting the DO flag, the DNSSEC flag, so they get the DNSSEC data, the signatures, everything, but they don't do anything with that. And that creates this vulnerability for them.
That's how many can be configured. I'm not sure how many are, so that's why I ask. But yeah, so enabling the DNSSEC is always the answer. Okay, thank you.
Yep.
All right, thank you. Next, Jan will be reading a question from the text Q&A.
Okay, there is a question from Kurt Kaiser. Sorry, I can't enter the queue. I have no mean to enter the queue. Sorry, Kurt Kaiser, private interest. Would DNS fragments filtering break anything? My hope would be that it does not impair DNS operations, hence can be endorsed.
It depends really on the DNS resolver software, whether it breaks something or not. We have tested with the popular open source resolvers and also with the Microsoft resolver, and there it worked in such that the products, the DNS resolver products, they always had a quick way to fall back. For example, to use a DNS query without eDNS, so falling back to the traditional 1983 DNS, which has the limit of 512 byte. There might be products out there that fail. We've operated this thing that we've thrown away fragments in the firewall on a large ISP in Europe for 3 years now, and we had not any negative effects by doing so. So from my point of view, it's safe to throw away the fragments.
Thank you.
Petr Špaček, Internet Systems Consortium DNS developer. First, thank you for compressing the analysis, and I have to say it's maybe too detailed because we should be spending energy on deploying DNSSEC, not on analyzing, you know, the stuff we know that's insecure from 85 till today. So please deploy DNSSEC to your zones and don't spend more time on probabilistic measures, because yes, even if we somehow duct tape this fragment vulnerability problem, it will still be, you know, open to other types of attacks because it's insecure by design. So please deploy DNSSEC.
Yes, I second that.
Okay, I see there are no more questions.
Also, just one remark. There is a comprehensive report about 150 pages on this research that will be published by the German Cybersecurity Office, the BSI. So if you are interested in more details, either watch the webpage of BSI in May. It should be available there soon, or if you cannot find it there, write me an email. You find me here or you find me on the internet, my email address, and I will give you the paper or the link to the paper as soon as it is published. Yeah,
may I have another one? Yeah, I was asking just another clarification question about the performance measurements. This is the performance of resolution time, right? Not performance on the authoritative side.
Yes, performance of name resolution side measured from the client.
Okay, because I would also very much be interested in what that would do to big zone servers like .nl.
Yes, a good research question for next time.
Let's talk later.
Okay, thank you very much. As Dimitrios is coming up to give his presentation, I would like to remind us that, well, there's the.
Yeah. Okay. Hey guys, it was a bit maybe dramatic title. I tried to change things a bit, and I'm glad to see you all. I'm sorry my eyes can't catch both sides of the room, so I pretend I'm looking at either. We have done, okay, yeah, sure. Yeah, I have just been looking at my own notes and let me put them here. So as I said, we've done this before, and I'm glad to see you all. I just try to give you some ideas how you can operate things when, let's say, unforeseen circumstances happen. Is this going through? All right. Yeah. So just a background, we are running the top level domain of Ukraine. I was at few meetings before and maybe have seen me before. But for those who don't know, we are a top level domain operator in Ukraine. We are a pretty small company. We have about 20 staff. And one of them, I guess I'm a CTO now, but I don't have the formal title. My title, I think, is Director of Strategy. We had done some things that were kind of preparing for us what was going on. We had a denial of service attack a week before, and some things that went down was the government domain. It was kind of unfortunate that things like that happen when you're not preparing for them. We have learned few things that prove it critical. One of them is having the team communication not using their own infrastructure. We switched to Signal chats, and I was using less and less email and more online tools like Google Docs and hosted tools, including, yeah, the Google Docs, I mentioned them. And that's something that is kind of strange feeling that you are used to have your own infrastructure and rely on your own. But when it's under attack and you don't have this separate infra, like maybe the cloud, which you should have had in foresight, it's good to have third parties. Anyway, that kind of takes the thinking of fixing your own tools versus fixing the services that you provide for the public. What happened next is more hard to describe. I was abroad when the active, as we call, military action, whatever it is, attack started. I managed to wake up pretty early in the day without knowing what's going on, and I was really in panic, like I guess most of our team. I didn't know what to do. The news was pretty grim, and I tried to reach out to everybody in the company to make sure they're okay. I kind of understood that the worst can happen. We may lose some of our staff, like really, and some of our infra, and I had no way to predict what's going to be next. The expectation of the world was that Ukraine would surrender in 72 hours, and to decrease the casualties, we just all, just give up. Well, obviously the military had their own ideas, and I had made a list of things. My main tool was Evernote. It was like doing most of my work from my MacBook and a phone. I was on a trip without my home setup. I decided this 80-20 rule is going to be like, we're going to save the most important things and the rest is just going to disappear. I created the plan to migrate most of our infra abroad in 72 hours. I think we overrun the time a bit, but I would say by end of the Sunday, which was the fourth day, so what's 96, we have done that. So I put these four things that I think as every manager, well, I can call myself a manager now, should keep in mind. You have to prioritize your stuff and also maybe customers, partners. But the whole thing we have here is not existing by itself. The goal of the society is to provide for society. If you don't care for your own people, then it's meaningless. The data, of course, is important. Like a database, is more important than the clients, right? And the data means also your financial data, your production, whatever you call it. But you have to kind of structure things that you are preparing to lose things on the bottom of the list, right? The money is something that you may lose, of course. I'm talking income, resources. You may overspend, you may overallocate. You kind of do speculative execution, like you're doing projects which you're aware would partially fail. Like, for example, I reached out to maybe 20 or 30 potential partners to help us. And I ended up surviving with like three main ones. The Cloudflare was our DDoS protection service. We have used NetNode DNS and we are still using them. We later added 6Connect. I'm grateful to folks from both companies present here. Well, Cloudflare folks too, of course. Then we used Severity as our main hosting provider, but we also had a not to be named company from Ukraine that was helping us primarily before, and they had services abroad. We had assembled, well, that was done in other presentations, so I'm not going to tell you how to run your own TLD. If you're doing that, you know what to do. If not, it's not your business, but we had certain set of things we have to take care of, and those are listed here. it was interesting to think of which data centers or which servers can go down as the military advance of Russia was progressing. Well, it was not that complicated, but as I said, we plan to move things abroad, but moving things means that you have to establish the account or create a new server, create the virtual machines on it, move stuff, and some of your people are actually in the car moving away from the zone where the active shooting happened. One of our lead developers was out of connectivity for 24 hours. She was calling me every few hours, so I was calling her and making sure she's okay. And then she's like, okay, I'm going to shut down the production and quickly migrate the Postgres primary, and then nothing happens for the next 5 hours. I'm like, okay, well, we have this secondary service, right? So it was kind of messy, difficult, stressful. I'm still recovering. It was fine when it was partially done, then a lot of loose ends. Some decisions we made early on and were kind of reinforced that what we do ourselves, what we don't do ourselves. I maybe haven't mentioned it before, but we are very BSD-centric. I made a sacrifice to migrate to Linux as a host platform for clusters. I know I'm still regretting that, but I think it was a good decision to have one main platform. So I guess simplifying the infrastructure and making sure you have less components, more standardizing is very helpful. Some things obviously are relying on the vendors, so we are not, for example, using Amazon as much, but when we do, we must use it as Amazon does. For example, I can complain a lot about the idea of Amazon virtual networking, and importing your own network blocks into Amazon is really, I wouldn't say a nightmare, but it's way more difficult. I'm planning to talk to people who designed VPC and tell them that they were wrong. Well, maybe they know this already. For example, no v6 by default unless you enable it. A lot of other v4 dependencies. These are not probably the costs, but the word cost means not just money. The word cost means at the end, your resource allocator. You're thinking time versus people, goals versus resources. What are you going to do? One lesson that I want to emphasize from here that you have to get contacts with people that you're working deeply before. Okay, you probably can get the CEO of Amazon as your close friend, but my contacts with, say, INA team and yes, Cloudflare management team were really immensely helpful. Not just my companies, my contacts, other people in my team's contacts, people who I knew helped me to reach people I didn't know. It was a lot of free help we got, and I already mentioned those companies, so I'm going to repeat their names later. It's kind of too late when you are having this situation to establish new friendships and relationships. Just setting up account, which may take a couple of business days, it just can't happen. You have to do things within 24-hour cycle. It's like the Scrum on steroids, right? So instead of a weekly loop, you have kind of a daily loop, and we have 2 or 3 stand-up meetings per day. Those are people I'm mostly relying on or were relying on, and I already mentioned some of them. The packet clearing house was their old partner, but Bill Woodcock also helped us to do some other things, which I'm not going to name here. No, nothing secret here. I just want to keep this talk short. A lot of companies that we offered to pay said, don't even think about it. Some of companies we have signed memorandums of understanding with. That includes Severity, and that includes wait, did I mention? Okay, well, let's go. Right. Sorry, I kind of got off track. Yeah, that was something I want to add. Having things in writing, not as on paper, but somehow is more important than just kind of having this warm, fuzzy feeling they are negotiated, and it kind of goes contrary to the way of using instant messenger. So as much as I recommend to not rely on well, word of mouth and having things in writing, sometimes you have to kind of trust things to be done correctly before they're done. I guess there is no right way to do it, but I try to cover up for the missing gaps afterwards. There are some few bits here, like we were updating the root zone for UA, and the people who are doing those checks in and run into some own issues. I have to escalate that to create a ticket. I have to message Kim Davis on the serial number, which I happen to know, just to push things forward on Sunday, and that was actually done. That's actually a thing that is bad working with people in the opposite time zone, right? US versus Europe, or let's say Asia versus Europe, or US versus Asia. So yeah, maybe that's a good tip. Try to concentrate on companies that serve in your own time zone or close to that. Most companies do that, but not everyone. I would like to also express my extra gratitude to people in this community and of course other communities, the Minister of Foreign Affairs of Sweden, which is what Utrikes department head. I hope I say this correctly, the Global NOC Alliance being partially present here, and other folks who gave me private advice. And I'm probably going to write longer version of this talk as kind of the document to be published on our company site. Well, the greetings go to the armed forces to actually protect my country and, well, make any possible for my own team to survive. I can take some questions and maybe, what about 10 minutes? Am I correct?
Yeah, we have plenty of time. So if there are any questions for Dimitrio?
And I'm sorry for stealing the mic of that
We're good.
table.
So.
Thank you.
So it looks like we have one person come to the mic. If other people have questions.
This one never been used before.
Hi, Tom Hill from British Telecom. I don't so much have a question as I think I just want to highlight how incredible this has been. And the work that you've done is probably one of the most amazing examples of internet architectural resilience that we've ever seen. So you've already said thank you to everyone, but thank you to you in particular.
Thanks. Well, I appreciate your words. I should mention we are an ISP, but we did rely on Ukrainian ISPs, and yes, those guys were really resilient on their own. And I hope they would come someday and speak about their role and their actions. Please.
Jim Reed, speaking for myself. Dimitri, I think you and your colleagues have done a wonderful job, and I cannot imagine the stresses and hassles you've had to cope with over the last few weeks, and it's very impressive the way you've handled this, so well done. One thing though I would like to move on from this little bit is that even though this situation is almost unprecedented and it's unthinkable what's going on in Ukraine right now, it does highlight that this business of running core internet infrastructure is now becoming much more complicated, it's becoming much more visible, and we all need to think much more about business continuity, disaster recovery, and even if the circumstances are never ever going to be as extreme as what's happening in Ukraine right now, I think everybody that's running internet exchanges, TLD registries, Anycast instances, root servers, blah, 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 need to start thinking about what happens if something really bad happens. And the really bad things are happening isn't some idiot with a JCB digging up a bit of cable or a power supply going out. We have to think about things, as you mentioned, people in particular. How do we keep them safe? What happens if one of those key people in your organization becomes unavailable for whatever reason? These things need to be thought about, and we need to think about having procedures and mechanisms and also drills to actually test these things out in practice. What do you do, for example, if you can't communicate with your organization because signal's gone away? What do you do if you can't use voice over IP or whatever? These things need to be looked at, and you need to think about backup strategies, defenses to these things in the future, and that applies to everybody, not just to what's going on in Ukraine right now. But again, thanks for all you've been doing, Dimitri. It's fantastic work.
Yeah, thank you. And I'd like to express gratitude to folks in the RIPE community, as I said, and many of people who I knew gave me their own personal advice and kind of been mentoring me and continue to do that. And yes, DRP is very important. And I think you can drill for the war, but you can drill for, I don't know, part of Infragunda. Please say what you want.
Dima, I would like to relay some comments from the online thing. And Kurt Kaiser is saying that the functioning of the internet for Ukraine is essential for not giving up and resisting the aggression. Great work. And Brett Carr is saying, great job from everyone at UA, an example to us all. Thank you.
Thanks.
Okay, thank you very much.
Yeah, and thank you, Peter, for your PC service. I know you're ending this meeting as a PC member, so my thanks to you and congratulations for the work.
Thank you. That's a fantastic segue to go into that we are having RIPE PC elections this meeting, as we always do. This will be my last meeting on the RIPE PC. I will term out. So we guarantee there will be at least one new member of the PC. If you are interested in volunteering yourself or volunteering a friend of yours, please check out the RIPE 84 website. We have a link with the explanation of what the responsibilities would be and how to apply. I believe the deadline is 15:30, so the end of the first afternoon session. And with that, I believe we are done with the session a little bit early. So go enjoy some lunch. See you all later. I've turned
Welcome to the Tuesday afternoon session of the RIPE 84 plenary. I'm Wolfgang and I'm going to chair this session together with Jan. And one word in advance, you can still put your name into the hat for the PC elections. Just check the website, what is required, what the program committee does. And if you're interested, just send an email. And with that, I'd like to introduce the first speaker, which is Stefan Schröder of Binox, and he is going to talk about the invisible impact of network handovers within content delivery.
All right. So welcome here, everybody. Thanks for having me, actually. It's great to be, well, back in the personal meetings, and obviously great to have you here in Berlin. So that's our hometown. So I'm from Binox. Binox is a spin-off of DT, and we are focusing on flow optimization and visualization for network analytics. So what I want to share with you today is a couple of experiences we've made during the last couple of years, actually, in scaling up networks to deliver all that predominantly streaming media into, say, subscriber access networks. And actually what typically fails and works well in the handover between CDNs and networks, obviously larger networks where you have choice of ingress points to select from. Good, I think I need to check this one here. Okay, that works. So what we see actually over the years, the past years, and I think that will likely continue, is that we have a trend to the edge, so that more and more content and also compute power will actually move deeper into the networks. And what we also see, well, alongside that trend, is that over time this will shrink the backbones. So there are a couple of positive elements in actually deploying content closer to the edge. It's good for customer experience. And if it's done right, it should also actually enable reducing the cost of traffic delivery in the networks themselves. On the other side, you need to allow for more headroom or install more headroom because you dedicate it closer to a user group, so you can't actually overbook that much. And currently, we also see that failover concepts are either non-existing, say, synchronized failover concepts are non-existing or poorly aligned. I think one warning actually stands here: the backbones will, over time, actually shrink to a level where they are not able to hand over the entire traffic from one region to another anymore. Or if we don't do that and don't shrink it to that level, we'll just not enjoy the savings which all that edge installation actually should bring over time. So that means localization and stability of localization actually will be key to make sure that that delivery actually works fine. So I have an example here how that actually can fail and how that then looks in a network. So that's actually a multidimensional flow view of traffic. Actually, that's about 2 weeks old, so pretty recent. What you see in the different dimensions here, not sure if I think I have light. So this is actually the source of traffic. So that CDN is delivering their own traffic here. They have, say, 2 handful of ingress points with that network. Then you see here, these are the link starts of backbone links, which then go into a random region A of that network operator here. And then they distribute among a couple of hundred BNGs into the subscriber base. So that's actually, say, a typical example of how traffic would get allocated. You would probably start wondering why is that CDN actually using all of the different ingress points to deliver traffic into that region A. That could be for load balancing or whatever. If you actually look at that on the timeline, it turns out this is more random. So this is a 1 week time frame now, and the relative distribution into that region A by ingress point. So what you see there doesn't seem to be a concept behind it, or that CDN's mapping algorithm is a bit confused by whatever. But actually what that does with the network is that the network operator needs to maintain 3 times the capacity of that, say, egress capacity in that region from all the different ingress points on the backbone, because just within a single week, all of that capacity was utilized on 3 different routes. So that obviously is a pretty bad example how localization can work, because if it's just flipping around like that, there's just no way that you can reduce the backbone capacities accordingly. So that means when you actually start investing, regionalizing servers and doing all that effort to get into the edge, make sure that your localization actually holds up. So why is localization important? There are 2 elements to it. The one is there's user experience involved. So we obviously have network distance. We also have hop counts. Then that typically comes to, say, network expenses on the operator side. So it is actually a relevant factor and can be measured as well. This is obviously not a new topic. So there are different, say, solutions and workarounds how to address that mapping question. A lot of CDNs still just simply do Anycast. That means they just reply to the request at the location where they receive the traffic. Pretty easy. Problem is you can't really do a lot of load balancing. You need to hold the content everywhere. So there are a couple of downsides with that as well. Some operators and CDNs agree that they would virtualize DNS locations or just say, well, I have a location or DNS which represents a full region. Needs a lot of configuration, and we see that in real life that doesn't seem to work as promised. Larger CDNs do just ping the world and do round-trip measurements all over. Comes also with upsides and downsides. Others buy external geo-IP data or determine that themselves. And what we actually do with a couple of CDNs for the DT network is that we exchange real-time data to actually then base it on the ground truth where actually traffic should be delivered from. I take the highlighted ones like the virtual DNS and the DNS related mapping and the external geo-IP as examples for some observations we made. So identifying DNS resolvers to locate users has a couple of upsides. The one is you only really have to manage just a couple of handful of addresses, so that's pretty easy. The DNS locations are fairly stable, easy to communicate, so it's very straightforward. And you also don't need ECS or EDNS 0 activated, so that also keeps the cache hit rates at the resolvers pretty decent. What we also see on the downside is that DNS resolvers typically are, well, you have a primary, secondary. That secondary may not just be in the same location, so that might be far off. And it also fails for DOH and also for smart TV DNSs, which are hooked up to whatever Coranian operator you would have. So it's not really a fantastic solution. I have 2 examples what also goes wrong there. So in the top graph here, you see this one. That operator had historically configured their DNSs on the mobile network in a round-robin load balance. That was pretty nice to start with. But once the CDNs actually started relying the mapping on the DNS location, they were obviously tricked around all the time. Was not easy to determine that, so you need some sophistication in tools to actually see what's happening. Obviously, once that was repaired, going back is this one. Once that was repaired, it obviously then became far smoother, and you see also the impact on quality of experience here. So there were a couple of outliers in TCP handshake duration, and that actually got repaired pretty quickly and actually was within expectable levels afterwards. Another one here was that for a couple of handful of BNGs, there was just a very far remote DNS server configured for that subscriber base. Well, that happens, 6 finger problems. It also needed some investigation then to identify these things. So the users in a random city, some of the population there just had a pretty poor experience because traffic came from the other corner of the country. Interesting here is there are no daily forced cutoffs anymore in broadband subscriber lines. So it took actually more than 2 months to age out. after that was reconfigured, because all the subscribers obviously had to have a downtime once, so that the home router would actually get a new DNS assigned. So these things happen. Good if you can identify them, and then obviously different ways to repair that stuff. Then getting to the second example on how mapping is done, geolocating users. The good thing is databases are broadly available. It's pretty straightforward, and it seems to work. But I think I clearly recommend to double check if it's really working. And there's no active engagement needed between a CDN and an ISP. So that is actually specifically if you cover a whole region with hundreds of ISPs around, then this is yeah, pretty straightforward way to go. There are a couple of downsides to that. A very frequent one is what you get as announcements on your eBGP doesn't really equal the iBGP allocation in the network. Then you have an update delay if something is refarmed or reallocated. And then geo distance doesn't always equal network distance. And I have an example for that here. And also the round-trip reality, specifically outbound paths, if you have asymmetrical paths, is an important thing to consider, also in my example. So the first iBGP versus eBGP. So what you would see on the route announcement on your peering or interconnect position would be, I've just taken a whatever /12 here, so that's about 1 million users or addresses here. And if you have the, say, the average rated location, that would probably be Braunschweig in Germany, just as an example here. But in reality, that prefix here is actually allocated above 220 say major prefixes in the network, and they literally are spread over the entire country. So you see here the different core locations of that operator, and well, if they are dark green, then they have about 100,000 users allocated. So that's actually how the network looks from the inside. If you now try to figure or send everything to Braunschweig, it's probably wrong in most cases. Another topic, what I said, is that aging out here. That is an example of a major video player who was pretty accurate actually with his regionalization and location. Problem here is, well, there have been specifically before prefixes get actually reallocated every now and then because there's just scarcity around. So the traffic you see here is actually traffic into a region of that operator, which comes from a remote ingress point. So traffic which shouldn't be there in a properly localized situation. But then all of a sudden it pops up, and it takes actually 2 weeks for that video company to recognize that this IP prefix has changed. It's not too bad. 2 weeks is pretty good. With some geo IP data providers, it might also take a couple of months even. So better check also the speed of update you would get if you have a geo IP provider there. Then actually phase 3 here, and I think I just spent a bit more minutes on explaining what happens here. So the first step is obviously you have been able to break down that /12 into the /20s which are allocated into the different regions. And I now have an example here also from Germany. So that's Heilbronn, sits between Frankfurt and Stuttgart. And then you identify a couple of prefixes for end users here. So in the second step, you need to make sure or decide if you actually serve that these subscribers from Frankfurt or from Munich. So 2 ingress ports you have available. Then you take a geolocation measurement here and see Munich is 414 kilometers, Frankfurt is 234. Seems like an easy decision. That's 80% more from Munich, so you take Frankfurt. If you actually had insights into the network topology of that operator, you would see that the traffic from Frankfurt actually takes a scenic tour and goes to Stuttgart first. So that's uplinked to Stuttgart. So now the difference is not that obvious anymore, because Munich, Stuttgart, Heilbronn is 460, and Frankfurt, Stuttgart, Heilbronn is 390. So that's pretty close already. But now the biggest problem comes, that's the outbound routing path. So in reality, that operator is egressing their traffic to that CDN in Munich for whatever reason. So what you see is from Munich, Stuttgart, Heilbronn and back, you are at the 460 kilometers which we had. But then the traffic from Frankfurt actually goes to Stuttgart first, goes to Heilbronn, goes to Stuttgart, goes to Munich, where it's egressing to that CDN. Well, it's a session, so it needs to get back to the server in Frankfurt, the scenic route on the CDN's network. So in total, you end up with 735 kilometers, which is 3 times what you expected in the first hit. So you see, well, geographical distance really is a pretty poor representative for network distance. For 2 reasons, the topology might be different and also the egress routing. And just to prove that this is actually, that's a factual case here. So that's a screenshot of that traffic actually. You see 99% is ingressing in Frankfurt, goes to Heilbronn, and then this is the egressing portion of it, and 76% of that traffic actually egressed in Munich and then had to be carried back. So these things happen. Visibility helps a lot, and then also, yeah, just awareness and collaboration between CDNs and operators to, yeah, make that as efficient as possible. And we see, well, with huge events now, we see traffic levels which probably will force all of us to be more efficient with the network resources we deploy, and just to be able to carry all that traffic. And I think localization and that traffic management and traffic engineering becomes an ever important element of the game here. Okay, so that's it from my side, and I'm open for questions now.
Okay, thank you very much. Any questions? There is nobody in the queue online. Nobody's running to the microphones in the room. Are there any questions in the QA section? I think everything was clear.
Fantastic. So if there are any questions popping up, just stop me in the show. I'll be around. Okay.
Thank you very much.
Thank you.
Okay. While the next presenter is getting ready, I would like to remind everybody to rate the talks. You can rate also talks from this morning if you have not done so. And still, you can put your name forward for the program committee. And I see Matthias walking up the stage. So I'd like to introduce the next presenter, which is Matthias Wichtelhuber of DKIX. And he's talking about peeking into black boxes, automated fuzzing of router resource usage. Matthias, go ahead.
Thank you, Wolfgang. So obviously you can hear me, that's nice. So this is joint work with appreciated colleagues from RWTH Aachen and from DKIX. And actually what we did there is on the title, we're trying to peek into black boxes, which are the routers that every one of us is using, and trying to find out how they internally map their resources to configurations and vice versa. So why are we doing this? So you are all probably operators of some critical infrastructure. So you all know that doing changes to critical infrastructure requires thorough testing. Everyone who has committed a change on Friday afternoon and had his weekend plans canceled afterwards knows that. So one thing that is often a blind spot in router or in test plans is the resource usage of the boxes actually. So how are your configuration changes laid out to the internal hardware resources of the box? Or more detailed, where are the router's limits? For instance, TCAM space. TCAM is a very good example here. It's the hardware part of the router that is doing the header matching and is used for all the forwarding of the box. So this is a critical structure, and that is something that we would like to measure here. Also, you're probably aware that like networking hardware has a certain life cycle, so you want to make sure that you can use your hardware for, let's say, 5 years or longer. So you still want to know whether you have enough headroom for future innovation. If you do feature X now, you still want to be able to do feature Y in 3 or 4 years. So we found it really difficult to look into these issues, and we are also probably at DKIX running into these issues a bit more frequently than other providers, because we're always doing things at scale and in very dense deployments, often doing it in a way that is not necessarily anticipated by the vendors. And so why is it so hard to measure that stuff? Well, vendors, at least to our experience, are pretty tight-lipped on hardware resources. One point there is that you do not want to make yourself comparable to competition. The other thing is that this is a really complex topic, because you're already starting with some deployment on your platform, so you also already have a certain base resource usage. Then there are different features everyone can use, and it's really not easy to give a satisfying answer there. Let me give you a little anecdote on that. A few years back, I was sitting in a meeting with a few engineers from a vendor, and we were discussing a certain configuration construct. And I asked them, so how much of this can I use? If I'm applying this to every port, will this still work? First answer was, okay, we cannot tell you, like it's like sort of NDA. Then after I insisted a little bit, they told me, okay, of course we have this information, but it's like a 50-page Excel sheet and it has 300 footnotes and nobody really knows how to read it. Of course, there are some people that know in the company, but it will be really hard for us to find them and to finally tell you about that. So at this point, I realized that we probably have to do this on our own. And what we did there is we applied something that is well known in security testing. It's called fuzzing or fuzzy testing. It's an automated testing approach. And the idea in the security context is that you generate a lot of random inputs, more or less random inputs, throw it against some implementation. And then you monitor the implementation behavior and look whether, for instance, the software seg faults or shows any other unusual behavior. And we are adopting this approach, but we are not looking for the next buffer overflow in the router OS, but we are trying to find the hardware limits of the router under test. So the general idea here is like we're generating masses of guided valid configuration changes, scaling up resource usage on the box. We measure the router behavior during deployment and check for any runtime errors and exposed hardware counters as far as we can scrap them from the box. And we correlate the configuration changes in the measurements and identify the scaling behavior and identify possible bottlenecks that appear during the deployment of the changes. I came up with a couple of scripts for that. The first version was cobbled together in an afternoon, and meanwhile this has developed into a little framework, which I call the Fuzzing framework. So the design is a modular 5-stage framework. It's mainly based on Python and Jinja 2 for templating. So this is a templating engine. I will get on that to that in a minute. It's quite flexible and adaptable. Could be adapted for different vendors, and most of it is plugin based. The idea here is that you can push in an existing production configuration, extend it as required by the test case. So you're working from a valid base, and you can evaluate the scalability of single routers with it. That means vertical scalability, not horizontal scalability, like adding more boxes. We really want to know how far the single router scales. And the design goals here were we wanted to automate repetitive tests. So we're really generating large amounts of configuration changes, usually several thousand configuration changes that we are applying here and measurement points. And the idea is that in the end, you can visualize and identify the bottleneck resources in the router. And you have some support by the framework in all stages if you're working with it. So really keeping away the repetitive steps from the person that is using this little framework. So let me guide you a bit through the framework design here. So we're starting with the first stage, which is parameterization. So usually the user will provide some sort of production configuration from a running router that we are going to test. And the first thing that we do is like we take the production configuration and do sort of a configuration parsing. That sounds actually bigger than it is. What this actually does is it converts the usually sort of tree-based configuration file and makes it traversable and easily walkable for the following code. And this like tree data structure that we create out of the configuration is called context. It gives you all the main information to work with in further stages of the framework. And also you can add here the scaling parameters. So actually the parts of the configuration that you want to scale and test. And additionally, we have the base configuration, which is usually just a copy of the running configuration. This will always serve as a basis for the tests. So this is our clean environment from which we are rolling out changes. In the second part, we are doing the actual scaling of the configuration. So what you see here is on top the context, which is actually the parse configuration. So here you see one part of it. For instance, those are policies, forwarding policies that are were found in the actual configuration. You see there is a pretty simplified example, but it's going from policy 1 to 6, 7, 8. And what the user provides actually is the Ginger template for providing an extension configuration on top of the base configuration. So what you can do with this templating engine is you can mix Python code with configuration stuff. And then you can like traverse this context here and can add new items at certain parts of the configuration. For instance, here what we're doing, we're traversing all the policies that you find in the context here, and we're adding new policy ID and description here. So it's just a very simplified example. And what that gives you is actually a rendered extension configuration, which you see here on the right, which would in that case add a description to each of these policies that we found in the context above. So a simple way to extend the running configuration here. Next step is rollout. So what are we doing here? We're applying the configuration on a test router. From the parameterization, we get the base configuration and the extension configuration, which is doing the upscaling of the configuration constructs that we actually want to test. And we're simply rolling out that stuff via SSH. So during the execution of during the application of the configuration to the box, we gather all the logs. Like for instance, did the CLI at some point say, okay, I cannot apply this anymore, I'm surrendering? Any errors, and also occasionally you found like things like hardware counter dumps for certain resources that are used during the application of the configuration. So we're scrapping essentially everything we can get from the box that tells us something about what the box is internally doing. SNMP counter, CLI output, whatever we can grab. And afterwards, we create a clean test environment. That means we are either rebooting the router or we're rolling back to the base configuration if that's possible. And this gives us a clean environment, and we repeat the step until we're done with all the extension configurations that we wanted to actually test. And the output of this is execution logs, error logs, resource dumps, as I said, whatever we can get there. This can be quite a couple of hundred of megabytes of measurement data. In the last step, we're doing a data cleanup. So usually up to this point, you will have the error dumps in some vendor-specific format. And what we're doing there is we're standardizing the output and create a data pool, combining the data from all runs. And in the end, we end up with something like here on the top right. So we have a description for resource X on line card, let's say 20 here, whether we had an error during the application of this whether we had an error during the application of this extension configuration, and the error description as far as we get one. So as I said, we're trying to grab what we can get. And in the final step, we are doing things with the data. So we have, currently we have two data consumers here. One is a visualization. So what we can do here is we can generate plots on measured errors, and we can visualize the resource usage. And usually this will give you something like this plot here in 2 dimensions. So let's assume we have scaled 2 parameters of the config, which are X and Y. Then you will get here a visualization of areas that are safe, areas where you're getting close to the border of what is possible with the router, and the white area here means applying this configuration failed, and you ran into some resource problem on your router. The other nice thing we can do with this is once you have the data, you can do sort of predictive modeling. I will go into detail on that a little bit later. But you can use nice machine learning models, like for instance, decision tree models, and provide flowchart-like predictions. And we found this quite useful for management and doing sort of predictive maintenance without actually looking on the box. I have a separate part on this in the talk, so that will get a bit clearer in a few minutes. So, quite a bit theoretical up to that point. That's why I chose to show you a little case study here. So what this case study here is called Quoz and Eccles for traffic filtering was the use case here. So we wanted to test whether we can drop DDoS or other unwanted traffic at the IXP at scale. And the question here was how many Quoz policies and ACLs per Quoz policy and port can we apply before running out of resources? As I said, we're doing this at scale at DKIX. We have at some locations, we have very dense deployments with a lot of ports. And this is really a relevant question here. So how does the resource usage scale is one of these questions here, and the other is what are the bottleneck resources actually? The test setup here was a complex service router with multiple line cards. As a base config, we used a production configuration of a multiple terabit router with more than 100 configured ports. And we generated extension configurations to scale the number of Quoz policies and the number of IP filtering rules or ACLs per Quoz policy. So, of course, you know, vendors are picky when it comes to NDAs, so I had to obfuscate some of the X's here in the following. Forgive me, but that's a necessity, but it gives you an idea of how it works in general. So, so let's first talk about the timescale of the experiments that we actually ran in the lab. So you see here a table with different runtimes for experiments with different resolutions. So the one thing you need to decide during the parameterization stage is what resolution you want for the data points you're actually measuring. So we chose here for the experiments a resolution of 10. That means in each configuration step we're adding either 10 Quoz policies and/or 10 ACLs per Quoz policy. And with this resolution, we were able to generate roughly 2,300 data points within 24 hours. And the nice thing with the framework is you get into the lab in the morning, you parameterize your stuff, click enter, and then you do something different. And the next morning you get your results. So this time here includes everything: configuration scaling, rollout, data collection from the box, and the environment cleanup. So what turned out is that environment cleanup is really the part that is consuming the most time here in these experiments. So this can really break your neck. It's the difference between hours and days. So what we have tried so we have implemented 2 things here that we can do. One thing is rollback to the base configuration, and the other is reboot. So you see here a little plot on, the pointer here. So you see a little plot here on the difference in time. What you see on the y-axis here is the time to apply a certain configuration and roll it back to the initial state. And on top, you see the time that you need for reboot. This one is pretty constant, around 50 seconds in our case. And the other is the rollback time. And one nice thing about using rollback is you see here that the the time is here gradually increasing depending on the size of the extension config that you're actually applying to the box. And at some point, it starts to plateau. That's where the red marker here is. So this indicates large failing configurations. And but you're very fast with rolling back to the initial state here, because anything that goes beyond can't apply is not applied at all, and you can immediately roll back to the base configuration here. And with rollbacks, we found that we are at least 2.5 times faster than with reboots. For the experiment we had before that, that would mean 2.5 days versus roughly 1 day. So quite a speed up. So once you have gathered all the data, you can start to drill down the data with respect to different criteria. One thing that we could do here, because we had really a resource dump here, also with upper limits for certain things that we could scrap from the box, we could really identify the resource that was here, the bottleneck resource. So I had to obfuscate them, but you can imagine there are different types of hardware building blocks, and each of these A, B, C, D represents one of the building blocks. And in this case, we immediately saw that resource A here is a problem. And once you have identified that, you can drill down this specific resource that you identified as a per line card. So that is also really interesting, because of course in a big service router, different line cards have different configurations and different resource usages. So using this method, you can find out that the most likely to fail here are line card 1 and line card 2. And in line card 4, you're pretty safe. An additional thing that we found out to be while playing around with the data is that you can actually do something like monitoring without measurements. So this is sort of predictive maintenance here. So the idea there is that you look at the production configuration and you simply extract the scaling parameters that you had in there in the example before, and that would have been how many CVOS policies and how many ACLs per CVOS policy do we have here. And you can use this as training data for some machine learning model. And after you have trained the model, you can simply put in the production configuration and predict the resource usage. So pretty nice for doing predictive maintenance, and also very nice for mitigating problems even before the deployment. So you can see whether you might be running into some problem even before you roll out the configuration to production. So what does that look like in detail? Here's an example for that. So what we do with the data set is we are training a decision tree machine learning model. I'm very fond of decision tree models because they remain understandable, at least until you are in a certain depth of the tree. So what we're doing here is we're learning on a trained test set split of 70-30 of the measurement data. And we can reach very high prediction accuracies up to 89% and more, 98% and more. So what you see here is how the model actually tries to approximate the resource usage of the box over different trees of over different depths of the tree. So we're starting here with a maximum depth of 1, which is essentially approximating just a line at either horizontally or vertically. And even that is pretty valuable, because this immediately gives you a safe area. So you know if you're staying below this black line here, you're safe no matter what you do in the other dimension. And as the depth of the tree here increases, you see that, well, you have a trade-off of understandability and accuracy. So 2 and 4 is still pretty understandable. With a maximum depth of 4, you reach a accuracy of 89% here already, which is probably enough for most cases. And depth 8, you don't gain much accuracy anymore, but you really start to lose track on what is actually happening in this model. Quick wrap up. So testing is crucial. And vendors are very tight-lipped on hardware resources, so resource testing can become pretty complex pretty quickly. Our solution to this is this little framework for network resource testing automation. We can generate really a large number of configuration changes and data points within a day, so smaller than 24 hours. We can identify bottlenecks per router and per line card, and we can create pretty accurate and human-readable prediction models, which is really a win here. And we have applied this general method in practice at DKIX. So one thing is assessing configuration changes for dimensioning products. The other thing is often you work with simulated routers in labs. So this was also pretty nice to apply this to compare simulated routers versus real hardware. Yeah, also quite nice results on that. And also what you can use this for is for validating claims on hardware capability that your vendor sells you. And that's all. Thank you for your attention and feel free to ask questions.
Thank you very much. Nobody in an online queue. Yeah, we have a question, please.
Hi, James Rice, Jump Networks. Actually, 3 questions, if that's acceptable.
Go ahead.
This is all actually really quite cool.
Thank you.
Lots of fun and really useful. Have you open sourced any of the tools or data sets?
No, it's not open sourced, but you can write me a mail if you're interested. I'm sure we will find some way.
Certainly are. Next question is QoS. What are you actually using it for at DKIX? Because I do a bunch of QoS for down prioritizing likely denial of service attacks. And are you doing anything similar to that?
Exactly that.
Yeah?
Yeah.
Okay. Is that documented anywhere?
We have a, am I allowed to do ads here?
I mean, it's something I've suggested to the London.
So we have, actually we have a product that is called Black Holing Advanced, which is exactly using this. I think I presented here some RIPes ago on that product. If you check the website or talk to me afterwards,
okay.
I can point you to the right documentation.
Is that an always-on service of particular traffic types, or is that just on-demand?
You need to ask for enabling it.
Right. Okay.
If you ask me, I can enable it for you.
Awesome. Thank you.
That was all 3 questions.
I guess the other one was, would you be interested in some more hardware to test? Like, you know, if the community was willing to run your tools on other hardware, having this collated somewhere?
Yeah, I mean, this always depends a bit on the workload, of course. I wouldn't say no, but I wouldn't say yes either.
Oh, also, is this on, can you give any information as to what particular ASICs this is? Is it White Box, Broadcom, Mellanox?
Sorry, I can't tell you that.
Okay, that's fine.
Okay, Gordon.
Hi. Hi, Gordon Guido Favi, Think Fiber. Thanks. Gordon Guido Favi, Think Fiber. I have a question regarding the results themselves. So you mentioned that you have anonymized or rather puzzled the results but due to NDAs. Would it not make more sense to, you know, make vendors responsible for what they claim the hardware is capable of and open sourcing the actual results?
Yeah, of course, that's wishful thinking. So if you're a big company, like, I don't know, Deutsche Telekom, maybe they can do it. But if you're smaller, I guess you do not have the lever to open source something like that. I'm sorry. I also think that it's a pity because, you know, this would be really valuable. But of course, I see that vendors simply don't want it because it makes competition comparable. So.
I see. Thank you very much.
Okay, please.
Hi, it's Michał Kedzierski from BT Island. I'm just curious, how do you do parsing of the comments? My understanding it's a multi-vendor tool. So do you use any plugins? Do you have pre-written the regex to parse the outputs from the show commands from the devices? And how do you store them as a data structure?
It's actually probably much more simple than it sounds. So most configurations are somehow like tree-based, right? And what we're simply doing is we're parsing it line by line. We're applying certain regexes to the lines to pull out the information that we actually want to pull out. And we present everything annotated as a tree-like Python structure, so you can easily traverse this. It's not more than that. So there's no lexer or parser or something like that involved.
Okay, so I have another one. In terms of Cisco, would you consider using, for example, payats, which you could define exactly what you want in the data structure, and then run in the test bed, and then run the script based on that? Because, for example, it has Genie, which is quite useful parser for Cisco.
Yeah, I mean, a lot of automation tools immediately come to mind when you look at this, right? Also other things like you could apply Ansible or something like that, right? No. But I really found it useful to work directly with CLI commands and SSH because it allows you to do some rapid prototyping, because you know none of these test cases is like another, and you have to adapt things anytime you use it. So yeah, you probably could do something like this. Would be nice to have, but in terms of rapid prototyping, I personally prefer to work with CLI commands.
Perfect. Just another one. When you're running your tests, you do this in parallel, or like you are connecting to all the devices at the same time, or yeah.
So the times I told you is just a single device. So it's a single lab instance that actually also was a pretty large lab instance. So you don't want to have two of these side by side. But of course you could you could replicate this and parallelize it. But it's a matter of cost utility trade-off.
Appreciate it. Thank you.
Yeah.
Rudiger, please. Oh, you're okay.
Yeah. Thanks. James Bensley, Sky. Thanks for the talk. Really good. I've spent years testing hardware for kind of, I guess, the same reason as you. But actually, you've done a great effort, but I question what is the point of this work. The reason I say that is because after years of testing, what I've learned is that you never ever want to run your hardware anywhere near 100% of its capacity. So I don't even care what the maximum is can do. I know two things. I know I know what I need for my network, for my users. So what I need to do is test two things. I need to test approximately the number of ACL rules or BGP rules, whatever that I need for my network, and I need to test a little bit above that, so I've got some growth room. If it works beyond that, doesn't even matter. I'll never hit that. And the second thing is, whatever your, however much you need scale from your device, that may not be how much your vendor can support as well. So really, for me, this is kind of like, you just need to know, I need my device needs to support this level. Does it support that level? Beyond that, not important. I need this level, and I need the vendor to support this level. And so I would say, if you're having to kind of do this fuzzing to work out what the device supports, really you should just say to the vendor, can it support this? They need to give you a yes or no. If not, you need to switch vendors.
I mean, you're perfectly right that you don't want to run your infrastructure at the limits of what it supports. I agree on that. So why I did it, part of that was actually curiosity. I wanted to know whether it works. Turns out it does. The other thing is, I still think it's better to know where the limits are than not knowing it. And the third point here is that I think probably DKICs and IXPs are a little special in that regard, because there are very dense deployments, as I said in the talk. And if you're thinking about like adding some, for instance, egress configuration somewhere to a port, you always have to keep in mind that you need to do this potentially 1,000 times for your setup. So this is a huge lever, right? And you still need to know whether this will work or not, or whether it kills you in 5 years because you want to implement a different feature there.
Generally, I agree. Perhaps I'll see you afterwards.
Okay, yeah, we can talk that off, take the talk off.
Thank you for the time, Good talk.
Yeah.
Rudiger, you have 11 minutes.
Oh, that's even a challenge. Rüdiger Volk, still retired. Looking at what you're doing, I wonder whether looking at the boxes as black boxes is actually the thing we should be doing. the complexities of how various variables kind of demand resources within the box. I think I understand the vendors that kind of disclosing that is very close to impossible. And as you mentioned, as far as something like that is disclosed, it is questionable whether the recipient can work with it. The thing that in the real world, I think we have to ask and maybe push more on the vendors is making transparent what the current utilization of the critical resources are, and the list of what are critical resources in the boxes. At least for a few critical resources, I think monitoring of the utilization is possible in most real-world products. Asking for better information is something that I remember doing many times with my upstream vendors when I had some. Yeah, well, okay, progress on such a thing is slow, but it can be made. And I think it should be made. And the question is, what are the resources that you in your environment know you can actually monitor in real operation? And if hopefully there are a few, why don't you do the monitoring and wrap this into your testing so that you actually see how the resources, the reporting back of critical resource utilizations matches with the crash, no, don't crash operation of your routers. And for the remark, you do not want in real life to run close to 100 or close to 98% or 95%. Kind of seeing how much water is beneath the keel is something that I think in such a testing environment actually should provide additional information and additional information about the security of operations that results from using your test result.
Yeah, you're totally right. So first, regarding the push for more transparency. So I don't know how you can get vendors to be more transparent on that. It's a really difficult topic because their business interests, and this is simply colliding with the way they perceive competition. The other thing is, yeah, I totally agree on monitoring. Yeah, we should. As I said, this was also one of the intentions here. How much water is under the keel? Yeah. So that's all I would like to add here.
Thank you. Do we have any questions on the internet?
No questions.
No, okay. Nobody else is running to the mics. 3 and 2 and 1, and thank you very much.
Thank you. So I don't want to repeat myself, but I'm doing it anyway. So please rate the talks. And the next speaker is Tom Strix from Cloudflare, and he's talking about the anatomy of route leak. Please, go ahead.
Hi, everyone. It's me again. So I'm Tom Strix, work for Cloudflare. I'm a network software engineer as well as the Edge Network technical lead. And I'm going to talk about a thing that happened in 2019, which is a year ago. So this talk is made up out of a couple of things. As you could have seen in the introduction slide, this is a presentation that we used to do with the three of us, Martin Levi, Jerome Fleury, and me. Martin Levi is retired. weirdly, and he's actually keeping retired, weirdly. So that's where the internet history comes from, because he's a history buff and he loves talking about history, but I'm a bit of a history buff as well, so I'm still going to do it. Talk a bit about some BGP rat leak history, because we've got at least one of the ASNs that did one of them in here. Talk about what happened in June 2019. Certain things, certain comments about certain vendors of certain products, and some graphs that hopefully indicate why you should do a specific thing. So, as some of you might know, the internet has been around for a while, roughly March 1977. Thing is, when all of that was built, when ARPANET was built, security wasn't top of mind, right? And that's not just indicative from the initial setups, it's indicative of the first RFCs, where, you know, like the first definition of IP, there's an internet header and there's a security option. But I don't think anyone actually ever uses it, besides maybe like certain companies that use load balancing and use it for load balancing reasons more than anything else. But it's not, you know, like nobody really looks at this anymore, and nobody actually really cares. And the same thing with everything that was built on top of IP. So when Tim Berners-Lee at CERN came out with the World Wide Web, he explicitly made it clear that the information exchange takes priority over information secrecy or information security. So basically everything that we've built since has been built on relatively unsecure foundations. So ever since, we've kind of been going back and forth and trying to improve things, but we still have a very critical communication protocol within the internet, BGP, where again, security issues are not discussed in the spec. So everything, again, is kind of just bolted on top of it, and that's unfortunately a pretty big problem. Because we started, like I said, insecure, where, you know, what you see at the top, that entire chain was unencrypted or unverified. And since then, we've started realizing that maybe we need to start verifying things, maybe we need to start encrypting things, because, you know, not everyone is on the internet with good intentions. So when you have the connection to a DNS name that's now nicely encrypted with PKI certificates, I think, you know, like what 90% of the internet at that point is TLS secured, so we're good. For DNS resolution, we now have protocols like DNS over TLS, DNS over HTTPS that adds a level of encryption. We've got DNSSEC for verification, but that last bit between like just the IP addresses, like lower layer, there's still some issues there. Because whenever we fail at verifying that lower layer, that layer 3, we're running into issues, and it's becoming more and more public. Because whenever there's a failure there, you get massive headlines that say Amazon, Facebook internet outage, or Google traffic hijacked, or DHS issue security alerts. And most of the time, it might not be the most accurate reporting, but the end result is still the same. People are worried about the internet security. And they're not wrong, because unfortunately, BGP has had a long history of routing leaks or routing hijacks. The first one was the AS7007 incident, hi Aaron, where a routing bug actually caused us to deaggregate the entire routing table in Florida, and, you know, things kind of broke in fun ways. Then you have the Pakistan Telecom hijack, which was them just trying to be regulators and blocking YouTube within the country, at which point they decided that the world was Pakistan. Usually not a good thing. Malaysia Telecom had a leak that was propagated through level 3, caused some impact. Google leaks to Verizon, and that was causing impact in Japan because they were being routed to Chicago. It goes on and on and on and on. And it ends with what I'm going to be talking about today, which is the routing leak from Verizon in 2019. But it keeps going on. Like, this is a tweet from Doug in 2020. it's interesting. It's apparently not safe to run any quad addresses. It's not just safe to not run 1.1.1.0/24, as I was talking about earlier this morning, but it's apparently also not safe to run 78.78.78 or any of the other quad addresses. This was a really fun and interesting one. It didn't really impact anything. It was just a weird thing to see, which is also why Doug picked up on it. But let's go back to June 24th, 2019. I'm sure all of you were aware what happened. A massive route leak from a specific provider caused worldwide impact for a bunch of different networks, but Cloudflare was the most impacted. That was also what you could see in most of the reporting, was that Cloudflare was front and center. But it wasn't just us. This is Sodexo's data from basically the entirety of Right Radar, showing issues for pretty much all of the large CDNs. The thing is that you can quite easily see that Cloudflare is the one at the bottom. That is likely entirely related to the fact that we're an Anycast network, not a unicast-based network, which means that if any of our prefixes are being leaked, it's going to be impacting globally, instead of where for the unicast systems or the unicast CDNs, it's going to be slightly more local, slightly less impacting. But as said, this wasn't just Cloudflare, it was pretty much the entire internet community that was impacted, just that I guess we're the ones that are yelling about it the most, or blog about it the most. But this was the impact that we saw, right? And the interesting thing that you can see is it wasn't just impacting us in North America, right? Like that was the initial expectation kind of with like route leaks like this, is it's gonna stay relatively local. Unfortunately, the way that this route leak or this route hijack happened caused us to lose significantly more traffic than we actually really wanted to. And I'll go into why or how a bit later. But how did we fix it? We didn't use any fancy APIs. We didn't use, we didn't use JSON. We didn't use anything fancy. No, we had to call for like an hour and trying to explain that what you're doing is wrong. Could you not do that thing? And unfortunately that took a while, because you need to kind of explain like you're leaking our routes. Could you not do that? And the other side then replies with, no, we're not. And then you're kind of stuck because you can't really, like he said, they said, right? But that's how we fixed it. We just told them, hey, you're leaking your routes. Could you please check your export filters? Please fix this. You're causing impact. And the thing is, like, I mean, this is a document from 2016 kind of defining what a BGP leak is. There's multiple definitions. There's multiple subsets of BGP leaks out there. You've got an inadvertent leak where someone is leaking their entire routing table, for example. Those occur quite frequently. But there's more nefarious ones, or there's an in-between. The interesting thing with this one is that it's not just a leak, it was actually a prefix hijack, because what you can see here is, first of all, /21, and the AS path here is strange, to say the least, right? We should never see a level 3 route in a Verizon route followed by, I think this is Tata. The thing is, Cloudflare doesn't advertise /21s, or at least not for these prefixes. We do advertise /21s, but this specific prefix is a /20, and that's the majority of our Anycast routes are actually /20s. So what we were seeing in the previous slide and then the leaked routes, they're 21s. So as you all know, longest prefix matching, that's always going to win. No matter how well peered and well connected Cloudflare is, that /21 being advertised is always going to win. And that's the main reason why Cloudflare was so severely impacted, because it wasn't just someone leaking /20s and winning locally for some peers. It was them advertising as /21 that, through providers like Verizon, hit the default free zone and suddenly started attracting all of our traffic. And that's where the tier 1s come in, right? Because like I said, it didn't just stay locally. It didn't just stay to a single IX. It didn't just stay within, you know, like the Pittsburgh area or like the East Coast. It went global, and it went global real quick because pretty much every single of these transit providers was either accepting it from Verizon or accepting it directly. And that's kind of what we see here, right? Like you see Cloudflare, but it's not really Cloudflare because, like I said, we don't do the /21s. Level 3, DQE, Allegheny, Verizon, and then it just goes global. And that was really problematic. We wrote not one, we wrote 2 blogs about it. And when Cloudflare writes 2 blogs about it, it's serious. But it was kind of a really fun exercise for us because it allowed us to really kind of flex our like engineering muscles a bit to really dig in to what was happening, to really understand everything that we were seeing, everything that everyone else was seeing. And Martin was nice enough to write a bunch of shell scripts that made it a lot easier for everyone to just kind of do some analysis themselves, have a look at what we were seeing, have a look at why we were saying the things that we were saying. So we made sure that everything was researched in an open source way and in an easy and understandable way. But this was always this, you know, like I showed you an IPv4 prefix. I've been talking about IPv4, and you know, like IPv6 has been the family of the future for the last 15 years. Why am I not talking about IPv6? Well, we kind of got lucky with that one because Allegheny Technologies is an IPv4 only network. They were only advertising IPv4 prefixes, which meant that even if they wanted to, they couldn't because they didn't support the address family. So the interesting thing that we saw for like the combination of a bunch of different ASNs, this is like the red is the IPv6 utilization. It's a bit sad, but we do what we do. But then you can see during the incident, IPv6 actually goes up. And that's where Happy Eyeballs comes into play. Happy Eyeballs normally is there to prefer IPv6 over IPv4, but I guess in this case, IPv6 is so bad that IPv4 still wins. But during the incident, because everything was so degraded, IPv6 actually won. IPv6 actually won those timing races on the mobile, on the clients to get traffic across. So that was kind of cool. Also just kind of meant there was some self-recovery happening. So that was always good. So how can we fix this? Because, you know, like it's all fine and dandy for me to be here on stage and then complain for half an hour about, you know, like everything's broken, please stop breaking things, if I don't suggest some solutions. And there's solutions. There's a bunch of solutions. There's always solutions, right? We're good at that. A concept primarily kind of talked about a lot by Job Snyder's called peer lock is relying on a very clear attribute of what we call tier 1 providers, where all tier 1 providers basically are in a mesh with each other, right? Because you see this mesh, all of them are interconnected with each other, which means that you should always be just a single hop removed from another tier 1. That's kind of the entire concept of this, which means that, for example, let's keep the level 3 thing going. For any of the customer prefixes from level 3, Cogent should never be receiving them from Verizon. They should just be receiving them directly, right? That's kind of the direct connection is there. So what you can start doing with peer lock is create explicit configuration on all of your routers that makes it impossible for multiple tier 1 ASN or transit ASNs to be chained behind each other. But you don't need to just stick to tier 1s. Obviously, tier 1s makes it significantly easier. It's basically the defining attribute of a tier 1 transit network. But you can do the same thing with a bunch of different networks where you know for a fact that this relationship specifically excludes them from being transited by this network, right? You can do this with content networks towards transits, but you can do it with everything, right? For example, from Cloudflare's perspective, because we're so well peered with, for example, Google or Amazon, we can explicitly state in our filtering that we don't want to see any of those ASNs through specific other ASNs because they shouldn't be seen through them. IXPs are obviously a ton harder to do, but it's still, I think, feasible. So it might be worth a thought, and it might be worth something to talk about. So where did that /21 come from? It was through a system or a piece of software called a BGP optimizer. So what do BGP optimizers do? Very straightforward. They receive the BGP routing table from their peers, from their transits, from any of the upstreams they want, and then they lie, because that's basically what they do. They're liars. They'll do is they'll de-aggregate all of the received routes and then split those across all of the available ports, allowing you to very fine-grainedly traffic balance or load balance, right? That's very, I can understand where certain networks might find that useful, but that's incredibly dangerous, as we've seen, because the more specifics will always win. So even if you make the slightest, the tiniest mistake in your export filter, and even one of them escapes, you're receiving all of that traffic. So that's what we saw. Like I said, like that /21 shouldn't have been in the routing table. It isn't in the routing table. So do route optimizers cause fake routes? Yeah, definitely they do. And to then have a vendor of a BGP optimizer to tell us how to do BGP filtering best practices is weird, because they're not secure by default. You would expect that, you know, setting the no export community on those fake routes would be a sane or relevant or a very useful secure default. They explicitly say it's not enabled by default. They've got an entire reasoning for this. It's that, you know, it's not perfect, and it's actually the fault of everyone else, not us, which is sure. It's apparently, you know, no export isn't a viable option for a specific subset of their customer base, therefore we're not enabling it for anyone. There's a bunch of complaints that you can have about that, right? It's not the right response, or at least that's not what we think is the right response. Now, onwards to RPKI, because it isn't ripe if there isn't at least a single talk a day about RPKI, and I think Job already did his one yesterday, so I guess it's my turn today. And then on Thursday, Frederick could maybe do his, and then, you know, we've got everything covered. But yeah, I mean, RPKI would have fixed this. RPKI, if everyone did RPKI route origin validation, because it's a /21, because it's a more specific, no one would have accepted it, because we only sign our /20s as /20s, and that's the only thing we do. So if everyone had ROV enabled, I wouldn't be up here talking. So this is all on you. But it's not just RPKI, right? Like, just like Manners is an amazing resource to help you figure out how do I do actual best practices and not just follow the specific vendor telling you what their best practices are. It's a neutral entity that helps you from very specific perspectives. That goes from service provider to IXP participant to content delivery network, to get the right things going. Obviously, IRR filtering is also a very useful tool. Unfortunately, there's a bunch of unanswered questions and scaling issues, especially for well-peered networks, very big networks. It becomes very, very cumbersome. Which IRR databases are we to trust? What about the non-auth side of things? What about any of the, you know, free IRR databases? How do we automate this? How frequently do we update our prefix lists? How do we tell our peers that we're currently not accepting a route because their IRR filters aren't correct, or because their IRR entries just don't exist? There's a bunch of remaining issues there that are still unanswered, still unsolved. But we've been making amazing strides over, you know, the last 2 years, right? That this still counts. over the last couple of years, we've seen a massive ton of progress, right? We've seen a consistent and very strong increase in RPKI signed routes. So that's just getting better and better. We're seeing more and more service providers and big networks saying and verifying that they're doing route origin validation. We're, like this is slightly outdated, but like networks like AT&T, KPN, Telia, a bunch of different ones now as well are actually dropping RPKI invalids, which definitely helps a lot. It significantly reduces the blast radius of incidents like this, because I'll show that in a second. But the interesting thing here is even if route origin validation was enabled on some networks, it didn't actually protect them. And the main reason for that is the ARIN TAL. I think since then, they've slightly changed the legalese that you need to agree to actually download the TAL. But when this incident happened, CCOM at the time were doing route origin validation. They just weren't including the ARIN TAL. Unfortunately, because the Cloudflare prefixes that we're talking about are issued from ARIN, they need to be signed by the ARIN TAL. So for all intents and purposes, for CCOM, they were unsigned prefixes. And I mean, at that point, you're kind of lost, and that's unfortunate. So again, there's clearly still some issues, right? Like I can't just say RPKI is the Lord and Savior and it will save the day for everything that we do. But it would have helped. So there's a really, really good research paper by Christopher Yu and David Wishnick from the University of Pennsylvania on how we can make RPKI easier for operators to actually use. This is basically an open letter to ARIN, right? that everyone understands that. But yeah, like it actually is really useful to deploy RPKI. What you can see here is a network that will remain unnamed, although no, it's not, it's AT&T. That had filtering enabled, and you can see everything is fine and dandy and everything, like sunshine and roses. And this is without filtering, and that's not from sunshine and roses. It was a massive, massive issue for us. But it's amazing when you see big, super big networks like AT&T and like Telia going, well, we're gonna, like lead the charge on this. We are gonna do what is right, and we are gonna start doing RPKI route origin validation and rejecting invalids. So, summary of this is, it's 2022, and it's still broken, right? I wish I could have another message. I wish my message could be, we fixed BGP route security, but we're not there yet. There's a bunch of different issues out there still. RPKI is only going to fix a very specific subset of the issues that we see. We need BGP path validation. We need BGPsec. We need a bunch of different additional security tools on top of the existing stacks that we use day to day to make sure that everything's okay. But I don't want to just sound hopeless. We are making progress. We're seeing that RPKI is being used day to day in the biggest networks out there. So there's nothing stopping any operator today to run RPKI route origin validation. You should be doing this today. Unfortunately, Verizon still isn't doing it, and we're, what, 3 years later? Because as some of you may have seen, we had a tiny hiccup with a network in Brazil that was leaking /29 to Verizon, who were then happily accepting that and then sending it within their network, causing Verizon customers to end up in Brazil, which makes perfect sense. So we're not there yet, right? Let's not kid ourselves. We're not there yet. There's a lot of work still to be done, but we're making good progress, and I'm really, really excited about the progress that we've made. So I've kind of flew through this because I know I still have like 8 minutes left. So sorry about that for the program committee. But does anyone have any questions? And if you don't have any questions right now, I already see Rudiger standing up. So if you have any questions, please don't hesitate to email. I think if you send an email to the Martin email address, it's probably going to end up in /dev/null these days, but you know where to find Martin. You see him driving around with a Miata with the 1.1.1 number plate, so easy enough.
Do you have a question?
Anyway, questions?
Thomas Schmidt, yes, please. Oh.
Hi, Thomas Schmidt from DFN. Work? No. Okay, yeah. Thomas Schmidt from DFN. While export filters are one part of the story, what about the import filters? What was going wrong there with the import filters from level 3 at that time?
Yeah, I mean, so at that point, it's a combination of things, right? The reason why we're complaining primarily about Verizon in this case is they're the source, right? They're the ones that should have stopped it. But yeah, you're 100% right. Like level 3 or different transit networks should have stopped the leak at their side. But it's one of those things where the moment it gets out, it's incredibly difficult to stop. So you need to stop it as close as possible to the source.
I mean, I would expect if they have a customer relationship that they have proper filters in place there.
Yeah, and we have a proper relationship with level 3. Like level 3 was doing the right thing, right? They're providing transit to DQE, so they're sending them a full table, which includes the Cloudflare prefixes. The thing is, like, we can't just shut down all of our level 3 sessions globally.
No, yeah,
because
that's clear. Yeah, sure. I mean the other side.
Yeah, and we asked them to shut it down, and that takes a while.
Yeah.
I have one online question from Kurt Kaiser, no affiliation. Is the time right to set a date for all route objects to be signed? I mean, if such errors continue, this is not fun. What about until RIPE 100, we aim to have 100% of all internet routes equal valid?
I mean, that'd be amazing. I'm all for that, but I'm also realistic enough to know that that's not going to happen. I think it would be nicer maybe if we, like hindsight being 2020, if 5 years ago, RIPE mandated a policy where if you want a new prefix assigned, it needs to be ROA signed. Unfortunately, that never happened. So we are where we are. I think it's good that we're making progress, but I don't see this being a fixed issue in 5 years.
Rudiger.
Okay, an RPKI talk and me not commenting hasn't occurred for a long time. Unfortunately, I don't have real questions.
I mean, in that case, Rudiger, if you want to stand on stage and talk, that might be easier.
I could do that, but well, okay, I have no prepared slides, and I survived a long career with a very amazing small amount of slides done. But okay, yes, we are not yet done. The area is something that is actually absolutely not trivial to be solved. For dealing with a non-trivial subject, sometimes it is extremely important to speak precisely, because, well, okay, people who are not in the know easily pick up mental models of things that are simplified in weird ways. So let me kind of first respond to Kurt. We should not be talking about root objects. I think he was asking for root objects, because IRR, as you were mentioning, well, okay, IRR can be used for pulling some information under some circumstance with some validity, but kind of it is only a possibility to be used if you are, well, okay, completely despaired about, well, okay, there is absolutely no information available to make decisions.
I completely agree with that.
And all best practice papers that claim that IRR filters are a good thing are essentially wrong by not claiming that, well, okay, yes, this may be the best available thing for certain people at a certain time, which is in the past, but it is not really a solution, cannot be. Your suggestion of allowing only prefix assignments with ROAS, well, okay, not really, unless you accept ROAS for AS0, which one could do. But, well, okay, the thing that we should be looking forward to is that kind of the market dynamics, the interplay within the IP routing means that routes that do not have a ROA just are not worth being kept. And that's something that may develop. Then we may run into a phase where, well, okay, kind of people who are a little bit backwards just don't get universal connectivity because they are not signing up their stuff. Well, okay, for speaking precisely, I think it is extremely important to use the word we are using RPK, or we are doing RPKI, as maintaining the cryptographically armed database. The use of that database can have a couple of purposes, some of which are already kind of available and in the play, and others are going to become more important and helpful. And so when people are saying, well, okay, we are deploying RPKI, I'm always asking, well, are you signing your routes? Are you dropping invalids? Are you authenticating your peers by the AS signatures? Probably not. Yeah, sure. So let me point at just two numbers for agenda that is straight ahead. The other week, RFC 9234 was finished, which defines an extension of BGP for characterizing open policy. That's not using RPKI, but it is absolutely something that would help with the examples that you showed, and everybody should be asking their vendors when that will be in their implementation. Same for 8893, which is just the hints of what details you should be using when you check the announcements that you are giving the other people. You should be doing that and not rely on the other people to fix your leaks. And then let's get back later on ASPA and BGPsec.
Okay.
Thank you. Thank you. Maria, finally.
Well, I think it's time for a provocative question. Is it now the time to implement ASPA and AS calls and BGPsec and so invert, or should we wait another 5 years?
No, we should start immediately.
Okay.
Thanks for that. That was an easy one.
All right. I see no other people rushing at the mic. The queue is empty. There is no questions online.
There is nothing online.
Thank you very much. Very
Thanks, folks.
informative.
Thank you. Okay, that's it. Happy coffee break. See you in half an hour, and please rate the talks.
So, welcome to our second RIPE 84 Kahoot quiz. And we started out well. My name is Gerardo Vivier, and I am your quiz master. We are broadcasting today from the barista station. Cappuccino, after 11 o'clock, that is so wrong on so many levels. So, this quiz is sponsored by BCIX, and the topic is BCPs. So, best common practices for you. Let me explain how to play the game. You can go to www.kahoot.it, put in the game pin 7941045, and a funny nickname, or your own nickname. Don't forget to include your registration number. That way you can get your bag of goodies if you win, only if you win. So log in and let's have some fun. We have today about 12 questions about best common practices, and I want to know if you know about it. Ouch! Yeah. So let's see, we got 40 players and it's time to start, I think. Let's get on with the party. Oh, wait, I see more people coming in. 1, 2, 3, 4, 5. This is amazing. Okay, now we're going to start. This Kahoot by RIPE is about BCPs. And it starts in 3, 2, 1. Question number 1. Using ULAs to number the WAN link for the end user CP is what? Impossible to do, strongly discouraged. I use UFOs instead, or strongly encourage. So impossible to do, strongly encourage, strongly discourage, or I use UFOs instead. I wonder what using UFOs actually means. And the right answer is, boom, strongly discouraged. So using ULAs to number the WAN link, remember the wild access network, is totally discouraged. Let's check the scoreboard. Jimbo at the front, Vista 332, CH41, Biga, and Ryder. On to question number 2. Anti-spoofing is to protect against the illegitimate use of bandwidth, IP addresses, Guy Fawkes masks, or magic. So, anti-spoofing is to protect against the illegitimate use of Guy Fawkes masks, IP addresses, bandwidth, or magic. And the right answer, everybody got it. Good. Means you know it, is IP addresses. Well done. Scoreboard says Vista 332 at the front, Jimbo taking a fall, CH41, MME, and Umel 265. On to question number 3. If you assign a /48 to every human being on Earth, how long would IPv6 last? We are now on IPv7, around 480 days, over 480 years, or less than 840 months. For those of you doing the calculation, so first you have to calculate how many human beings are on Earth. But then we go into the philosophical question, who is a human being, right? And everybody got it right. This is too easy. Over 480 years. I would have thought we would be on IPv7. Scoreboard says Jimbo taking the lead again. Vista 332, CH41, RVS14 RIPE, and MME. Question number 4. It's multi-select. Whop, whop, whop. Which action does Manners recommend for routing security? Global validation, filtering, coordination, or anti-spoofing. So it's multi-select, so you have multiple chances of getting this right. Global validation, filtering, coordination, or anti-spoofing? Which of these does Manners recommend? And yes, all 4 of them. Yeah, for those of you that were thinking, you should have just pressed any button. Let's see, Cynthia 59 taking the lead, Sergey 7, Wolf 21 and L, Vista 332, and MME. Let's see, number 5, as the best practice, use max length with adequate protection anytime you need more address space. What is max length? And as strictly as possible. Oh yeah! So use max length in Aurora with adequate protection as strictly as possible. What is max length? And anytime you need more address space. The right answer is yes, as strictly as possible. Yeah. Okay, on to the next question. But before, let's check the scoreboard. Cynthia 59 still at the lead, Sergey 7, Wolf 21 and L, Vista 332, and RSC 289. Question number 6. Wake up! Is it good practice to drop all RPKI unknown BGP announcements? I fear the unknown. Yes, no, and what is RPKI? So, is it good practice to drop all RPKI unknown BGP announcements? And the answer is no, bad practice. Ask anybody who knows. Best common practice is don't do that. Cynthia 59 at the lead, Sergey 7, Wolf 21 and L, Vista 332, and RSC 289. Question number 7. Preventing propagation of incorrect routing information is the definition of coordination, global validation, anti-spoofing, or filtering. So I think we just heard a presentation about this topic. Huh? So preventing propagation of incorrect routing information is the definition of filtering. Exactly. That's the best common practice. Filtering. Scoreboard says rules 21 and L, Vista 332, CH41/me. No, please don't slash me. And Cynthia 59. Question number 8. Why should you run 2 different validators in RPKI? Is it for redundancy and bugs? Should I run a validator to use that extra hardware that was left behind by a former colleague, or to confuse the BGP hijackers? That's right, Flipper. I know that is right. So for redundancy and bugs, of course, 2 different validators, best common practice. Scoreboard says rules 21 and L still at the front, Vista 332, CH41/me, and Cynthia 59. Question number 9. Why not? Yeah, why not? If your RUA matches your routing intentions, something went wrong. It's a coincidence. You are a hero. What is a RUA? I know, Crow. I know, Crow. That question should not be asked at this moment. So, if your RUA matches your routing intentions, you are a hero. You did it well. Let's go on to the scoreboard. Rules 21 and L at the front still. CH41 coming in. Vista 332/me and Cynthia 59. Question number 10. So what does MANNER stand for? Is it mutual agreements never rip sheets, MAN, Aragon never reacts supply, or mutually agreed nerds for routing suppleness, or of course mutual agreed norms for routing security? Yeah, Putty Cat. Yes, it's mutually agreed norms for routing security. We all know what MANNER stands for now, don't we? Scoreboard says rules 21 at the front, CH41, Vista 332, Cynthia 59, and /me. On to question number 11. How can you best manage the coordination required by manners? Ouch! That's not so bad. Implement anti-spoofing techniques, learn to dance, filter all your routes, or maintain your RIPE database entries. So, how can you best manage the coordination required by manners? Maintain your RIPE database entries. Whatever. No, it's not whatever. Maintain your RIPE database entries. On to the scoreboard. Rules 21 and L, Vista 332, CH41/me, and Jimbo coming back in. Question number 12. Which RIPE document specifies a BCOP for IPv6? RIPE 404, RIPE 960, RIPE 690, or there is no such BCOP? If you answer that, that's what I'm going to play. So RIPE 404, RIPE 960, RIPE 690, and that's correct. The correct answer is Ripe 690. If you haven't read it yet, those of you that didn't press that answer, go and read it now. Let's check the leaderboard. Slash me in number 3. Vista332 in number 2. And number 1, CH41. Very well. Congratulations, all of you, on playing and learning more about the best common practices. Thank you, thank you, thank you. And thank you, BCIX, for sponsoring the quiz. We will be back tomorrow with another quiz. Until then, bye-bye.
Hello, everyone. May I ask the candidates for the program committee to make their way to the stage so that we can start the session on time?
You know, I found the home here. Now I need to find the new home. Do you want me to do video? Okay. Then I will break the record. 4 sessions in a row. 4 sessions in a row. Okay, he's coming on move.
Okay. Thank you. Apparently, we are still missing exactly PC candidates in front of the stage. So if you volunteered for the PC, please come to the stage and we make a small introduction round.
Good, I'm off the hook.
Perfect.
Now you can get drunk.
Okay, people, please find seats. It is 4 o'clock and we would like to start with this session. I was promised I will get the PC elections slides. Okay, then I will. Okay, so I would suggest everyone who's volunteering for the PC, please go on stage just for a second. And I will pass around a microphone and I would ask you to just do a like 2 or 3 sentence pitch why you want to work with the program committee. So who are you and why do you want that?
Hiya, I'm Dave Knight, operator architect on Ultra DNS at New Star Security Services. I've been participating in RIPE for over 20 years. I was a chair of the DNS working group until last year. I've previously been on the DNS OARC program committee. I really love RIPE and I've missed not seeing everyone these past couple of years. And I hope you will give me the opportunity to make an already excellent program even better. Thank you.
Hey everyone, I'm Wolfgang from DKIX Academy. I'm actually on the PC and running again, and I've been on the PC now for 2 years. It was fun, but this is actually the first physical RIPE meeting I'm here as a PC member, and I liked that, so I would like to continue my work here on the PC for another 2 years.
Hi, I'm Max. I work at the Internet Society. I just want to be more active in the community and I would like to have a more active role, and that's why I applied for the program committee.
Hi, I'm Magnus from German Edge Cloud. I want to be present on the program committee to bring in some young and fresh blood. I feel that I'm will be one of the youngest ones, and yes.
Hi, I'm Sander Stefan. I had a long stint of 11.5 years as address policy chair. I was actually part of the first program committee when we all started the thing up. I needed a break for a couple of years, but I'm full of energy again, so I want to volunteer again to help make a nice program for all you guys and ladies.
Hi, my name is Jelte Jansen. I work as a research engineer for SIDN. And yeah, I've been on the program committee before and I really loved it. So I would just like to be there again. Thank you.
Okay, thank you very much. The voting for the PC is now open. Everyone with a RIPE NCC Access account can vote. We have 2 open seats and a bunch of candidates. So we actually do have an election going on this time. So please take the chance to participate. Thank you. And with that, we start with our first presenter who hasn't a microphone. So I'm not sure how we're going to do this. I will just pass this one.
Hey, so this is a little presentation about how we started to do an Anycast project at SixConnect. We just had this idea, and so that, we're not going in too many technical details. This is just a story about how we started it, how it went, the roadblocks we ran into, and just to give you an idea of what's possible, what's not possible, and how to deal with all this. So we started. SixConnect is a global company. We had some DNS servers, but we were like, oh, our DNS platform should be properly global. And the best way to scale that is using Anycast. So Jan and I decided, let's just do it. So at that point, we told the technical of the commercial people in the company that we were thinking about doing this. And they were like, hey, this might actually be something that we might offer as a service in the future. So we had backing from the commercial side. We were doing the technical stuff. And we just set off. But how do you do that? How do you actually deploy an Anycast network? Like, we have lots of experience with BGP and routing and the standard things. So, figure out what is actually different when doing Anycast. So build a prototype, set up some measurements, do some fine tuning, check if everything is okay, and that's it, right? Can't be that hard. So first choice was like, okay, what software are we actually going to use? So we looked at Bind, Node, NSD, Power DNS, and we're like, okay, what are we going to use for our authoritative platform? And we just decided to use all of them. So we used DNS dist. We have all 4 of the DNS servers serving the same zones in the background. We have DNS dist in front of it. And that way we can also compare the performance of the different backends by looking at the statistics in the front end and the measured latencies and the policies and things like this. So for routing, we're just using BERT2. Ansible for rolling it out, because if you're rolling out a lot of servers around the world, doing that by hand will definitely cause you to forget something. So all of that is automated. And of course, Jan was involved, so we needed to include some bash scripting as well. So the way we set it up, DNS dist provides the scripting and monitoring. SixConnect is a company that has IPAM and DNS tools, so we use that as our provisioning system for the zones. Sends it over to the server. We have a Python script that makes sure that all the backends are serving from the same zone file. And we wrote a small script called Damocles, which hangs as the sword of Damocles hangs over the bird daemon. And if it notices anything going wrong in DNS, it just stops the bird, and that node will go out of circulation. Little bit more detail. We started the first nodes. So 6Connect already had some racks and equipment in different locations. So we started in Fremont, Ljubljana, and Apeldoorn, which is basically Ljubljana is the hometown of Jan, Apeldoorn is the hometown of me, and Fremont was the original data center built by Aaron. So that's how we started. Of course, if you want to do Anycast, you should actually get a proper spread around the world. But for a proof of concept, we just started here. But then we thought, okay, how are we going to do this? Because if you just have one IP address, then if that node fails, then all the latencies start massively shifting. Do we advertise multiple addresses on multiple nodes? What AS number do we use? Do we use a separate AS number for each instance, or do we give each instance the same AS number? And in the end, we decided we're using one AS number, 3 v4 prefixes, and 3 v6 prefixes. So every POP now has 3 VMs. The first VM announces the first prefix as the primary address, and the second prefix as a backup address. The second node does the second and the third address, and the third node does the third and the first address. So even if one of the nodes fails, the traffic still stays local, and one of the other 3 nodes in the cluster catches the traffic. So that way we actually also, for example, with maintenance, if we reboot one of the 3 nodes in the cluster, customers won't notice because one of the other 2 nodes will just pick it up. How do we do the failover? Well, if it's, like I said, the primary has a high priority and the secondary low priority. If we have a cluster, for example, where we have our own BGP routers, we use iBGP with local pref. So that way we just have a clean failover. But some locations we have VMs in a third-party data center where we're not running the first hop router. So there we use eBGP with path prepending. That means if there's a failover, it is visible in the routing tables, but we tested it and it doesn't have a massive impact. So good enough for now. But then, things weren't properly working. We had some black holes, we had some lost traffic, performance was really weird in some places. So how do you debug this? Just putting some BGP boxes out there with DNS servers is easy. But what is going on, and why is traffic ending up on the other side of the world? Why do we have black holes at some places? We just didn't know. So we looked at route views, we looked at RIPE Atlas, but it all wasn't detailed and targeted enough to actually debug this. So this was an issue. Of course, even though we knew we had issues, we were like, well, we already know we're not having a good distribution around the world. So while we're figuring out the measurements, let's add a couple of more nodes. So we added Tokyo at this point, and we just were brave, and we have, of course, we didn't touch the 6connect.com domain name because I think Aaron would kill us if we did that. But we have 6C Labs, so we put that on our own cluster just to have a first test and actually see what's going on. So, like I said, we use 6Connect Provision as our control center. From there, they are pushed to the servers. Basic monitoring is just Libre NMS with SNMP and some plugins. We do want to do some more measurements on the front end because a lot of these are just looking at the public-facing part. But yeah, if at some point one of the backends starts performing badly, DNS dist would just not give it as many queries. So on the front end, you wouldn't even notice. But of course, as an administrator, you do want to know that something's going on. So there were some things here that could be improved. And then we were like, okay, while we're doing this Anycast thing, what else can we do? I mean, everybody always says, okay, UDP-based protocols, you can do an Anycast. like really short-lived DNS queries you can do over TCP. But we were like, okay, but how stable is the routing? What would be the effect if we would host other things on there? Can we host a DNS cluster, sorry, a database cluster on there? Can we do a web front end that is distributed around the world? For example, spam filtering, SMTP sessions. They don't live very long, and if an SMTP session breaks, then the sender just tries again. So what other things could we do? Because this is just an initial proof of concept, and we can just experiment with it. This is not something that we have to be super careful about because we have paying customers on it at this point. So for those things, we also like, okay, not all services need to be in all locations. And how do you host it? Like if you add an extra service, we have, of course, per/24v4 or per/48v6, we have one address for DNS. Could we host other things on there as well? But then you get into the problem that if one of the services fails, because they're all in the same prefix, you would have to pull the whole prefix and also pull all the other services. So do we actually need to run everything everywhere? Can we put some load balancers and caches in the Anycast locations and run the actual service in another location? So we've been experimenting a lot with this. I don't have any results on this yet. These are just the thoughts that came up in our heads that we have been playing around with. But so far, we're actually doing quite well. One of the bigger problems is usually trying, for example, to use Let's Encrypt, because Let's Encrypt, you need to create a specific file that needs to be served on port 80. And if you're doing that for an Anycasted setup, which node will actually get the query? So you have to build something for that as well. So those are things we've been working on and playing with. Well, there's actually this slide. So yeah, Let's Encrypt is a bit more complicated, but with some caching and scripting and proxying, it's actually doable. But while we're having all these wild ideas, we're still having this problem that we don't really know what's going on. Where are the black holes? Why is Asian traffic ending up in the US? Why is European traffic ending up in Asia? What are the latencies? What are the distances? Why are these things happening, and how can we fix them? So this turned out to be a bigger problem than what we could handle. So we had a visit with Remco van Moog. He lives 15 minutes away from my house. Jan was visiting me, so we went over to Remco for a drink. We had a nice chat, and we were just chatting about this Anycast experiment we're doing and how we're playing around with this. And it turns out that Remco actually just started a new company called LinkState, which specializes in measuring network reachability and Anycast specific stuff. That's exactly what we needed. And we also might have had some whiskey. So then we get to the point, what do we actually want? We want to know where our prefixes are visible. We want to see from all over the world exactly which nodes, which clients end up at which server. We want to know what latency they have, what cluster they have. We want to be able to optimize that clients go to the cluster with the lowest latency from their point in the network. And of course, the black holes. We had some places. I think it was Croatia, Serbia, somewhere around there. Yeah, Serbia. So where just a whole country couldn't reach our Anycast network, and we had no idea why. So this is something that we actually worked with Remco a lot, and he will be the next presenter. So he will go into all the details of this. But yeah, so these are actual questions that you don't have when you run a simple network with just normal routing, normal BGP. If you do Anycast, you suddenly get a lot of questions that are kind of familiar to network engineers, but the implications are completely different. So this is where we really had to learn, and where we got some really interesting results. You know, you'd think that in one AS they have one routing policy, but we found ASs where the northern part of the network ended up in Europe, and the southern part of the network ended up in Asia, and the network itself was in the US. And no idea how that network had different policies, and you could see them geographically divided. So there was something going on there, but you need tools for this. If you just want to deploy Anycast, like if it's for a hobby project, sure, you just throw some nodes around the world, and as long as nobody complains, it's good, right? But getting this right was actually a lot harder than we thought. So we ended up with a map a bit like this. In North America, we had a decent reachability. We had in Europe, we had the Netherlands and Slovenia. In Asia, we had Japan. So and then we saw this map, which is actually coming out of Remco's system, I think. He nods, so it's true. And we were like, yeah, this is a bit shaming. Like, we're definitely focusing on the northern hemisphere here. Like, the whole southern part of the globe is red. So at this point, we really started working with Remco and to basically just get the whole globe green and get good service everywhere. This is actually my last slide. I want to jump a little bit ahead to after Remco's presentation, because at the moment we do have most of the globe green. And like I said, we had our own domain names running on this platform, eat your own dog food style. But we needed some more traffic to actually do some proper testing. So by now, like I said, most of the globe is green, and we're just running the .ua domain on this Anycast network. So Dimitri's sitting here in the front of the room, and this is actually now running one of the TLDs. So how's that for a test case? Yeah, and at this point, I would take some questions, and if there are no questions on the concepts, I'll hand it over to Remco to show how to debug a mess like this.
Thank you. Okay, we start with Peter, who is properly queued.
Thank you. Peter Hessler from DNIC. You mentioned in your presentation that you're using a sort of Damocles style scripting. How do you make sure you don't cause a cascading failure and kill all your nodes at the same time?
I see you were not the only one with that question.
Yes.
No, so each node only queries itself. We have a whole set of records that it checks. Theoretically, if we push like a bad zone config to the Anycast cloud, it could kill itself. But as long as the zone pushing mechanism is correct, which we do actually check, we check and parse the zone files before we actually activate the config, then every node is independent and can't kill any other node. So we do keep the testing very local, specifically for this. We should probably implement some extra checks. For example, if your zone file shrinks by more than 50%, stop. But at the moment, as long as the zone file is correct, it will keep running. And for the .ua stuff, we're actually using IXFR updates and not even pushing the whole zone file. Yeah. So that's how we currently have it. Like, there's definitely room for improvement.
So I'll just make a quick suggestion. Some systems have seen issues where one node gets overpowered and fails the health checks, gets pulled. The neighboring nodes get overpowered, fail their health checks, et cetera, and then that's a really nasty cascading failure case. Yes. So I recommend adding that to your to-do list for sure.
So what we did for that is we implemented rate limiting in DNS dist. But we whitelisted our own checks with the highest priority to make sure that they have the biggest chance to get through.
Okay, Eric.
Erik Barnes, A2B Internet. Sander,
Hey.
on the black hole networks where it wasn't reachable, did you try other prefixes for the BHP announcements, or did you just test it with one?
No, so we have 3 different prefixes, both V4 and V6, and it actually turned out to be a firewalling issue on one of our sites. So it wasn't even a BGP issue.
Interesting.
Hi, Q myself, Gloucester Digital. On the topic of Let's Encrypt, you were talking about HTTP-based validation. What work, if any, did you put into looking into the DNS 01 based validation for certificates from them or other ACME CAs?
Yeah, so what we could have done DNS, except our own zone is provisioned by our own backend software.
Right.
So
you could use CNAMEs, so you could CNAME the ACME challenge out to another zone if you looked at that.
Correct. No, but the biggest problem was the latency between requesting a certificate, updating the back end, waiting for the propagation back to all the front ends, and so in the end we just used I think it was Nginx or AA proxy to just forward all the Let's Encrypt traffic to one central node, request the certificates there, and then push them out.
Okay.
I think Dimitri, you want to comment?
Yeah, thanks. Thanks for the work. Yeah, I'm pleased to be in Epic. Just a comment. I do like your statistics. You didn't mention that as a presentation.
True.
I just say that using Grafana, I used many Anycast vendors, and I did like the one your way of doing that.
Thank you. Yeah, that's I actually made those after making this presentation. Plus, they are you okay with me sharing some screenshots of that? Okay, so then I will make some screenshots and see if I can upload them so we can show them after Remco's presentation.
If you're really fast, we can do that.
You know me. I can write presentations 5 minutes before the session starts.
Oh, I know. Next one, please.
Hi, James from Astrum Networks. I've always been concerned about the potential for a rare corner case when doing TCP to Anycast deployments where eyeball networks might be doing per packet rather than per flow load balancing between 2 equal cost Anycast sources and breaking TCP. Are you able to determine that this never happens?
I'll leave that one to Remco.
Okay.
And if I said correctly, our final question for this one.
Tomer Gaberchenkov, service.com Cyprus. The response to the previous question is, over my 12 years of using TCP with Anycast, never had such problem. And to you now, Sander, networks of what particular size did you use? It is /24, /23, or what?
So we have 3 /24s V4 space and 3 different /48s in V6 space.
All right, because /24s might be filtered by some networks or there's. Yeah, Anycast is fun. I mean, it's like a dozen times in my life that I realized that my Anycast-based failover is actually a failover. So yeah, thank you for your talk.
Thank you. No, so far the /24s do propagate quite well. So we didn't run into problems there.
Okay, thank you. Yes, that was it about Anycast, but wait, there is more.
There's more.
There is much more. So Remco will tell us the other part of that story.
Wow. Can everyone hear me okay? Yes, apparently. People in the live stream, don't raise your hands because you're not here. Good. So let's wait for Meetecho to do its magic. For those about to Anycast, or as when Jan and Sander came to visit for a whiskey, dazed and confused, as more to the point. A little bit about why I'm standing here today. I had a frustration, and it's always a good reason to do something. And that is, there's a lot of ways to measure stuff on the internet, but not a lot of ways to measure from a lot of places on the internet. And if you want to do stuff like network optimization, or even apply machine learning to your network configuration, I mean, whatever kind of thing you think you might achieve out of that, you need data, you need a lot of data, you need diverse data. Currently, there's more than 10 billion devices on the internet used by 5 billion people. And if you want to get statistically relevant data, you need to have internet scale viewpoints. And that means you're not looking for hundreds of viewpoints or thousands. But ideally, you want to be able to look and observe what's happening from hundreds of millions of places. And that's what we figured out, is we found a way to take some of the existing frameworks from other companies and actually build a platform that we can leverage those and continuously measure network performance from a pool of hundreds of millions of end user connections. I think the current tally sits at around 250 million. And as it so happened, when Jan and Sander were visiting, one of our internal test cases was a global Anycast network. So let's talk about Anycast. Like, that's what you're here for, right? What are the key challenges with Anycast? Anycast is a bit of a different beast. First of all, you need to make sure that any inbound Anycast traffic shows up at all. How do you know? You don't. There's no black holes, no loops. And unlike Unicast, you just can't send out a packet and sort of expect it to show up where you think it shows up. You have to make sure that your inbound traffic ends up in the right place. And in order to make sure you define what the right place is, you need to have a defined intent. So what are you trying to achieve? Which POP is going to serve what geography, or which specific ISP, or whatever. So you need to have that defined and then measure it against that and see how you run with that. So you can determine that by geography, service level objectives, how fast is it, what kind of latency. But one of the key things to keep in mind as you're optimizing Anycast is you are effectively trying to traffic engineer the reverse path. It's not about your outbound routes. It is about how everyone else in the world decides to send traffic to you. So the dream of Anycast. You have a bunch of nodes around the world, and they all have a particular reach, and happy days. So European traffic goes to Europe, Indian traffic goes around to India, Australian traffic definitely stays in Australia, and so on. But here's the real world, and this might be a horror picture for some people. This is what a typical Anycast situation looks like. So you have a massively outsized footprint for your European node, because your European node is connected to a bunch of internet exchanges that have excellent route servers, which propagate your visibility all over the world and doing a better job than actually most places in North America or South America. So your European node will show up absolutely everywhere. At the same time, you're ending up with your Australian node, which you actually try to limit because it's far away from everything. But for some odd reason, like half of Russia and the Caribbean are ending up in Australia. And if you, I mean, I didn't put the sea cables into this map, but you can probably imagine that this is the worst possible outcome. You see that your node on the west coast of the US has its own footprint, which is fine, but actually also takes over like half of the traffic in South America and Northeast Asia. So this is your problem to solve now, but you don't even know that this is your problem to solve, because this is what your monitoring is telling you. I have a bunch of nodes and they're online and they're getting traffic. How amazing is that? So Jan and Sander came over and they were talking about their Anycast issues, and I'm like, oh, so you mean something like this, right? Right? So you want to know what kind of latency you're getting. You want to see if your network effectiveness is good enough. What's the access distance that your traffic is traveling, right? So how many extra kilometers is your traffic doing compared to an optimum situation? How much of it is actually matching the intent that you defined, and so on. So which POPs do users end up in the last hour? I mean, this is a nice visual, and it's typically good for nice visuals on big screens and not for engineering purposes, but you can see where this is going. Interesting other thing, this is a histogram of round trip time. So anything over on the left-hand side is good. Anything on the left side of this line, 50 milliseconds, is good enough for pretty much anything you want to do. But as you have a global network, this is data from my internal test case network, so here's this outlier at around 90 milliseconds for apparently Japan. And, oh no, that was Frankfurt. Here, this is my POP in Tokyo. And my POP in Tokyo is doing a lot of traffic that's clearly going to the other side of the world. That's not good. So, other thing, how efficient is the routing that I'm observing? What am I seeing here? How many hops are the end users away from my Anycast POPs? Well, again, this is all very good. I mean, 4 or 5 hops is like theoretic optimum because I have an edge node. Their ISP is an edge node. 1 or 2 internal hops. This is all amazing. This is all great. This is okay. And this is just wild. This is crazy. Also, this is Comcast. Beats me. I have no answer. I have no idea. Just observing. So, am I hitting my performance objectives? How much of my Anycast traffic how many of my measurements actually work? Well, it's a decent number. It's not really 100% of attempted measurements is a good goal to have. At anything over 99% of trying to do an observation is okay. My average round trip is, considering this is my test case gloriously unoptimized network, it's actually not too bad. And my intent match, well, I may have sort of changed my intent to reflect what I was seeing, which is a bit of cheating, but I don't know. Access distance, I know where all of my POPs are. I know with some level of certainty where the end users are because of GeoIP lookups and that kind of thing. So I can look at where's the end user, where's the POP they ended up, what are all the other POPs, and what is the difference in distance between where did they end up and where should they have ended up, or where could they have ended up. And like 300 kilometers, that's nothing. That's like point something of a millisecond. That's fine. If this goes up to 2000, then you have an optimization issue. More important for engineering, what's my homework? What is the stuff that I can see is going wrong? So here I have, for example, a whole bunch of ASNs in the UK, and they're ending up in Frankfurt and Amsterdam instead of in London, which is okay, I guess. There's some interesting stuff. There's Ross Telecom ending up in Tokyo, which is clearly not great. Comcast clearly loves to send all of its traffic to Miami. There's more POPs, but oh well. And this is all nice, right? This is actionable. You can, as a network engineer, you can log in every morning, look at your dashboard and saying, oh, this is my homework for today. This is the stuff I need to go and optimize. But really, we're engineers, we're lazy, we like to get this stuff done by computers. So that's sort of the next step where you want to take this, because knowing which networks should go where, you can help you by saying, okay, so how do I do this? And some of it is the good old-fashioned legwork of peering coordinators and sending emails and getting on phone calls saying, hey, your network is behaving weird. Can you fix it? Or actually, we can help your customers get a better experience, right? That always works really well. If only you could do this. So, but in order to do this, you need, like I said, you need huge data sets in order to do this. And continuous data feeds help. And this is what we're doing. And you can try to do all of this with like flow analysis on your network. But flow analysis really only tells you what's already happened. And if you're trying to optimize stuff or you're trying to fix something in real time, you don't have time to look at what happened yesterday. That's might be giving you some insight, but you want to know what's happening right now. So this is here we go. It's a bit Schrodinger's box. Did I push the button, or did it not send a signal? So Anycast as a technology, as a network technology, is a little bit like Formula One. If you get the settings for your Anycast network exactly right, it is absolutely incredible. It is by far the most optimized piece of network technology you can run to deliver content. The problem is, if you don't get it exactly right, things get pretty mediocre pretty quickly. And the environment is the defining factor. It's not about what you're doing, it's what everyone else on the internet is doing to your prefixes. And let me tell you, they're up to no good. It's a bad world out there. And the only way you can actually see what's going on is with specialist tools. So with that, any questions?
Thank you. Yes. So I will start off with questions that we actually got in written form.
Mm-hmm.
So bear with me. Aaron Weintraub from a small local ISP is asking, how much of this sort of problem is additionally self-inflicted damage caused by some entities buying transit far out of market due to real or imagined pricing concerns? So South America buying in Miami, Asia buying in Los Angeles, and so on.
That's actually an interesting question. Yes, to an extent, but also one of the things that we've observed with one of our early stage customers for this is what's actually even more important is the mix of who are you buying transit from as an Anycast provider, and who are your end users, the end users that you're trying to serve, who's their ISP buying transit from. So interesting example. So one of the things we wanted to optimize was a number of people playing some game, not going to name any names, in Greece, and 90% of the traffic from Greece was ending up in Athens. Amazing. That's exactly where it should be. And 10% ended up in Madrid. And I mean, if you look at sort of the network topology of Europe, Madrid is probably the worst place for traffic to end up if you're starting from Greece. And why was that? Because of the transit provider. Because the transit provider for that particular pop in Madrid was a one-off, was a different one that they were using elsewhere. But it happened also to be the transit provider of one of the major ISPs in Greece. And that route was preferred over everything else. And there you go.
Rüdiger.
Rüdiger Volk, still retired.
Good for you.
Thank you. During my operators days, I remember someday when I figured out, Anycast users were having trouble, and well, okay, I was thinking about it back and forth, and I figured out, wow, strange thing. They are basing their optimization of traffic on the routing system, which is probably driven by people with different objectives and circumstance, and optimizing their system. And well, I figured out one should not be surprised. One should absolutely not be surprised that this can spell trouble, and certainly is kind of not a safe way of doing optimization. And the question that Franziska read is kind of an extreme example of that, where even optimization criteria kicked in that were far outside my network operators' optimizations. Strange thing.
And that is exactly why you can't, if you're trying to do any code. I mean, no one says Formula One cars are particularly safe, right? They're really fast, though. So it's really cool to have them. It's not, maybe not the safest, but you want it to be as safe as possible. And in order to get it as good as you can, you need the data to tell you what the whole world is seeing. And I completely agree with you. You're trying to, it's actually in my second slide, you are trying to optimize the reverse path. You're trying to optimize someone else's routing.
Yes, and actually one of the most frightening things is you are really on shaking grounds, because the optimization and the objectives of the optimization on the routing level may change any moment and you cannot even blame the guys for not making an advance notice.
Well, then that's why you need the real-time data.
Okay, apparently people have found the Q&A feature that makes me read out a lot of stuff.
Oh, dear Lord.
So you need to wait a sec. So first one, by Maximilian Emmig, Atticon. Are you analyzing the respective tier 1 upstreams of your ISP? In general, it is key to have the same tier 1 upstreams everywhere if available. For tier 2 ISPs, BGP communities like do not announce to internal peers are very valuable resource.
That is all true. It's also not enough.
Okay, let's take another one of those. Brad Khan Nominet. Is the tool you demonstrated a commercial product, open source, or something else? Would be really interesting in getting data for our TLD from it.
I would love to talk.
So you know how to reach out to.
And for TLDs, I mean, Dmitry Komanyuk is actually is using 6Connect, who are using this data to optimize .UA. So.
Tom Strix, Cloudflare. Really cool talk, really cool data, data visualization. But is it my understanding that you're currently selling this or you're providing this as a service to Anycast operators? What about offering that data to Anycast receivers, to like service providers? Because like you said, like one of the issues that you're trying to debug is them reverse pathing. And providers like Cloudflare, for example, like what we do is we attach location-based communities to all of our Anycast advertisements and make it easier for us to figure out where things are. We're not at a stage yet where we're publishing that. globally, but that is definitely a state we want to be in. Is that something that you're considering as well with your data sets?
I mean, we're definitely heading in that direction. We were just really only starting to take the covers off. We're just we're just launching, starting to build this and go a little bit public about it. When Jan and Sander were visiting, this is still very much an under development, not to be disclosed kind of thing. But I was like, this is what you need, right?
Right,
So
cool.
yeah, I mean,
Thanks.
it's definitely and the use case for this is not uniquely Anycast, obviously, because you can do basically ISPs interested in what kind of performance they're getting to cloud providers. Cloud providers interested in what kind of performance they're getting to ISP. I mean, you can basically name a business case. Perfect.
Awesome. Thank you.
Thank you.
Okay, another question from the internet.
Oh,
so Jaron Lindert's Hackers Bescherming. Wow, you people have weird affiliations. How much percentage of the internet content is really needed at external POPs? Isn't that only needed for global operations and therefore a minority of the total online content?
I'm not sure I understand the question, and secondly, I'm not sure if I'm qualified to answer it.
Then rather abstain. So, go ahead.
Right. Tomasz Gawryczenko, servers.com Cyprus. My 2 cents. First, when analyzing the latency-wise performance of an Anycast network from the client side, some of the outliers on the graphs could be explained by VPN servers, especially popular ones.
Mm-hmm.
So yeah, that's something maybe to look at. I did that before. So,
Yeah, I am keenly aware. So this is the point about having a sufficiently large data set, because when you have a sufficiently large data set, I mean, the VPNs, they stick out like sore thumbs. You can pick them up because you have a graph that goes like this, and then there's this peak. That's a VPN provider. You don't know that until you have enough data.
Correct. Secondly, I totally support and endorse the idea of designing Anycast networks with whiskey. Thank you.
I agree.
Okay, I think that was it for this presentation. So thank you.
You're welcome.
All right. Okay. Thank you. Oh, now
And
this
I
extra
think-
missing slide.
Yes.
Yeah. So as Dimitri asked,
You have 2 minutes.
No problem. We put some stuff in Grafana. The way we did it is we used DNS tab to get the queries out. Then we use a collector that presents that as Prometheus metrics, which we then graph in Grafana. So the color is a bit bad on this one. There's actually a very vague purple line at the top, which is .com.ua. So this is the first level, basically. .ua is split into several subzones, and we just made a list of all the queries. Now, if you look at the bottom, we're getting CN, we're getting DE, we're getting net. We're not running the authoritative DNS for any of those. So there's a whole bunch of weird DNS traffic actually ending up at our Anycast cluster. But you see at the top, the com.ua gets like 3,500 queries per second at the moment. This is roughly like this data I just screenshotted 5 minutes ago. So this is as good as live. Then we dive in one level deeper. So we not only take the .ua zones, but we actually have graphs, and you can see all the different subzones and what like this is a top 50, I think, or top 25. So and it's interesting to see some zones like the purple one that is at the bottom, then suddenly it goes all the way up to the green lines and then drops away again. So there's suddenly a zone that is very briefly very active and then drops away. So if you want some interesting statistics, you can do quite some nice research based on this. So this is all the zone data. Then we also have some more generic cluster-wide information. Type of query, response code that we send out. We send out the latency. So this is the latency between the query coming in and and us sending the response out. So we monitor our own latency there. And at the bottom, the graph is actually showing the different Anycast sites we have. APE is Apeldoorn, it's my hometown in the Netherlands. And of course, since that is quite close to Ukraine, it's not surprising that that one actually gets most of the traffic for this. Then we have the cluster of 3. So NS1 is the first prefix, NS2 is the second prefix, NS3 is the third prefix. So you can see that's actually for some reason NS2 is getting slightly more traffic than the rest. So yeah, it's interesting that not every prefix gets exactly the same amount of queries. You think with 2,000-3,000 requests per second, it would equalize a bit more, but this is what we're currently seeing.
I tell you why it gets less traffic. It's because I removed 2 of your V6 addresses because we had connectivity issues. I'll fix it later.
Okay.
Those are V6.
Oh, and I forgot to change the title on this slide. This is actually the ASNs that are sending the queries. So we're getting a lot of queries coming from Google, and then there's some different ones that have a very interval-based pattern. No idea what they are, but you know, if somebody feels like this is an interesting research subject, ask me or Jan or Dimitri, and we can see if we can give you some data. And that was it. Thanks.
Okay. Thank you. Okay. Yes. You still want to ask the question after the 2-minute slot? Okay, good.
No, I would like to apologize to Dimitri, and I share a story, deployment story. Well, what you saw here in these graphs, this tool, we developed it, and Dima was continuously saying, I can't reach it. It times out, and we were testing it. It worked for all our locations, and then it turns out it doesn't work over IPv4. We didn't even notice it. Sorry, we will fix it.
Well, yeah, I was in Greece and I got a residential V6, and that was magically working. So all hail Greece for finally doing something better than many other countries, including Ukraine. We have very little V6 deployment. But please, Pavlos Serpezis, I hope I stressed your name correctly. Thank you. You're welcome.
That is the wrong slide deck.
Yeah.
Yes. As I say, Kalispera. Yeah, please, bias in internet measurement infrastructure. It's uploaded. I checked it, but it's because we added one more lightning talk, which was not on the program as of yesterday. And so you get kind of the one-off error. But you got time. I'll start the timer when this deck is on the screen.
Okay, so that's the correct presentation. So hello, everybody. I'm Pavlos. I'm a researcher. I'm in Data in the Web Science lab at the Aristotle University in Greece. And today I'm going to present you a work that it's a joint work with Lars Prehn from the Max Planck Institute and Emil Laben from RIPE NCC. And in fact, it's based on a recent article I have written on RIPE Labs. And the committee there, apparently they liked it and they invited me to present it in front of you. They thought that it would be interesting for you. So the topic is bias in internet measurement infrastructure. And while I was thinking how to introduce it to you, I saw yesterday a talk by Doug Madory from Kenting, that their topic was about how to measure RPKI ROV adoption based from some data they have from the networks of their clients. And while presenting his methodology, he made an important point that it's the note there, that the analysis he presented is subject to biases of the customer set, which of Kending, which includes mostly networks from US. And it's very good for him that he did this note, because it's important when we present data, when we see our own data from the measurements, and we want to understand what's going on and get some insights. It's really important to understand if there is any problem in this data, if there is any bias, because this may affect our conclusions. And that's exactly what we are investigating in this work. So we're investigating the bias that the measurement platforms like RIPE Atlas, RIPE RIS, and Route Views, the bias that exists in these platforms that a lot of people use for their everyday issues and to handle their networks. So what these platforms allow us to do, it's to view the internet. So let's say that this is the internet that is composed from many networks of different types all over the world, that they are connected with each other. The measurement platforms give us a window to see what's going on the internet. So network engineers, they know what's going on their internet. And if they want to learn what's going on the outer internet, engineers know what's going on their network. And if they want to learn what's going on the outer internet, they look through the measurements and the measurement platforms. So measurement platforms are like a window. But the problem is that the window, it's not like this. It's mostly like this. So it's a stained glass window. And why we make this analogy, it's because some parts behind this glass cannot be seen. We don't have visibility everywhere. Some parts can be seen quite clearly. It's behind the transparent blocks where you can see some networks. And some other networks can be seen, but not that clearly. It's the networks behind the colors. And this is exactly how we define bias in measurement platforms and measurement data. So bias exists when we don't have the same, when we cannot see all network types equally clear. So when we see some networks more clearly than others, some network types. And let me give you a couple of examples so to make this clearer. So for example, RIPE Atlas and RIPE RIS have many probes and peers, and a lot of them are in Europe. This is normal given that RIPE NCC serves this region. However, this is a location bias. We may have a clearer view of networks in Europe rather than in other locations. But a location is not the only type of bias we may have. We may have network type bias. So what this plot shows, it's a different network types as they are declared in PeeringDB, and the bars show what is the percentage of networks that belong to each network type. So if we focus on the first category of the cable, DSL, and the ISP networks, and you see the blue bar is the percentage of all the networks that are of this type. Now, if we take into account the networks that are on RIPE RIS and Route Views, which is the green and red bars, then we can see that these bars are lower than on what happens on average than the blue bar. So what does this tell us? This tells us that cable, DSL, and ISP networks are underrepresented in measurement platforms. On the contrary, NSP, in the category of NSP, we can see that the green and red bars are overrepresented because they are higher than the blue bar. And this is a clear network type bias we have in the platforms. Another example, a third example, is the topological bias. So what these bars show here, it's the average number of neighbors an ASN has. So if we consider all networks, all ASNs in the world, the average number of neighbors, it's quite low. It's the blue bar that it's barely seen. But if we consider only the networks that are in RIS or Route Views, we can see that they have a lot of neighbors. And this is a huge topological bias we have. So these three examples, these are only three examples. And the bias, in fact, has a lot of dimensions. This can be location, network size, network type, IXP connectivity, etc. So what we did is we tried to analyze the biases in some important dimensions. So we collected public data for all these dimensions and tried to calculate the bias score in every dimension. So we calculate the bias score that is from 0, which means low bias, to 1, which means high bias. And we present all this analysis in this radar plot, which I will explain you how you can read it. So each radius of this radar plot corresponds to a dimension. So you can see dimensions related to location, network size, topology, IXP connectivity, etc. And the colored lines and areas correspond to different infrastructures. So blue is for iPatlas, orange is for RIS, and green is for route views. The value of the line corresponds to the bias score. So for example, if we can see at the location here, the bias is 0.2. If we see at the dimension of topology here, the bias of RIPE-RIS is higher because it's farther from the center. The farther from the center, the more the bias. And it's around 0.4. So what does this analysis tells us? What we can see here in this plot is that at first, all these three platforms are biased. And they are biased in most of the dimensions we took into account. Here, it's important to note that these are some dimensions that we considered important, and there are public data for them. But in this plot, you can add more dimensions and do more analysis, or remove some dimensions if you don't care about some dimensions. So another thing is that the bias is not homogeneous over all dimensions. There are some dimensions where we have a lot of bias and some dimensions where we have less bias. So, for example, some, let's say, main observations is that RIPE-Atlas is biased, but is less biased than the route collector projects of RIS and route views. Another observation is that RIS has quite large bias on topology features, which can be explained because route collectors of RIS are connected to IXPs, where networks peer with many other networks. And it has also quite large bias in terms of network size because the majority of the peers are large networks. The peers of RIS are large networks. And finally, we can see that all platforms have relatively low bias on the network type dimensions. So in terms of how representative they are in terms of network types. There is bias also there, but it's lower compared to other biases. And this analysis can be done also on other measurement platforms or even for specific measurement purposes. So for example, we analyzed what is the bias of the peers of RIS and route views that are full feeds that provide more data. And the bias there, it's higher. It's the red area where you can see that it's larger than when we consider all the collectors. And another example, it's in the RIPE-Atlas platform, where we compared the bias between the IPv6 probes and IPv4 probes. IPv6 probes were a little more biased. However, the difference is not that big. So why it's important to know all these things and to see this plot and maybe pay some attention to this? It's because the bias, as I told you before, affects our insights, the insights we can get out of the measurements. So we believe it's important for someone who works with these platforms or wants to take decisions by the measurement data he sees to take into account that there is bias and maybe handle it depending on his use case or her use case. Because there are different use cases, we cannot have a generic rule for all of them. So some things someone can think before trying to interpret the results. It's at first, which dimensions of bias would affect my measurements? Some measurements are about latency, some other are about routing paths, etc. Not all dimensions may be relevant to his measurement objective. And then they could go to our plot and see if there is bias there. And in fact, in our website, we provide more detailed data about why this bias exists. It's on, for example, as I showed you before, it's on NSPs, it's on CDNs, etc. And in fact, we did a short survey, and we found out that not all people are aware about the bias. There are some experts that know about bias. So our main goal with this presentation and the article we have written, it's about to raise awareness between the community. So to be careful when you interpret your results, and then even to deepen our understanding, even for expert users. So there are also some next steps we can do about the bias. We can reduce the bias, and there are two approaches to this. At first, it's from the existing infrastructure we have to carefully select what data to use. For example, select probes or select data from RIPE RIS in order to reduce the bias in the data we have. And the second option, it's to extend the infrastructure, but in a way that it is bias-free. And I'm not going to present you any of these results here, but stay tuned to our project. We are going soon to publish some results on this. So that was all from me. And what I would like from you is to give us feedback, because that's something that's the research we do for the community, for everyone. So to give us feedback in order to improve our analysis, or maybe build a tool for you. And in fact, tell us if you like it, or if you don't like it. If you don't like it, it would be more important feedback for us. And also, apart from the questions, we'll be around with a meal. So yeah, you can chat with us. Thank you.
Thank you. Thank you very much. I would actually like to thank you too, because I was working in that research world as well. And I was always sure this phenomenon exists. I was just too lazy to investigate because it is a lot of legwork. So great job you did there.
Thank you.
So let's get started.
Tema Gabrichenko, Source.com Cyprus. You've had a story yet in errors. Sorry, I'm still learning. Do you want to know how deep is the rabbit hole really? I've seen it down somewhere in IRTF proceedings, probably, that the peering DB network type itself, it's significantly biased towards ISPs away from enterprise networks. So I mean, it's a lot of collateral there.
Yeah, that's true. So. And in fact, the biases I presented you, some of them are based on the peering DB dataset, that it is biased by itself, but it's the best we can do. We don't have more data to analyze. But there are some other dimensions that are not based on peering DB, so we have information for all networks. But this is a valid limitation. But if you have any idea on how we could augment the data in peering DB, yeah, that would help us.
Thank you.
Leonard, Individual Network Berlin. On the first slide, I think you had a bar chart where all AS bar was lower than the RIPE Atlas or RIS bar there. Yeah.
Oops. I overdid it. Yeah. It has some delay. Yeah. Sorry.
Yeah, no problem.
So
maybe you can already phrase your question while he's.
So I don't understand why all AS is lower than RIPE Atlas, the orange.
No, it's not. It's not all. So in fact, these percentages count up to 100% for each color. So if you sum up all blue bars, they are 100%. So they cannot be always high upper.
Okay.
Do I miss something?
I don't know. Maybe I just have problems to understand it. But yeah, if it makes sense, then it's okay.
Let's take this offline.
Yeah.
Hi, Ivan Beveridge from IG. I was wondering if you'd done analysis on any of the commercial kind of equivalent systems that perhaps.
You mean commercial platforms?
Yes.
Yeah. No, we did not do.
Is that something you're planning on doing, or?
It depends. If we have data, we can do. And what I mean by data is we just need to know what parts they measure, where are the networks they measure from. So just give me a list of networks for a measurement platform. is it RIPE Atlas, is it any other platform, and I can produce you this nice plot. I just need an input of networks. Yeah.
Okay, that's very interesting. Thank you very much.
Hi, James Rice, Jump Networks. Apologies if I missed an explanation somewhere along there, but I didn't quite catch what you would consider to be unbiased, as it's equal weighting or even distribution per prefix or per IP address or per autonomous system number or per network operator, or what would you define as being unbiased here?
Yeah. So at first, our analysis, it has been done on AS level. So we did not consider more fine-grained analysis, and that's because there are the public data. Most of the public data we're based on, it goes on an AS level. So in order to do it in a more fine-grained level, you need to do some extra measurements to collect the data by yourself. It's doable, it's extensible. You just do exactly the same thing, but you just need different data, and that's one of the things that we are planning to do. Now, what does it mean to be unbiased? So, for example, here in this plot, in the optimal scenario, we would like the green bars or the orange bars or the red bars to be equal as the blue bars. So, for example, let's say that in the world, there is 10% of large networks and 90% of small networks. We would like the peers of RIPE-RIS to be 10% small, large and 90% small. I understand that this is maybe not what RIPE-RIS would like, because they connect to large networks, because they get more information from them. So bias, it's not the single objective we may have when we build the platform, and probably that's why the platforms are biased. But it's something that we could take into account. And there are nice trade-offs. We have seen nice trade-offs that you can both have a lot of data and satisfy your other objectives, and at the same time be unbiased.
Okay. Thanks.
Okay, thank you, Pavlos.
Great. We now call our last presenter for today. It's actually last moment submission, Aaron Glenn from Predicted Path BV. Thank you very much. We got a bit of time. I think it's 15 minutes. I'll start it now.
Yeah, it's really quick. I didn't realize lightning talks were this long. Yeah, my name's Aaron Glenn. I'm someone else in this slide. If you're not familiar, I've been talking about programmable data planes and the language that allows you to do that, or at least one of the most popular ones. It is called P4. I've been talking about it for many years, and one of the biggest problems is the developer experience. People want to go from, okay, let me try to program something, to actually programming it, not spending 3 hours downloading a Vagrant VM. So in order to fix this, next slide, do I press this thing? No.
Just the big button on the remote.
There we go. All right. So you can open up your browser. You can go to the vanity domain c.p, the number 4, .works. You will be presented with a little text box. This is to keep the general internet out, because these are just little containers that last for like 3 days. No login, no really saving state. The cookie will let you come back to the browser tab in like 24 hours. GDPR scares me. I don't want to know anything about you. Please just write some P4 and have fun. It's intended to be a quick thing over coffee. I really do mean that. If you spend a little bit of time and just run the Python scripts and the little P4 app thing, you can experience a learning layer 2 switch in like 15 minutes. And my hope is that it kind of wets your whistle, so to speak, that you're actually a little more interested in it and play around with it. If you do get bit by the bug, I'm happy to share the Docker file with you. I'm not just putting it out there because I want to talk to people who are interested, not looky-loos. So if you're interested, email me. I have another vanity domain, hello@routing.games. Last bit, I'm trying to set up a situation where you might be able to get some actual IP address resources, Anycasted, on the internet and run your own P4 programs attached to them. If you are able to do the exercises and make your own working layer 3 IP router, I I can give you a /32 that's anycasted. I can give you a /44 that's also anycasted, and you can start running your own network functions there on the internet. Set up a GRE tunnel, IP tunnel, literally anything that Linux supports. Write your own P4 program to handle the encapsulation. Obviously, it has to go over the general internet, so no SRv6. Anyway, it's not a long one. Everything is copied from the wonderful work of Dr. Lauren Van Beevert and his group at ETH Zurich. They have a wonderful Git repo called P4 Learning. It starts with the hello world example of reflecting a MAC address back at you. Example 4 is an MPLS label switch. So it goes pretty quickly and you can start doing some real stuff with it. But the surprising part to me when I got into this a few years ago is it's not that many more lines of code. Layer 2 Ethernet learning switch doesn't have that many more lines of code to get MPLS and a deep label stack. I'm sorry I don't have any slides on P4. Again, I figured this would be like a 5-minute thing. So if you're interested in P4, there are a lot of great resources on the internet. I gave 2 talks in the before times at RIPE. They're probably a little dated, but should at least point you in the right direction. Please try it out. Please reach out to me. Come find me. I'm here all till Friday, and I look forward to interacting with any of you interested. Thank you.
Thank you, Aaron. But you have to stay on stage for a bit because we actually have a comment.
Oh, I didn't say what to put in the text box, right? Yeah. Thank you. All right, so in the text box, it is the future. Capitalized T, capitalized F, there is a space. That will open it up for you. Don't tweet that. I don't need this thing on the general internet and a bunch of people screwing it up. Thank you. Okay.
Good point, but that was not the thing.
Oh, sorry. I realized it. Anyway.
Well done. I mean, this was actually a real lightning talk for a change. So we have Kurt Kaiser in his private capacity, and he comments, I consider P4 a very smart idea to decouple software stacks from hardware vendors. I really would like to see this used more in government networks or critical infrastructure that should be locked into fixed hardware software cycles from volatile vendors. Please consider it seriously.
Call Ed Doe at Intel. I mean, I talk to him like once a quarter. He would love to hear from you. Go buy Tofino's. They might give you a hard time to get the software development experience, but I told him that was hard and you should tell him it's also hard. Anyway, yeah, it's a thing. It's considered. Please. Yeah, great. Email me. Love it.
Okay, cool. Thank you.
Thank you.
And with that, we give you a couple of minutes back for your next coffee break. And after the coffee break, in this room, you will find the B Corp task force that talks about best current operational practices. And in the side room is the meeting of the Code of Conduct recruitment team. And after that, we will have a great social event, 2 days of working groups, and the plenary will be back for you on Friday. And please vote for the PC.
Yeah. Give it a minute. So. Welcome everyone. Good to be back. So the B Corp Task Force. Welcome. For the next hour, we talk about IDs, maybe good IDs, maybe IDs that had to be documented. It's good for the community, good for the operations of your networks. So this is all about with the B Corp Task Force. So we're thinking about, well, there will be 2 presentations this evening. And the idea is that it's kind of spinning up an ID. If it's good, maybe delegate it to one of the working groups. The work can be done in the working group, and then it's back to the task force, kind of finalizing the work or presenting this has to be finalized. So this is the idea of the B Corp Task Force. So best current operational practices. We're not a working group. We deliberately not decided to be a working group. Also because of the form, the lightweight we want to use and to be early in the week. Maybe I should reintroduce myself, Benno Overeinder, B Corp Task Force, Jan George, well-known PC member and B Corp Task Force co-chair. We're chairing this session. Good. So for today, let's see. This should work. Next slide. Oh, there's a delay. Okay. Not that much. Yeah. Marco, can you please help me out? Oh, there. Okay. There is only one slide. I see 2 slides on the Meet Echo. How do you call that? The screen say don't touch it, but I see the next slide. I want to swipe, but do not touch the screen. Well, it's the agenda. It's the 2 speakers. That is Chris, who presented this afternoon or afternoon session about the green data centers, and will now present another idea he has. And Sander Stefan. Oh, there it is. Yeah, Chris Adams. So indeed, IT procurement and sustainability will be the first agenda item. Next agenda item is Sander Stefan, building resilient networks. Yeah, we call it agenda bashing, but that's the agenda. So maybe you have some comments or additions. We have an open mic afterwards. Jan, you have something to add? Excellent, thanks. Can I invite Chris, or you want to? If you want, you can present your own presentation. Oh, Marco's already giving instructions. Yeah, yeah, no problem. Sander will kick off. No problem. Yeah, excellent. Yeah, thank you. Yeah, Sander will not use any slides, I understand. So
I predicted this.
yeah.
Yeah. So.
Yeah.
Hi. All good. So, as you probably know, Jan and I are part of a foundation that helps network operators. We started working on this, and doing simple things like we have a Zoom license that we use to help NOGs to organize their meetings. We have some software, for organizing events. We host websites. So those are just the little things. But then suddenly we had this massive war in Ukraine. So while we were looking at what can we do for the network operators there was actually a thought like, okay, we should not just like wing it this time and then forget about it. We should work on making like a BCOP, a document best practices, like how can we deal with this, and even better, how can we prevent this? Like, what are the things that are necessary to make the network resilient? So what can people do before things go wrong? What can you do while things are going wrong? What do you need when rebuilding? So we basically have this this slot. There were some thoughts on the mailing list, but I intentionally didn't put anything on slides because I actually want to have a discussion and see if people are willing to help to work on this. There were some great ideas already, but we need to think like this is something that's now in our backyard. But bad things, war, disasters, nature, this happens all over the world, and I think in this part of the world we've been pretty lucky that we didn't have too many major disasters. But now that we see what happens in Ukraine, and for example, one of the things is they still have working internet, which is amazing, but it's very much centered around Kiev, for example. And they were really afraid that if when Kiev was under attack, if that would fail, then a whole lot of connectivity in the whole country would fail. So we've been discussing, okay, maybe they were looking at building a ring around Kiev, so they would have backup paths. These are things we're thinking about, but also, what do you need during an incident, a war, a disaster? And we found out that in our work that the most difficult bit is paperwork, logistics. Luckily, we already had a foundation that could serve as the basis for this. So you have some legal status that you can use for customs. But maybe there are things that that could be prepared. So we are better to deal with instances like this in the future. So I actually just want to ask people in the room, like, do you have ideas? Like, of course, there were things mentioned on the mailing list, but let's start from scratch here. What do you think we can work on as a community to make the internet more resilient for everybody?
Hi, I'm not sure whether I should order a comment with the Meet Echo, but starting aside of speaking,
let's keep it simple.
Speaking on behalf of myself, what can we do as a community? We can put more efforts on building the local communities, because that's can help people to communicate within the country and then build better internet. Even when there are not enough, let's say, links or interconnections of network before the disaster, then the people can organize themselves after the disaster starts.
Thank you. You know, and the interesting thing is that René didn't mention in his presentation is what is the second most requested thing that people from Ukraine are asking us after fiber splicers. It's actually wireless access points and power over Ethernet switches. And I was asking them why. They said, okay, when bombs start falling down from the sky, people go into shelters. When they go into shelters, they lose the mobile connectivity. They are cut away from the world. They can't call, they can't communicate. And bombs are falling, and these people is completely disconnected from the world. So now they are very busy. We are sending them lots of wireless equipment. They are installing wireless access points in the shelters. So when people go down, they can communicate. They can call other people. They can say, we are still alive. And you would never think about something like this if there is no war. Because now if you think, why would I put wireless into the shelter, right? But then when you need it, it's not there. So how can we learn from this very unfortunate event, but learn how to make the networks in other countries better, more resilient to things like this? That's the question.
Hi, I'm Vesna. I have 3 suggestions, and they're all about cross-connecting with other organizations, existing organizations. One of them is NSRC, which also has an overlap with our community. Philip Smith, who I just saw here, and Sebastian, and many other people, they have been doing helping the communities in the developing world to build more resilient networks, and mostly by education and workshops. So that's one. The second is connecting with the refugee organizations that exist in many countries and actually asking them what would they need, and then going from there. And there was a third one. I don't know. So it will come to me.
Great. Thank you. So yeah, it was really interesting. Some of the responses we got when we started asking for help for Ukraine. People also didn't seem to understand how advanced the internet in Ukraine was. We literally got offers for people saying, "Oh, I got a couple of 100 megabit switches. Oh, sorry, 100 megabit hubs. Are you interested?" Sorry, please change the M by a G. They need 100 gigabits gear. And that actually was made much more difficult because of the chip shortage we experienced the last couple of years. So we talked to Juniper, we talked to Ariska, we talked to Cisco. They themselves don't have enough high-end equipment available. So they, even though they wanted to, they couldn't donate it. I tried contacting second-hand hardware vendors. And because the new equipment ran out, a lot of people went with the second-hand equipment, so they also run out. So this might just be a coincidence at the moment. But yeah, when something bad happens, we really have to start thinking about, okay, you know, where do we get the spares from? Like, how are we? And in these cases, competitors are not competitors anymore. If they have something and their neighbor needs it, they help them. And so this is something that I've been thinking about a lot. Like, what can we do to make this more of a community thing? That when disaster strikes, all the competition is set aside, and we have a way of working together on this. Sorry, Vesna, I see.
Yes, so I remembered, and it is a little bit opposite from what you're saying. I think we should focus on low tech and go back to repurposing, repairing, especially connecting to the next presentation, which is about like the fossil-free fossil fuel-free internet and technology in general, so that we shouldn't be aiming to this like highest tech possible, but seeing how can we meet the needs of people by using the low bandwidth, low tech, old-fashioned equipment, and like getting connected with repair cafes and a right to repair movement, so that the old equipment doesn't expire, but that we can actually reuse it.
Thank you. Yep.
Thomas in Berlin. I also think that high-speed internet is cool for normal life, but we are discussing here about emergency communications. People like to have a chat to say they are alive, and possibly we could learn from projects like Freifunk with routers and self-organizing networks. There are existing routing protocols for self-organizing mesh networks. They are not capable to do live streams and so on, but they are easily to set up, even by people without any knowledge. You can power it with solar power, an example. And with this setup, you may be able to get a few kilometers or a few 10 kilometers to the next working infrastructure.
Thank you. Yeah, the one thing I'm worried about is I know, for example, in Ukraine that the Russians have small rockets that home in on radio signals. So operating a strong radio signal might actually be a risk as well. So, but it's definitely something to think about. Thank you.
Please. Yeah. My name's Ivan Beveridge. So,
can you go closer, please?
Sorry, I don't know how loud. My kind of queries in things that we briefly discussed were primarily sort of questions about the logistics side, and we kind of, certainly as tech people, we kind of go straight onto the technology side, and then you find out the issues around perhaps things that you've mentioned, like licensing, upgrades, all that kind of thing. Are you getting the have you got into the vendors to actually be able to get the approval to do these kind of things?
So for Arista, we have Florian, yeah, thank you. I'm sorry, I'm getting tired, and it's only Tuesday. Yeah, so for Arista, Florian said, let them contact me, I'll sort it out. I had contact with Juniper, a friend of mine actually just emailed the CEO and was like, hey, help us figure this out. Haven't managed to get very high up in Cisco yet, but the problem is that you need to get like to the top of the management, because nobody else has the authority to sign off on something that sounds as simple as, yeah, sure, they can download a firmware image, but no, there's lots of rules in place. And this is something we're actually working on to see for this disaster and for the future, that with the major vendors, we kind of have contacts that maybe we cannot give all the operators in Ukraine a login to download stuff, but at least we are permitted to redistribute the images for them. So, stuff like that.
Yeah, because there's partly that, and the proliferation of, with the proliferation of things like Ubiquity, which might be quite useful as well, and Meraki and that kind of thing, whereby your control plane's in the cloud, therefore you need a license, and the hardware that you may have is totally useless unless you've got a license, all that kind of thing. So that's sort of partly why I was wondering. And also there's things that you touched on, like not only the logistics of getting the kit somewhere where you guys can kind of get it moved. But the VAT tax implications, all that kind of thing that, you know, I think that's quite a useful thing that we again, as techies, we really don't want to be worrying about, because we don't really like that stuff.
Rene very aptly said at the, when the first truck went to Ukraine, Jan, Sander, how does it feel to go from network engineer to logistics manager in 3 weeks?
And the last thing I'll touch on, certainly that Vesna kind of mentioned, I think some of the stuff that where the guys are looking at the developing countries, you get things like you know, radio, long distance radio, perhaps line of sight, you know, microwave kind of things, whereby perhaps you'd get a sort of a significant step into the country. How well that would work, I don't know, but it may get you some kind of amount of bandwidth for a particular distance, at least to cover some breaks.
Yeah, good that you mentioned that. I did, like a decade ago, I went to Palestine to do some IPv6 trading there. And they have a lot of issues with fibers being damaged and stuff like that. They are amazing with radio and microwave technology. So maybe we should ask our friends from those regions about how to do these things. That's a really good one. Thank you.
I'll mention that there's a few of the guys in the US that we know as well that are really kind of hot on that. But yeah.
Thank you. That's it.
I saw somebody else who wanted to go to the queue, but now the queue is empty. Oh.
It's me again.
We don't mind.
I just got worried when I heard you talking about the licensing and that being a problem. Is there a replacement which is like open source, free software technology where you don't have to talk to the director to get a special treatment?
Sometimes.
Well, very, very rarely. It's if you're talking about like backbone providers, getting open source free 10 or 100 gig gear is quite complex, especially with a large number of ports.
Please.
My name is David Schweitzer. I'm working for NetDev and open source routing. So yes, there are alternatives. There are also very performant alternatives with, for example, a new plugin that was developed. It is called Linux Control Plane, the LCP-ng plugin for VPP. For those who haven't seen that, go check it out.
Pim did a great job on that.
Yeah. And we have made, we've done tests with FR routing. So far, it seems very performant and good for BGP and OSPF. We haven't had success with ISIs.
Thank you.
Anyone else?
Yeah. When I said there's very little open source, like if I was more thinking about like 48 port devices, that gets a bit complicated. Do you know anything for that?
So currently VPP is performant for one core, for one interface. We have done tests up to 10G. So if you have as many cores as you have, you can have interfaces. And you can scale that up. We are maybe talking 100G on the New Horizon series.
Okay, cool.
For maybe 64 ports if you have 64 cores.
I did some years ago. I did some testing with VPP for NAT64, and we got up to 180 gigabits on a single socket, and we couldn't figure out why we couldn't go higher. And it turned out that it wasn't the core; it was the PCI lanes that were all full.
Again, if you're looking at technical solutions like that, there's the I know whatever. So Arista built some hardware around discussions and so on with Facebook, and so that particular hardware is 40 gig, 100 gig, whatever. So I think the Open Compute system platform has some routing stuff in that would kind of deal with that, if that's what you're after. I'm kind of, it's anything's good. I'm kind of thinking to some extent that I should imagine that the network engineers and so on there are kind of, this is my skill set, and if I'm put in front of an iOS-like configuration or Junos or whatever, then I can probably deal with that. Perhaps in certain circumstances they may not have time or whatever to look at alternatives, but again, anything's better than nothing. So.
Definitely. And yeah, you rightfully mentioned that yes, we're techies. We focus on technical solutions, but we definitely need to look beyond that. And yeah, that's a little bit out of my own comfort zone. So, but yeah, it's really important. And I never imagined that I would see a war with Russia in my lifetime. I thought we left all of that behind us, but yeah.
So what I'm wondering is this the topic that could become the best current practice document? What do you people think? It's good enough. Yeah?
I think collaboration, as Esna said, this kind of thing we'll hope will never be used again or will never be needed again, but exactly. But I think it could serve as a sort of a foundation for even developing countries or anything like that. And it is this stuff, I feel it is this stuff that we hate and don't want to touch. The logistics, the who can I contact, or who's got some kind of knowledge in this.
Bureaucracy.
That's exactly that. And we've got a cooperation work group here, which could be a useful, help us in that kind of side. So I think it's definitely a worthwhile subject that we're not very good at, broadly speaking.
That's actually a good idea. So because there are so many different factors in all this, there's technical, political. Maybe we could start with something like work with the cooperation working group and try to isolate that bit and make a big up about that. Yep. Because trying to do everything at once, nothing will get done.
Please.
Yeah, Alistair Woodman, NetDef. I think it's the idea of best common practices is a very interesting idea because there's only a very small intersection, which I think was well articulated by you actually need to know about getting past VAT things and all those other bureaucracy things, but the common nature of this problem I don't think is going to be repeatable. Well, I hope it's not going to be repeatable. So the specific issues associated with supply chain issues, COVID, run over, as well as a war, right, I think are going to be relatively, well, I'm hoping they're relatively unique, right? So the planning, like the old adage about, generals are always planning for the last war. We don't want to be planning for the next event with all our learning from this event. So I actually think the creativity that you guys have shown by just winging it is really the thing that needs to happen. And we got to figure out how to be able to wing stuff faster, whatever stuff is, right? So if it's what you want, power over Ethernet down that because people are being, that's the only place that they can shelter, then that's the right thing for that. But we're going to have droughts or whatever it is, and that's not then the appropriate behavior for a drought situation. So we need to sort of maybe have scenario planning thing to figure out what we would do under certain, but we don't want to write this thing down because I don't think the next thing is going to look like this thing.
More generalized.
Yes, we need to think about other stuff. And again, I do think that bureaucracy is the thing that it's useful to figure out how to make those things work faster.
Because it's what delayed us the most when doing the stuff for Ukraine. So thinking from our own experience, if we had a list that said, if you are doing humanitarian aid for whatever, for example, the moment we were like, oh, we have a bunch of routers and switches we want to bring over the border. And then suddenly somebody brings up, oh, but this is dual use equipment. This might be used for bad and contains cryptography. You need a different export license for that. So listing those things would actually.
Right. But did anybody reach out to the UNHCR for refugee folks like that high up at the UN?
We didn't have time because when,
right.
When we started, the whole thing started coming in, and we were working day and night.
Jan, what was the guy in Slovenia's name who actually works for the UN?
No, he's from Serbia.
Yeah.
Yeah. We talked to UN, and they will try to.
Right. They're catching up with us now. So we actually got approached by the European Commission last week.
Right. So, but the point I'm taking away from this is that we should try and crowdsource our the layer 9 network connectivity about who knows people.
Exactly.
Right? And preload that thing into the system. So I think I happen to know somebody relatively high up at UNHCR personally, and it had not occurred to me till I was sitting in this room that, oh, if I'd have known, I could have shared that information, maybe not the direct contact of the person, but the fact that I think I'm one hop away from UNHCR headquarters, if that's what you guys need.
Excellent.
Right. And comments about Cisco, I might be able to go rattle some chains at Cisco but that people could sort of have that Rolodex for these types of things so that we can then crowdsource what do we need? Because to everybody's point, people stop competing and are willing to cooperate very quickly. So you just have to find the connection to make it work. And if you can pre-bind that stuff as opposed to just working around, because it's pretty obvious we'll probably want to talk to UNHCR next time round.
Okay.
So.
Yeah. We are learning.
Just as an example, and I'm not throwing rocks. I mean, you guys have done a great job. I'm just saying if you were going to do stuff, it's that level of political connectivity or the ability to do that quickly, get on the phone with somebody is probably what's necessary.
If you can help us with that, pleasure.
Yeah, I think it's the outcome of this session so far. Working with the cooperation working group, working like building like the crowdsourcing layer 9 stuff. Those are very good points, I think, because we can't do everything at once. I think those should be the first points we start working on. Any objections?
Yes.
I see. Yeah. Sorry.
One last thing, Marcos from Dickix.
Come on, Gordon.
First of all, you did a great job with everything you presented us, and
it's a hobby.
If I try to abstract this a bit, because maybe the specifics won't repeat like this, what we are trying to recommend is for network operators to have some kind of business continuity management at some certain level, and there are standards for that. Okay, like ISO 2022 something, but those standards are not open. So what about kind of open source business continuity that we document and orientate on practices, and we hand out to network operators to say, if you want to be able to continue your business, to take a look at this.
That's a great idea.
Do you have experience with that?
A bit.
Are you currently volunteering?
Happy to help.
Thank you.
Thank you very much. Gordon.
Why am I here?
Yes.
Just listening, I suddenly realized there was something I was looking at some years ago. I think everyone knows about Doctors Without Frontiers, Médecins Sans Frontières. There's another NGO called Télécoms Sans Frontières. And they've been around for a long time. And this is their game from the telecoms point of view, not the internet point of view. But they're there, they've got a setup. I think somebody has to contact them and talk to them about what they are doing, because apparently they're already active in Ukraine. And well, we all know that internet and telecoms are not the same thing, are they? But yeah, joking apart, they are there because from the telecoms background, they're probably more bureaucratic than we are. And that might be useful in this case.
They might have experience with the bits we're lacking.
Indeed. They've had a lot of experience with getting stuff into areas. And they are doing something, according to the website, they're doing something in Ukraine right now. So there has to be contact. I don't know who takes that on, but there has to be some contact to see what they're doing, if there's any synergy possible, and even learning how to get stuff into areas, because they've been doing it for, I don't know, 30 years.
Do you know them?
I don't know them, but they've got a website. It's easy enough to contact. Telecom Sans Frontières. Okay, thank you.
Thank you. Any other thought?
I think we have a good starting point to continue this.
Exactly.
Thank you.
Would like anyone to join Sander in this work and help with stuff?
Not
Any
all at
volunteers? Vesna, yeah. Okay. If you don't want to lift your hand now, or if you decide to do it later, talk to Sander or to me. Thank you very much, Sander.
Thank you.
Thanks, Jan. So yeah, thank you, Sander. And what Alistair was saying, I was nodding that hard, almost my head rolled off my body. I completely agree. It's disasters in general. It's not only this war we're talking about, but we have to be prepared for the next disaster. Next, can I invite you, Chris? Your slides are uploaded and ready, or you want to connect? Yeah. Oh, there
they are.
Yeah,
That's
excellent.
cool. All right.
So either you can use this microphone if you want to walk around.
Okay,
or
I'm just going to use this because it's easier. And then where is the kind of clicker thing to go forward or backwards? Oh, the green forward button. That's kind of cool. Did that work? Yeah. Excellent.
Excellent. Success.
Okay.
Go in.
Hi, folks. This wasn't initially my. I'm very much kind of picking up a project that was actually pushed by or carried by a gentleman called Michael Ogier at previous RIPE events. So this is me carrying the torch, and I hope that other people might also be interested in doing something along these lines. Oh, I just realized that me frantically changing this meant that I've got the wrong link in there, so forget about that part. The thing I wanted to actually just share with you or kind of talk about some of this is that I've spoken about, okay, yes, it's important. We should be thinking about the environmental impact of the stuff that we do. But a lot of the time, there are lessons that we can see from other communities and other sectors where they've been able to end up with much more equitable outcomes. And the example that I think is kind of interesting that I'd like to share with you and possibly have as a starting point for discussion is some of the stuff that we've seen where people have made accessibility much more of a thing with websites and other such devices. So first of all, just has anyone heard of tools, think anything like the WCAG, WCAG, Web Content Accessibility Guidelines, or anything like that? Okay, got one or two nods. Okay, this is reassuring. Basically, I mentioned this when I was doing a talk, and this is the idea of this whole kind of gold thing I was talking about before. POUR is basically one of 4 principles in these guidelines, which are used to allow people to kind of explain the importance of accessibility in a way that people are able to write into contracts. And because people who are large purchasers, like say public sector, or often will actually be able to say, look, we think this is really important. And because we're spending this much money, we really want this to be, we basically have sufficient buying power to force your hand to make sure this is actually going to be a thing that everyone has to include if they work on something. And this creates something of a level playing field. There's some examples that we've seen with things like, say, e-readers, like, say, Amazon Kindles and things like that. They previously were not tools that were very accessible to anyone who's partially sighted. But through having some kind of guidelines like this, and I'll just move to the next example, because there were guidelines that people could refer to when they were procuring things, we ended up with examples like, say, the New York Public Library saying, Amazon, we know you're $1 trillion organization, but we're spending enough money that you're not going to get this contract unless you make sure that your products are accessible to people who are partially sighted. And they were spending enough money to justify doing this, but also because they basically said everyone has to meet this bar, there was very, very difficult for someone to say, well, I can't possibly do this and give away a competitive advantage. They set the bar at a certain level. And I think you can do something like this for sustainability as well, because in many other sectors, we've seen certain groups, we've seen kind of norms be set at a kind of public sector level first before you get private sector moving into this. So this is what I figured we might talk about in the time that we have. So if there are examples of good, if you sell to public sector that you've seen that have been made it possible for you to say, well, we'll make the argument to do something more sustainable technology-wise. I figure this might be worth something for the private sector as well. If there are examples there you can point to. I was going to ask a little bit about sample language that you can use, and I'll touch that in a second. Then I wanted to kind of throw the floor open to see what kind of blockers there are that are stopping us being able to adopt some of these practices. And most of us, I would say that we, given the choice, we would choose to do this if we could. And in many cases, there are like organizational reasons for it not to happen. And if you don't know how to actually change some of the organizational drivers, then a lot of us will just feel a bit unhappy that things that we want to see happen aren't happening. So this is an example of what I'm talking about when it comes to like public sector. So in the UK, if you want to sell to UK government, they've got some relatively stringent guidelines that you need to actually meet if you're going to sell to them now. And this is the kind of stuff which, again, creates that level playing field that everyone has to be using. So if you're in an organization, a manager or a boss can't say, I'm not going to take on this cost. They know that everyone and all their competitors will also be taking on this cost. And there are now, in the private sector, there are tools and there is guidance about saying these are the targets you need to actually set. But there isn't so much in terms of guidance for people with specific domain expertise. So before I came to this conference, I had no idea there were tools like P4 that allowed you to kind of abstract away some of the kind of network activity, the kind of activity you want for, say, a network switch or anything like that from the underlying hardware. And I feel like this is the kind of thing which means that you can have the logic essentially abstracted the way that would mean that you could have multiple different kinds of tools providing the same behavior, for example. And the reason I'm sharing, there are examples from private sector which I think of some use, but I think it's also worth looking at if we're going to kind of work in an area which we're not that comfortable, for example, like procurement, because I don't think anyone's a professional procurement specialist here, are they? No, no one is around for this. The thing is, there are groups like, say, lawyers who actually are taking kind of open source approach for stuff like this. So this is a group called the Chancery Lane Project. And what they've been doing is they've been trying to like create essentially open source clauses that you might put into contracts to allow you to set useful defaults that result in more sustainable procurement. And an example of this is these folks making this stuff specifically for certain ways of buying things. And what they did was they basically realized that lawyers, they work a little bit like, if you forgive the kind of bad example, if okay, anyone here used like a WordPress website before, right? Or, okay, so there's like WordPress, which is one piece of software. And then there are these kind of plugins that allow you to extend functionality. And pretty much this is a kind of typical open source approach. It turns out that when you're looking at law and contracts, it's often very, very similar. There are kind of some standard form contracts, which are a little bit like your kind of Linux operating system. And then you can have like these clauses, which are a little bit like kernel extensions, provide more kinds of behavior. And this is basically the approach that was adopted, which was thrown out into the world for people to use. And this is what Salesforce have ended up using as part of their own procurement practices now. They have a contract called the Salesforce Sustainability Exhibit, which they basically use with all their suppliers now. And that contract has some very, very specific guidelines in it saying, if you're going to sell to us, you need to disclose carbon emissions, you need to agree to be doing this, this, and this. And these things that they've adopted were basically the clauses that we saw before that were in the domain. Someone realized that they're basically open source things and they bolted them onto the standard form contract. And that's what we're looking at here. And I think you could probably do something similar in this domain as well. Because let's be real, most of us aren't really competing on sustainability for procurement for this kind of stuff. So it feels like a thing where you probably have more to gain by sharing some standards rather than kind of jealously guarding this kind of stuff. Is this going to go forwards? So yeah, that was one idea that I want to kind of throw out and point to that I found interesting and possibly relevant for this discussion. And then I figured it might be useful to just like throw these questions out to you folks. If you have tried to get any kind of procurement, and you don't obviously, you might not want to name your existing employer or anything like that, but if there are things stopping you buy sustainably or stopping you sell sustainably, then knowing this would be really, really helpful so that you can talk about, okay, anti-patterns and things you might want to address. And yeah, that's kind of it. I've actually got a kind of notepad that you can kind of put things into it. I've been adding some links, and I figured if there are examples that we might refer to, then this is a way to capture some of the discussion we're actually happening that we could then take into a mailing list or something like that afterwards. And now that's kind of me, really. I'm going to hand over to this gentleman here, actually, who I'm sorry for, I forgot your name, even though you were speaking just before me. Yeah.
Hey, sound. So yeah, I think this is a really good idea. I mean, we have experience with RIPE 501, RIPE 554, and RIPE 772 for requirements in IPv6 for IPv6 compatibility. And that has shown how effective it is to have a common requirement that a lot of organizations use. Because if it's just one organization asking for it, they just go like, yeah, I'm sorry, we're not signing this. But if suddenly half their customers start asking for it, that has a real power. So I think this is a really good idea. Thank you.
Cool.
Hi, I'm Tim. I just wanted to share one observation. If you look into the marketing materials of Apple, for example, you will find that they obviously decided that sustainability is a new, let's call it, feature of their products, which they are advertising and which they're pointing out where they're better than, or allegedly better than the competition. So I think actually the last two questions which you asked, maybe we actually start seeing demands pushing efforts in that direction. Hopefully we see that. The other observation is more from the governance perspective. I don't know what's the current status, but in Germany I noticed some discussions regarding supply chain regulations and so on and so forth. And so I see that people are thinking about it, and obviously any help would be appreciated, I would guess. So just observations.
I'm really glad you brought up the Apple example, because there's some really interesting stuff with Apple. Apple traditionally have not been that great on things like right to repair or being able to, well, get anything repaired.
Absolutely, yeah.
Yeah. Now the thing that you've seen in the last, like, say, month or two, you've seen changes in the law brought about by some sample language, which basically has said, well, if that has got very, very large organizations starting to move on this. And this has actually come from shareholder resolutions being put forward by organizations. And if you're going to have that, you need to have that sample language coming from somewhere in the first place to say, these are the things that we're going to be asking for or requesting. Microsoft have basically ended up doing this partly because shareholders have been looking for some language to use to say, we want you to incorporate this in how you make things. And what they've ended up doing was they were able to get, commission some work, not agree to it to begin with, commission the work, and now the report has basically said, yes, there are absolutely sustainability advantages from having repairable, extendable surfaces and things like that. And this has led to legislation, which is basically meaning that you now will see Google, Apple, and Microsoft doing this kind of stuff. So there's all these different ways to get this out there, and people will reach for what's available, and most people don't even know there's stuff like the crazy P4 stuff I discovered today, for example, or even any of the other problems that we face, like we just mentioned about not having a license for a switch, for example.
I think I also see some parallels with privacy related stuff. So that's another, just not to pick out Apple again, but they obviously noticed, okay, if we like it or not, we can distinguish ourselves in that regard from like Google or other competitors. So I think we need to help them actually, continue that, because I would love to see it. And I think users, or the money basically drives that. So I hope we can, yeah, build a little bit of pressure by choosing the choosing what we buy.
This is some of the stuff that KD has been doing some work so far. I mentioned Ocular, the PDF, like the first certified one. One of the reasons that you have things like the Blue Angel certificate or process is because there is talk about it being used as a criterion for German procurement now. So if you want to sell to German, you need to be able to show this and show compliance or be able to demonstrate performance along these sustainability metrics that didn't exist previously. Yes, sir.
And so the stuff that you're saying about, you know, the large companies sort of let's say jumping on this bandwagon, something that I've noticed with my work, where I work in fintech, our company has started something up over COVID times to look at more charity work, certainly at a higher profile. And I would guess that's certainly not an isolated fact. So hopefully this, you know, with the other conferences that are going on, this will also kind of funnel into that kind of idea. So a bit more of a charitable sort of what everybody is sort of aiming for, particularly with the current situation. Hopefully that'll kind of funnel in.
Thank you. Any other one? So, Chris, I was thinking, so I'm just curious how Salesforce put that in their, in their requirement. So is that also by the shareholders you just mentioned?
Nah. Salesforce is interesting because there's actually some leadership from the very top. Right. And there's people asking for the from the very bottom. But in the middle, people don't necessarily have all the same skill, organizations don't have the roles in many cases. Like most, who has a chief sustainability officer in their company, right? One person in the entire room, right? And like, we know like it's not like climate, people haven't been talking about climate for like 10, 15 years, right? A lot of the times the organizations don't have these skills internally, right? So they'll reach for what's out there. So the thing that the folks at Chancery Lane Project recognized this and said, well, we'll put stuff out there so that people who are trying to use this, they'll reach for something, and the defaults will be quite good defaults. Because just like when we use a bit of open source software, we incorporate all these other defaults, which a lot of the time we trust that they're actually kind of quite sensible defaults a lot of the time. And that's essentially what we've seen with Salesforce. They were looking around for something, they found something which was useful and effective, just the way we look for open source software, and said, well, someone's thought about this, it's more or less good enough for what we need to actually have. And this saves us having to draft all this language ourselves. So yeah, we'll totally use it and give it another name and then say, these are the requirements we want to have for everyone else who wants to sell to us.
Yeah, good. Yeah, so because speaking for the Netherlands, so I've seen that the public sector can create some leverage for the corporations, or to, yes, and especially for standards. So that's where I have some knowledge of. But it's really the government or the public sector asking for implementation of standards. And they're not the newest standards, IPv6, for example. They're really now high on the list. We have in the Netherlands the Pastoorvleg Uitlijst, POTOL. But this is important because that pushes indeed organizations. So I was also asking myself, apparently it's not necessary, but also the public sector can create some leverage in this for companies to.
So this is exactly like, it's going to sound a bit weird, but traditionally public sector at certain levels, particularly central government, they've been somewhat less price sensitive than other sectors. And this has often been used to basically end up making it possible to do the initial first of a kind purchase for something which leads to a more equitable outcome. So the New York Library's example of them saying, well, we're going to have a $30 million contract for some kind of e-reader, and we're going to, because we're spending enough money, we can actually be explicit about saying we definitely need to have these accessibility criteria inside it. They were able to do that because there was enough in there, and the government they have a mandate to serve all the people rather than just a particular subsection of people that private sector might be. Yes.
Yeah. Yes, Jelte Jansen, SIDN. You say that the PAS2 of leg-uitlijst is a way to leverage that, but yeah, you yourself, the presenter, has already shown a much more a much more large one. That is the WCAG requirements in the Netherlands. All official software of the government must be AA compliant. And I think that in Europe, in a few years, every single web shop has to be AA compliant. And if you can get that for sustainability, that would be even much bigger steps. Yeah, because the PAS2 leg-uitlijst, the comply or explain list is usually explanation of, yeah, it's hard is enough.
Yeah, well, yeah, true. But yeah, so again, speaking for the Netherlands, we're both from the Netherlands. So we know what we're talking about. It's true. It's a well, either apply or explain indeed. But we know there's also kind of a measurement tool now, it's internet.nl, and that's being used as kind of a whip. So it's visible you're not doing some, and then after some time you really have to explain why you don't do it. So that the pressure is increasing a little bit more and more.
Yes. Oh, yeah, that's true. The internet.nl helped much more than
really
the
helps
list
for the
itself.
public sector. Yeah, and then asking companies to provide services that are, for example, DNSSEC or etc. Or even so RPKI is not on the PAS2. Sorry, I will close down.
So yes,
but indeed, so it's a way, and it is a process, and it takes time. But yeah,
can there be a way to externally and independently verify the sustainability of any given system, like internet.nl does for security?
So there are some things you can do. So like one of the things that we do, we basically have to literally speak if someone asks, I want to have a green website, my organization or the organization I am part of, it's not mine, it's been around for way longer than me. When people say I want to have a green website, we ask for particular specific kinds of information, and we're asking for evidence of that. So like, can you demonstrate that you've accounted for the emissions this way? Can you point to, say, either the contracts you're using or the power contracts, or if you've purchased some kind of offsets, are there things you can point to? So there are things like that that's definitely out there. And this thing that it's weird in sustainability circles right now, people have just jumped straight from, oh, I guess the only way I could possibly check that something is where something is by using a blockchain, when like we've got like DNS, we've got names, we've got all this stuff, which is like specific, like if the internet works, this is a really, really good example of the fact that this makes it really easy to do these kind of lookups and this kind of stuff. So yeah, it will be really useful to have these things, but there is going to be, there's only so much that you can expose to the public, like your public IPs and your public network compared to like the rest of the iceberg. And for that kind of stuff, people usually end up resorting to independent third-party verification. And like this is something that you're seeing more organizations doing in this field now. But it's still it's a relatively small group, and a lot of the time it's very, very manual. There aren't particularly easy ways to expose this information or even set the requirements this stuff would be exposed, which is what's interesting with Salesforce. They basically said, we need you, unless you implement our sustainability API, we're not going to buy from you. And this is where it's kind of useful for groups like public sector to do this, because that sets it for every other issue. And specifically in the context of, say, climate, this is the information that pretty much everyone needs to have so they can understand the risks associated in their own supply chain.
Thank you very much. You have some.
Yeah. So if we still have time, I would like to.
One short remark, and then
No, because this just made me realize that I have a few web applications that are, of course, 100% internet.nl compliant, but they are also trying to get WCAG compliant. But that's much harder to do, but also much harder to show. And I've realized that the easier regardless of how hard it is to actually do to become sustainable and green website, the easier it is to show it, the better it will be to put on like a big, nice "we are green" thing on your on your product page. Point.
I mean, it may be, this is kind of web, so it's a few layers up from where we are, I suppose, right now. But literally just the last month, well, actually this month, I think, there was the beginning of the W3C setting up a new sustainable web group specifically to explore this stuff. So there is work here, and I feel comfortable talking about that part, but a few layers down at the network part, that's kind of different. And there are all these assumptions being made at the web level, which possibly don't hold true further down. There's an idea that the amount of energy use scales with the amount you download, for example, which I'm not sure is entirely true, but this is what's being used for regulation right now in lots of places, or for procurement, because they don't know any different, because the things they're reaching for are peer reviewed, but kind of top down assumptions, which is, as far as I'm aware, don't necessarily hold true if you're directly measuring like network infrastructure and stuff like that. And without that, you end up with silly regulation, because we're not able, I say we, but like people who are working with network, people don't have access to basically better information or better access. And one way you can do that is actually have something in the open to say, well, these are the things you might do from someone who's actually measuring this stuff or trying to implement some kind of sustainability related goals.
Thank you. We have to wrap up. Yeah. So thank you very much, Chris. So 2 questions actually. So is that a topic you want to work on? Is this a document or you want to document? And kind of is what is the forum you want to? So is RIPE the correct forum? RIPE meaning, or do you see other forums to develop this document and share it maybe later back to the RIPE community? Or
I'll be honest, because I'm not particularly, I mean, I work up and down the stack, and I'm comfortable with, like, say, Linux servers and web and stuff, but when it goes to network, I'm a little bit out of my depth. I would really appreciate having some people to speak to check the assumptions that we might be making, so that you do have, so the assumptions about, say, energy use, or what's stopping you use, say, reused hardware, stuff like that, what that might be. The fora that I imagine, I mean, as far as I'm aware, there are things like mailing lists that we could be using, and I'm comfortable using some tools like that. I've asked anyone to kind of just put some stuff onto this thing here, because I figured this is the thing that anyone with a laptop can access and put and drop links into there. But I would be very, very happy to speak to folks inside RIPE so that we can be sharing some of this stuff in future, because this is not my domain really, and I know that there are assumptions being made elsewhere which might not necessarily be true, and I don't know who to point to at the moment.
Okay, thank you. I think there's some interest in the room. Definitely, I see a couple of people nodding. We also will send out an email to the mailing list, at least, with this presentation and this specific link, to make it more visible also to people that did not attend the session, but can give input or read the what's written in the document. And let's I'm also looking at Jan as my co-chair. Maybe you can schedule another session here in the BCOP task force, or maybe one of the other working groups, but I think it's better here. Well, let's discuss it on another time. Yeah, in Belgrade. Okay, cool.
Just pointing to existing examples and a bunch of policies that people have used. They thought, okay, this is quite effective, or this was readable, would be an improvement on what you have right now, because people, the bar is so low.
Yeah, and I think it's so important topic for the future. Please go ahead, and then we have to close because people have also social.
Sander mentioned a number of documents, I think. I don't know if one of them was. Okay, because there was one that I seem to remember, possibly rather old, that was about CPE equipment for users. A fair amount of work, I think, has gone into that. It may be a bit old, perhaps 10 years old, but about this is the kind of kit, and it needs to have the functionality, and it needs to have various other things. That it might be useful to kind of be able to insert something into that, or use that as the basis, or, you know, as Sander mentioned, there's some other examples as well.
We just published 7.7. Yeah. So yeah,
So that document is for IPv6 requirements. And yes, it just got updated finally after a decade. So it's no longer old. But yeah, using that concept as the basis is definitely what I was thinking about. Yes, but I think it should be a separate document because this one is specifically for IPv6.
This here is a set of targets. If you want a problem to solve as an engineer, say, okay, how do you reduce emissions 7% year on year for the next 10 years? This is only problems with no solutions. And I'm speaking to a room full of people who are paid to come up with solutions. This stuff is probably one of the best places to look for problem statements that you might say, well, here's how we would solve this kind of problem or these kind of requirements. All right. I think that's it now. I'm going to hand it back to you.
Yeah, thank you. No, I'm very happy with the whole discussion, and we're running out of time. It's actually also a good sign that and we have to schedule another session and then or another presentation on this topic in another session. Thank you very much, Chris. Thank you very much, Sander, for your presentations. Wrapping up, yeah, we're already running out of time. Thank you, Jan. You have been, yeah, you're tired, and I completely understand. You are doing a lot of good work. Thank you all for your attendance and for your input and your discussion. And if you haven't subscribed to the BCOP mailing list, there's a RIPE BCOP mailing list that keeps update of, well, the presentations here. And if people want to share other ideas, you can discuss it over there or on the mailing list. Hopefully see you at the next RIPE meeting in Belgrade. Yeah. Thank you very much. Jan, some final words? No? Thank you. Thank you all. Have a pleasant evening.